In this video, you're going to learn how to develop a Spring Boot application using microservices architecture. This is going to be a highly practical tutorial, so to follow along, I expect you to have at least a basic understanding about Spring Boot and basic understanding of what microservices architecture is and why you use them. This video is sponsored by Lumigo. Lumigo's troubleshooting and observability platform autonomously deploys OpenTelemetry in under 5 minutes with a single click, automatically capturing and contextualizing all of the data developers need to troubleshoot microservices issues in production. Lumigo is the only distributed tracing platform that enriches traces with complete in-context request and response payloads and correlates them to the relevant logs and metrics, enabling developers to resolve issues up to 80% faster. To know more about Lumigo, check out the link in the description section. So we'll be building a simple online shop application using microservices architectural patterns, using mainly Spring Boot and the latest Spring Cloud technologies. So we're going to cover all the interesting and important architectural patterns like service discovery, centralized configuration, distributed tracing, event-driven architecture, centralized logging, and much more. If you're not aware of what are these fancy terms, don't worry, we'll cover this in the tutorial. So before going ahead and implementing our microservices, let's take a moment to understand what is Spring Cloud. Spring Cloud is a project under the Spring Projects ecosystem. So it's another project like Spring Boot, Spring Data, Spring Security, or any other Spring project, but it mainly concentrates on helping us to build the reliable and robust microservices. It provides us a common set of design patterns which are implemented already, like the configuration management, service discovery, circuit breakers. So, and there are many other patterns which are implemented into the Spring Cloud project. We'll have a look at it in depth in this tutorial. You don't need to worry about that. We are going to use Spring Cloud to mainly develop the microservices. That's what you need to know. As you understood what is Spring Cloud, now let's go ahead and check what are the different services we're going to build in this tutorial. So the first service we're going to build is going to be a product service. So this service provides us an API to create and view products in our application. And it also acts like a product catalog where we can view all the products inside our application. So the next service is going to be an order service where we can order the products which are available in the app. And after that, we are also going to have an inventory service where the order service can check if the product is in stock or not before submitting the order. And lastly, we're also going to have a notification service where we can send email notifications after the order is placed successfully. And out of these 4 services, we are going to mainly have the order service, inventory service, and the notification service talk to each other. We mainly have the asynchronous and as well as synchronous communication as part of these 3 services. So now let's go ahead and check the overall solution architecture of our project. All right, so this is how the solution architecture diagram looks like. So mainly we are going to first look at the services we are developing. So we have the product service, which is talking to MongoDB, and an order service, which is talking to the MySQL database. And the inventory service is also talking to the MySQL database to store all the inventory information. And we have the notification service, which is like a stateless service, which it does not have any database, but it is responsible to just send out notifications to the users. If you're talking about a microservice architecture, you cannot call it as a microservice architecture if the services are not talking with each other, right? So here the order service is talking to the inventory service. So whenever an order is being placed, we'll first check whether the inventory is available or not by making a synchronous communication. And after that, we are also going to send out the notification once the order is being placed successfully. So for that, we are going to make an asynchronous communication with the notification service. If you're not sure what is synchronous and asynchronous communication, don't worry, we will also cover this in detail in this tutorial. For asynchronous communication, we are going to use Kafka. And coming to the outside world, we have the surrounding services which enable the microservice architecture. We have the API gateway, which acts like a gateway to send the requests from the user to different services. So for example, if I am a user and I want to communicate with the product service, I don't want to give the host name or the IP address of the product service to communicate with it, right? So the API gateway acts as like a gatekeeper to send out the requests to different services we like. So our applications is also being secured using the authorization server called as Keycloak. We'll also have a look at it in the detail. And other than that, we also have different services like Eureka. And we are going to use Grafana stack to implement observability. We are going to use Grafana Loki to aggregate the logs from our microservices, and we are going to view these logs in Grafana using Grafana Loki. We are going to use Grafana Tempo for distributed tracing, and we are going to use Prometheus to collect metrics, and finally we are going to use Grafana to visualize the metrics of our applications, of our services in a beautiful dashboard. Finally, we are going to containerize all the services using Docker, and we'll run all the Docker containers first using Docker Compose, and then we will migrate this Docker Compose workloads to Kubernetes. And again, don't be overwhelmed with all these details. We will have a look at each of them in detail in this tutorial. Alright, so if you'll have a look at the logical architecture of each of the services, we have a controller, service, and a repository layer for each of the services. So in the controller layer, we will be receiving the HTTP request from the clients, and from there the business logic is being executed on the service layer. And in some of the services, we are also going to communicate with a message queue. So that's why we have this message queue communication, and mainly in the order service, we are going to make use of the message queue and also the notification service. And after that, we are also going to store the information in the database. So for that, we are also going to maintain a repository layer, which mainly talks to the database. So we have MySQL and also the MongoDB database. So both of them will follow the same pattern. We'll have a repository which talks to the database. This is how almost all the services are being structured. So we'll follow the same process for all the services we have. All right, so now it's time to coding. The first thing I'm going to do is to create the product service project. I'm going to open start.spring.io project website. This is where we usually generate the starter for all our projects. So first of all, for the project, I'm going to create a Maven project. I'm going to select Maven as the build tool. And of course, we are going to use Java as a language. And for the Spring Boot version, as of creating this tutorial, the latest Spring Boot version is 3.2.4. So I'm going to select that version. For the group ID, I'm going to type in as com.techie.microservices. And for artifact ID, I'm going to provide it as product service. And the description is going to be called as product service. You can type any description you like. The package name, I'm going to just provide as com.techie microservices and product. I'm going to remove the service here. I'm going to choose the packaging type as var, and I'm going to choose the Java version as Java 21. Coming to the dependencies, first of all, I'm going to add the dependency of Lombok, and next we are going to add the dependency for Spring Web, as we are going to create a REST API. Next, we have the Spring Data MongoDB, as we are going to interact with the MongoDB database for the product service. And lastly, we are going to add the test containers dependencies, because we are going to also write integration tests for the product service. So once this is done, I'm going to click on the generate button. This will download a zip file to your machine. And the next thing you have to do is unzip the zip file and open it in your favorite IDE. Alright, so before we go ahead and start coding, we need to have Docker installed on your machine. So for that, just search for Docker in Google, and I'm going to click on the icon Get Docker. And here, based on my operating system, I'm going to download Docker. I'm going to choose Docker Desktop for Mac, as I'm running on a Mac machine. So if you're using Windows, you can just use the Docker Desktop for Windows, or if you're using Linux, of course, you can use Docker Desktop for Linux. So once this is installed, we will first go ahead and see how to download MongoDB using Docker. And specifically, we'll be using Docker Compose to download the MongoDB database to our machine. All right, so now I'm inside the location where the product service source code is downloaded. So first I'm going to unzip this file, and after that I'm going to open this code in my IntelliJ IDEA. So I'm going to click on the open button here in the IntelliJ, and then select the product service folder, and I'm going to trust this project, And once the project is loaded inside the IDE, I'm going to first make sure that the project is downloaded correctly by running a maven command. So for that, I'm going to click on this maven icon to the right side of the IDE, and I'm going to click on this execute maven goal button, and I'm going to run the command maven clean verify. So this will first download the necessary dependencies to our local machine, and then we'll start to build the project. And as you can see, the project is built successfully. That's good. So now let's go ahead and download the MongoDB database as we told before. So for that, I need to create a Docker Compose file. So for that, I'm just going to right click on the product service root project, and I'm going to click on new file, and I'm going to create a file named Docker compose.yaml, and here I'm going to create the necessary code to create the configuration and create the necessary configuration to download MongoDB. So for the Docker Compose file, I need to first start with the version of the Docker Compose file. I'm going to use the version 4, and after that I'm going to add the object for services. And for the service, I'm going to create the service with name MongoDB. So I'm going to create the service name as MongoDB. And here you can see that our GitHub Copilot is already suggesting me the necessary configuration for MongoDB Docker Compose. So I'm just going to make use of that. But I don't want to use this configuration. I want to change this configuration a little bit. So for image field, I'm going to use the Docker image called Mongo, but I don't want to use the latest tag. I want to use a very specific tag. So the tag is going to be 7.0.5. Select this tag, and the container name, I'm going to leave this as MongoDB, and I'm going to expose this Mongo container on the local port 27017, and the MongoDB itself will be running on the port 27077 inside the container. And also I need to add another object called as environment, where I'm going to add the MongoDB username and password for authentication. So I'm going to add the property MongoDB Mongo initDB root username and Mongo initDB root password. I'm just going to change the password to password. I'm also going to add another parameter environment variable here called Mongo initDB database, and I'm going to call the database as product service. And lastly, as MongoDB is running inside a container, whenever you stop the container, all the data you have inside the container will be lost. So for this reason, we have to provide a volume folder where the Docker container stores all the necessary files or data inside our file system. So after all this configuration is added, I'm just going to open the terminal, and I'm going to run the command docker compose up -d. So the -d will start the Docker Compose in the background, so we don't see all the logs. So if I just press enter, you can see that the Docker Compose is running, and the MongoDB container is started automatically. So for me, it's almost instantaneous because I have the MongoDB image in my local Docker registry. But if you're running this command for the first time, you can expect a small delay because the Docker Compose will download the MongoDB image from the Docker registry, and it may take a minute or two depending on your network speed and the machine you're running. The first thing we have to do is to configure the MongoDB URI inside the application.properties file. I'm going to give the database name as product service. If you want a detailed explanation on how to configure Spring Boot with MongoDB, have a look at the Spring Boot MongoDB playlist in my channel. You can also find this in the description section. After that, we have to create our domain model, which is the product class. So let's create a package called as model. And inside the package, I am going to create a class called as product. To define this product as a MongoDB document, I'm going to add the document annotation to the top of the product class. And I'm also going to add the Lombok annotations to generate the getter setter methods and the constructors. Inside the class, I'm going to create the required fields, which are ID, name, description and price. And to the field ID, I'm going to add the ID annotation from Spring Data to specify that this is a unique identifier for our product. And to store this product inside the database, we have to create a Spring Data repository. For that, I'm going to create a package called as repository, and inside this package, I'm going to create an interface called as product repository. And I'm going to extend this interface with the Spring Data MongoDB's Mongo repository interface. And I'm going to pass in the generic argument as product. And for the identifier, I'm going to pass a string as the second generic argument, because this is the type of the ID field in our product class. Now it's time to create the controller class. So for that, I'm going to create a package called as controller. And inside the package, I'm going to create a class called as product controller. As we are exposing a REST API, we have to add the REST controller annotation to the top of this class, and also the request mapping annotation with value /API/product. So now let's create the API to create the products. So for that, I'm going to create a method called as public void create product. And this method, as this creates some products, we are going to send a post request for this method. So I'm going to add the post mapping annotation, and as a response, we are going to type in response status, and we are going to send out the HTTP status as created. So I'm going to select HTTP status created, right? And as a request body, we are going to receive the product information. For that, we are going to create a new class called as product request. I'm going to use this product request. So instead of using a class, by the way, as we are using Java 21, instead of using a class, we can also use a record type. So for that, I'm just going to create a record called as product request, and this is going to be inside a package called as DTO. So I'm going to select the destination package as DTO, and I'm going to click on OK. So now we have the product request record. So this product request takes in almost the same values as the product class. So we need an ID, name, description, and a price. So let's also type these fields inside the record. So I want to have a string ID, I want to have a name, description, and a price. So the price is going to be of type big decimal. So after creating this record, now we can go back to our controller. And here we need to write the business logic to create the product. So I can directly use the repository, access the repository from the controller itself. But this is not a good practice, because usually all the business logic should be inside a service class and inside the service layer. So for that reason, I'm going to create a new class called as product service. So I'm just going to right click on the main package, and I'm going to create a new class called product service. And I want to create this inside a separate package called as service. So if you add also the package name while creating the class in IntelliJ, like for example service.product service, IntelliJ will automatically create this product service class inside the service package, right? So let's see that. So I'm going to select class, and I'm going to press enter, and you can see that the product service class is automatically created inside the service package. So now I'm going to add an annotation called as service, as this is a service class. And for this, inside the service class, I'm going to first inject the product repository interface. So I'm going to write private final product repository. And now IntelliJ is complaining that we need to add a constructor for product repository and initialize the product repository inside the constructor. So we can do that using a Lombok annotation. Either we can create the constructor manually like this, or we can do that using Lombok. So I'm using, so I want to use Lombok for this, because then you don't need to write this boilerplate code. So we can do that by adding this required args constructor annotation. And now inside the product service, I'm going to create, I'm going to add code to create the product. So here GitHub Copilot is already automatically suggesting me the code. So let's use the code here, and then I will explain to you what is happening inside this method. So now you can see that we are taking the product request record as the input argument for this input parameter for this method. So I'm just going to import the product request DTO, and here we are creating the product class, the object for product class, and we are providing the name and we are mapping the name coming from product request to the name field of the product class. So here, instead of writing product request.getName, what we have to do is we have to write product request.name, because to access the fields inside a record, you can directly access them using the field name. You don't need to write getters and setters for record. So that is one of the advantages you have by using records, right? So I can do the same thing also for the description. So it's going to be product request dot description and product request dot price. So now we have a logic to create the product object from the product request. Now we have the code to save the product to the product repository by adding this product repository dot save method. And after the object is saved to the repository, I'm just going to add a log statement like log.info product created successfully. So this log variable is not available for us. We can use the SLF4j annotation from Lombok to create a log variable so that we can use the logger to add the log statements. So now we can go back to the product controller, and I'm going to inject the product service into the product controller. So for that, I'm just going to add required args annotation on top of the product controller, and I'm going to define the product service variable. So I'm just going to import the product service, and I'm going to take the product service variable, and I'm going to call the create product method inside the product controller. So now we have our endpoint ready. So we have a controller that takes in the request body of type product request, and is going to pass it to the create product method of the product service. And the create product method is first creating an object by mapping the fields from the product request record, and then finally saving it to the product repository. So the next thing we are going to do is to return the product we have created from this method. So I'm going to add return product to the end of the method, and I'm going to change the return type from void to product. And let's go back to the product controller and also add a return statement and add the return type as product. I'm adding this product as a return type because I want to have some response back whenever I make a call for post call to create the product. I want to see a response of the product I've created, right? So this usually includes the details, right? So I want to see that as a confirmation that the product really is saved. So that's why I'm changing the return type to product. So the next thing I'm going to do is to create another endpoint to read all the products. So for that, I'm just going to create a get mapping, and I'm going to add the response status annotation, and the response status for this endpoint is going to be 200 HTTP status OK, and this method is going to be public. It's going to be a list of products. I'm going to import the list class from Java util package, and this method is going to be called as getAllProducts. And here I'm going to use this product service dot getAllProducts, and this getAllProducts method does not exist yet in product service. So I'm going to create this method inside the product service, and here I'm just going to call product repository dot find all, and then I can just return all the products which are present in the database. One improvement I can do here is, instead of returning directly the product class, it's actually our domain class. What we can do is we can create another DTO called as maybe product response, and we will map product object to the product response object, and then we can return that product response as a return type. So let's go ahead and do that. I'm going to right click on DTO package, and I'm going to create a new record again, and I'm going to call this as product response. And this product response contains the ID, name, description, and the field price, and this price is going to be of type big decimal, right? So let's go back, and here instead of returning a product object, I'm going to return a product response object, and what I have to do now is to map this list of product objects to list of product response. So for that, I'm just going to add .stream map, and I'm going to map this to the product response object. So for that, I'm just going to create a new product response object, and I'm going to call this product.getID, product.getName, product.getDescription, product.getPrice, and at the end I'm going to call toList, so that we get a list of product response as a return type. So now let's go back to the getAllProducts, and here we have to change the return type of the getAllProducts from list of product to product response. So now let's also refactor the create product endpoint to return the product response instead of the product class. So I'm just going to change the return type to product response. Let's also go to the create product method and change the return type to product response. And here also let's copy the same object here. Let's copy the same code here and paste it here inside the create product method. All right, so now it's time to test our implementation. So first I'm going to start the product service application. So let's open the product service application, and I'm going to start the application in the debug mode. And IntelliJ is asking me to enable the annotation processing. I'm just going to click on the button, and now you can see that the application has started successfully on the port 8080. So now to test our two endpoints, I'm going to use Postman. So the first thing I'm going to do is I'm going to create a post call for the URL http localhost 8080/API/product, and I'm going to provide the JSON body. So the name is going to be iPhone 15. The description is going to be some text about iPhone 15, and also I'm providing the price, right? So let's click on the send button and see what is the response we'll get. Okay, looks like we are getting an error. Let's see what is the problem. So let's go back, and okay, you can see that we are getting an unauthorized exception, because if you open the Docker Compose file, we are providing a username and password for the MongoDB, but in our application.properties file, we are not providing any authentication information, right? So let's change the MongoDB URI to include the authentication. So we can enhance the MongoDB URI by providing the username and password. So after MongoDB / just before the local host, I'm going to add the username as root. I'm going to add a colon and then add the password as password, and I'm going to add the symbol @ right? And to the end, I'm also going to add the auth source as admin. Okay, because the username and password is going to be created in the admin collection, and by adding this parameter, we are asking Mongo to authenticate to take this username and password and authenticate it against the admin database. So now let's restart our application, and then let's try to call the endpoint again. All right, so now you can see that the create is successful and we got back the response. This is the manual test. Well, let's create also an integration test, an automated test, where we can run our tests during the build, right? So for that, I'm just going to open the product service application test class, and here we are going to write integration test for our two endpoints, the create endpoint and the read all products endpoint. So for that, we are going to make use of test containers. If you're not aware of test containers, it is a library which will spin up Docker container for us. We can create a Docker container for whatever library we want, whatever database or message queue we want. As we are using MongoDB, we can use a real MongoDB for our test. Instead of using some embedded MongoDB, we can make use of a real MongoDB with the help of test containers, and we can spin up this test container. We can spin up this Docker container during our test process, and we can connect to this containers as part of our tests. So I opened the testcontainers.com website, and here you can see that test containers is an open source framework for providing throwaway lightweight instances of databases, message brokers, web browsers, etc. Right? You can run about anything that can run in a Docker container using the test containers. So it provides out-of-the-box support to many modules. So if I click on modules here, you can see that there are many different kinds of modules which are supported by test containers. So if you want to run integration tests against Elasticsearch or maybe Kafka or RabbitMQ, everything is available through the test containers module, so you can make use of it. For our test, we are going to make use of the MongoDB module. So if we go back to a project and click on the pom.xml, you can see that we have already added by default, as we already selected the test containers option in the start in the Spring Initializer website. We already got this dependency out of the box, so we don't need to add any other dependencies, any other external dependencies. So we can go ahead and start writing our tests. So let's go back to the product service application test class, and here I'm going to first change some configuration inside the Spring Boot test annotation. I'm going to provide the web environment value as random port, because whenever I am running the integration test, the test will spin up the application, and by default it will run on port 8080, and I don't want to do that, right? I want to run it on a random port because it can conflict with the existing processes which is running. For this reason, I'm going to ask Spring Boot to run this test in a random port. So for that, I'm just going to provide the web environment as random port, and inside the test, I'm going to rename this test of context load as should create product. And this test is supposed to actually create the product, and then we will verify if the product is created successfully or not. So the next thing I'm going to do is to initialize a MongoDB test container. So I can do that by typing static MongoDB container and new MongoDB container, and I'm going to provide the Docker image name. So the Docker image name is going to be Mongo, as we saw before in the Docker compose.yaml file. We have provided the image name as Mongo and the tag as 7.0.5, right? So I'm just going to copy this and use the same configuration also here. So now I'm going to add one dependency to the pom.xml, mainly to make REST calls from our integration test. So for that, I'm just going to go to the pom.xml file, and I'm going to, inside the dependencies tag, I'm going to add a dependency called as rest assured. So for that, I'm just going to type the group ID as io.rest assured, and artifact ID should be rest assured, and the version of this dependency as of now, the latest version is 5.3.2. so I'm going to add this dependency and click on the Maven icon to the top right corner, so that Maven will download this dependency to my local repository. So once this is done, I'm going to go back to the test class. So here what I'm going to do is I'm going to set up rest assured inside this test. So for that, I'm going to add a before each annotation, and I'm going to create a method called as setup. And here I'm going to, so here first I'm going to define the base URI of our application, base URI where our application will be running. So I'm going to define rest assured dot base URI equals to HTTP localhost I'm not going to use 8080 because as we are using a random port, we have to dynamically check which port our application is running. So for now, I'm just going to define the base URI as localhost, and I'm going to define the rest assured port. And to define the port, I'm just going to add one annotation called as local server port, and I'm going to define private integer port. So what this annotation will do is whenever the application is running, it will inject the port on which the application is running into this variable, right? So now I'm going to configure rest assured to use this port. So I'm just going to call rest assured.port is equal to the port integer variable. And once this is done, the configuration to use rest assured is completed. Now we have to also start our MongoDB test containers before running the test. So for that, I'm just going to add a static block, and inside the static block, I'm going to add MongoDB container dot start. And one last thing we have to do is whenever the application, if you open the application.properties, you can see that we are setting the MongoDB URI. We are setting the host name as localhost and the port as 27017. We also need to define this property while running the test. Test containers comes with an annotation which will dynamically assign the MongoDB host and port while running the application. So we can do that by adding this service connection annotation. So by adding this, you don't need to manually specify the MongoDB URI. Spring Boot will automatically inject the relevant URI details for our application.properties for MongoDB. Okay, so now we are ready to create our test. So first of all, I'm going to create a product. For this, I need to have access to the request body. So I can just go to the Postman request we have done before, and I'm just going to copy this request. I'm just going to reuse this request body, and I'm going to define this inside this test class. So it's going to be string request body equals, and here I'm going to make use of multi-line strings, which was introduced in Java 14, I guess. And here you can define the multi-line string, and I'm just going to paste this with the JSON. So now we have a request body ready. Now it's time to call our endpoint in the product controller. So we have to call the /API/product endpoint with HTTP method as post. So for that, I'm just going to type in rest assured dot given dot content type is going to be application JSON, and here I'm going to type in body as a string, and this is going to be a request body, and I'm going to type when I'm doing a post request. So for that, I can type in post /API/product, and I can write then I want to have the status code as 201. I want to also assert the fields inside the response body by adding some matchers. So I'm going to type in .body, and I want to check that the ID field is not null. So I can do that by adding matchers dot not null value, and body again I'm going to check the name field is equals to iPhone 15. So I'm going to use matchers from Hamcrest, and using the equal to method, I'm just going to check if the name field is iPhone 15 and the description is iPhone and I'm also going to assert the description, and finally I'm also going to assert the price. So let's go ahead and run this test and see if our test is successful or not. All right, that's great. You can see that we see the logs product is created successfully, and if you observe the logs inside the product service application test, you can see that we can see the logs. Our test is connecting to the Docker, and as I already have the MongoDB image on my local machine, it's actually just started the test instantly. But if you don't have this Docker image, then the test will first download the Docker image and then we'll run the test. Alright, so now it's time to create our second microservice, that is the order service. So for that, I'm going to open the website start.spring.io, and here, as we did for product service, we're going to select the Maven project, and we are going to select the latest Spring Boot version. The group ID is going to be com.techie.microservices. Artifact ID is going to be order service. And let's give the package name as com.techie microservices.order. I will leave the packaging as jar, and I'm going to select Java version as Java 21. Coming to the dependencies, I'm going to add the dependency for Spring Web, and I'm going to also add dependency for Lombok. I'm going to add the dependency for Spring Data JPA. As we are using a relational database, we are going to use Spring Data JPA with Hibernate. And for the database driver, as we are using MySQL, I'm going to choose the MySQL JDBC driver dependency. And I'm also going to add the dependency for test containers, because we are also going to write integration test for the order service. And finally, we are going to also add a dependency called as Flyway to run database migrations. We will discuss what is database migrations and why we have to use this in the coming sections. So once this is done, just click on generate and the source code will be downloaded to your machine. Alright, so I opened the order service source code in IntelliJ IDEA, and the first thing I'm going to do is to download MySQL to our machine using Docker Compose. So for that, I'm just going to right click on the root folder, and I'm going to create a file called as docker compose.yaml. Similarly of how we did in the product service, I'm going to create a version as 4, and here I'm going to create an object called as services, and I'm going to create a service for MySQL. And here you can see that GitHub Copilot is automatically suggesting me the necessary Docker Compose configuration. So let's use that and make some changes. So for the MySQL image, we want to use the same MySQL image, but I want to use a different tag, so the different version. So I'm going to use the version 8.3.0, and the container name, I'm going to leave it as MySQL. This restart field, so I'm going to remove this. I'm also going to use the MySQL root password environment variables. So I'm going to define this as MySQL, and I don't need these 3 environment variables, so I'm going to remove them. And the port, I'm going to leave it as 3306, because this is the default port where MySQL will be running. And the volumes is going to be the MySQL folder. So whatever metadata which is created by MySQL database will be stored inside the MySQL folder in the order service project. So now let's go ahead and start up the container and see if this Docker Compose configuration is working or not. So I'm going to open the terminal inside the same folder as the Docker Compose file, and I'm going to type the command docker compose up -d. And you can see that as I already have this particular version of MySQL Docker image inside my local registry, it's directly went ahead and started the container. And if you don't have this image, you can expect a slight delay, because Docker will first download this image and then will start up the container. So the next step is to configure MySQL in our Spring Boot project. So for that, I'm going to open source main resources folder, and I'm going to open the application.properties file. And here I'm going to type in the property spring data source.url. So this is going to be the JDBC URL of our MySQL database. So I'm going to use JDBC MySQL localhost 3306, and I'm going to define the name of the database as order_service. I'm going to define spring data source dot username as root and spring data source password as MySQL. So this is the same value we have defined here inside the Docker Compose file. So I think we have one typo here, so it's going to be spring data source dot username. So the next thing I want to do is I want to set the Hibernate DDL auto property. So this is going to be none. So this will disable the DDL handling for Hibernate. We are doing this because we want to do all the database migrations through Flyway. And the last property I want to add is I want to run the server on the port 8081, because by default Spring Boot will run the application on port 8080, and we already have the product service running on that port. So we want to run the order service on the port 8081. All right. So now let's go ahead and try to start the application and see if we are able to connect our application to the MongoDB or not, to MySQL database or not. So I'm just going to run the application on the debug mode. All right, so we are getting an error. Let's see what is the issue. So we see Java SQL syntax error exception, unknown database order service. And problem is Hibernate is not able to find the database with name order service inside our MySQL database instance. So to fix this issue, we can either create the database manually by connecting to the MySQL database using software like MySQL Workbench. So here, if you go to the mysql.com/products/workbench URL, you can download this MySQL Workbench IDE, where you can write queries and then view the database. Either you can download this and you can create the database manually, or we can directly write SQL script and add this SQL script to the Docker Compose file, so that this SQL script will be executed automatically during the startup of the MySQL database container, right? So for that, let's create a new folder called as Docker inside the order service. And in here, I'm going to create another folder called MySQL. And in here, I'm going to create a new file called as init.sql. So here I have to write the SQL command to create the database. So I'm going to write create database if not exists order underscore service. So we want to create the order service. So I'm just going to write the create database command to create the order service table, order service database. So now let's enhance the Docker Compose file to add this init.sql file into the container which is running the MySQL database. So for that, I can add a new line here, and I can reference the Docker MySQL folder and the init.sql file, and I want this file to be added to the /docker entry point -initdb.d/init.sql file. So the Docker entry point is the command which will be executed whenever the MongoDB MySQL database container will be running, right? So in this way, our init.sql file will be executed whenever the MySQL database container is starting up. So after adding this command, what I can do is I can run the Docker Compose one more time, Docker Compose up -d, and you can see that the MySQL database is running. Now, if we can verify if our command is executed or not by opening Docker. So if you open the Docker dashboard, here you can see the order service which is running. So I'm going to expand the menu here, and I'm going to click on MySQL. And if you check the logs, you don't see anywhere that the SQL file is executed, right? That's because our volume actually is already created. So we have to first delete this volume to make sure that the data is initialized correctly. So I'm going to add again Docker Compose down. I'm going to stop the MySQL container, and once this is done, I'm going to run again Docker Compose up -d. So if you open the MySQL container one more time, you can see some more logs, and in here you can see that the entry point Docker entry point initdb.d/init.sql is running, and the initialization has started, right? So if you now open the MySQL Workbench, so make sure you download this MySQL Workbench to actually, make sure you download this MySQL Workbench based on your operating system to make sure that you can view the database and then run queries on the database. So I'm going to open the MySQL Workbench, and in here I'm going to create a new connection. I'm going to provide the host name. I'll leave the host name as it is, which is pointing to localhost. I'm going to provide the port as 3306. the root username, it's going to be root, and I'm going to provide the password, whatever password we have added inside the Docker Compose file. Let's add it here and click on OK. So once this is done, you can test your connection test your connection. I've already created my connection before, so I'm just going to click on this so that the connection will be established to my MySQL database. So once the connection is established, you can go to the schemas tab, and in here you can see that the order service is created successfully. You can see the order service database. Now let's go back to our application. So order service application, and run the application one more time, and you can see that the application is starting without any errors. So now let's go ahead and create our model class. So for that, I'm going to click on the root package, and I'm going to add a new package called as model, and in here I'm going to create a new entity called as order, right? So as this is going to be a Spring Data JPA entity, I'm going to add the entity annotation from jakarta.persistence package, and I'm going to add the table annotation, and I'm going to provide the name of this table as t_orders. So I'm going to add a getter annotation, a setter, and I'm going to also add an allogs constructor and noargs constructor. Coming to the fields inside the order class, so the first field I'm going to have is like an ID, which is going to be a unique identifier, which is for our primary key, and I'm going to add the generated value annotation, which is a strategy type of identity, and this is going to be a long ID field, which is pointing to our primary key inside our order table. The next field is going to be an order number, so it's going to be of type string. We also have a field called as SKU code. We'll have a field called as price, which is going to be of type big decimal, and the last field we're going to have is a type of integer called as quantity. So we are going to maintain a very minimum data model because we'll be mainly concentrating on the microservices architecture. That's why our services doesn't have any huge business logic. So I'm going to keep everything very simple. So we just need this one model field. So the next thing we are going to need is a repository to store this model. So I'm going to click on new Java class, and this time, instead of creating the package manually, what I'm going to do is I'm going to type in the package name inside the Java class itself, and the package name is going to be repository, followed by the repository I'm going to create. So this is going to be order repository, and this is going to be an interface, not a class. So I'm just going to press enter, and you can see that this interface is automatically created inside the repository package. So this order repository is going to be extending JPA repository, and this JPA repository is for the model for a class order, and this order class contains a primary key of type long. So we have our order repository, and the next thing we are going to create is like order service. So I'm going to do the same thing here. I'm going to create a package called as service.order service, and this order service is going to have the service annotation from Spring Boot, and I'm going to, inside this order service, I'm going to create a method called as place order. So I'm going to be public void place order, and this place order method will be taking a method, will be taking a type, a parameter of type order request. So this order request, we don't have it yet. So let's create this order request as a record, Java record. And this is going to be in a package called as DTO. And in this order request, the first field is going to be ID. So this is going to be long ID. The next field is going to be order number. The next field is going to be SKU code, followed by the price. And lastly, we have our field called quantity. So this is going to be a plain old Java record. And let's go back to the order service. And in here, what we have to do is we have to first map order request to order object, and then save order to order repository, right? So that's what we want to do inside the place order method. So to map the order request to order object, I have to first create the order object. So first I have to create the order object. So this order is going to be from the model package equals new order, and I'm going to set order dot set order number as a UUID dot random UUID dot toString, because we need to create a unique order number. And the next one is going to be the price. So I'm going to map the price directly from the order request. So I'm going to type in order request dot price, and in here I'm going to next map the field called SKU code. So there's going to be order request dot SKU code. The next field is going to be the quantity. So order dot set quantity should be from order request dot quantity field. So this is all the fields we have for the order object. Next we have to save this order object to the order repository. So for that we need to inject the order repository into the order service class. Let's do that by adding private final order repository, and we need to add a constructor for this order repository. So let's add the required args constructor from Wiremock, and let's come inside this place order method, and in here I'm going to type order repository dot save order. So let's remove this comments, so not so useful. So now we have the place order method ready inside the order service. The only thing which is remaining is to create the order controller, order rest controller, where we have the REST endpoint where our clients can call. So before we go ahead and just remove the unused imports, and now I'm going to create a new Java class in a package called as controller, and the name of the class is going to be order controller. And on top of this class I'm going to add the REST controller annotation, and with the request mapping annotation as /API/order, and let's also add the required args constructor annotation, as we are going to inject the order service. And the endpoint we are going to create is going to be a post mapping endpoint, and this is going to send back a response status dot created, and the name of the method is going to be public string place order, and this is going to take a request body of type order request, and inside this method I'm going to call order service dot place order, and I'm going to pass in order request as the argument, and I'm just going to return a string called as order placed successful. So this is all we need to create the endpoint to place the order. So before we go ahead and start our application and do the test, we need to do one last thing. So if you open the application.properties file, you saw that we saw that the Hibernate DDL auto property, we have set it as none. If we set it as create, what it will do is it will create the schema and destroy the previous data, and it will also create all the necessary database tables automatically. But we won't want to use this option usually on production grade environments. So what we can do instead is we can set the disable DDL handling option by choosing the option none, and we can create the tables and do all the database migrations using a special library called as Flyway. So the main advantages of using Flyway is it helps us to version control our database so that we can run the migrations easily. So imagine that I have one database table called order, and like some months down the line I want to add a new field inside this table. So what I can do is, what I will usually do is I will add this field inside my Java class, and the migration and updation of the database table usually happens as part of Hibernate, right? And if there is something went wrong while creating this new additional field, there is no easy way to roll the database back to its previous state, right? By using the Flyway database migration tools, we have the option to migrate a particular database by writing our own SQL queries, and we also have the option to roll back to any previous versions. We also have another library called as Liquibase, which is widely used database migration tools. So in our project we'll be using Flyway, and we have already added the necessary dependencies inside the pom.xml. So if I just scroll to the pom.xml of order service, you can see that we have the dependencies Flyway core and Flyway MySQL to add the support for MySQL for Flyway. And our database migration scripts will usually be stored inside the dp/migration folder under resources. So Flyway, whenever it's initialized, when it's running, it will look for the database migration scripts inside the db/migration folder. Before starting the application, as I mentioned before, we have to create the database table for the order entity. So for that, I'm just going to click on the db.migration folder and just going to click on new file. And in here, we have to follow a specific naming convention whenever we are writing migration scripts for Flyway. So the naming convention is going to be, it should start with a capital V for version and a unique incremental number. So for example, I can write V1, and it should have the prefix symbols as 2 underscores, right? So have V1 underscore and underscore, and then you can have the name of your file. So it's going to be init.sql. So in here, you can write your database migration scripts. So for our use case, I already have one SQL query ready. So what I'm going to do is I'm going to just paste this SQL query. And what we're doing here is we are creating a table called as t_orders. And inside this table, we first have the ID field, which is like a primary key, which is going to be auto incrementing. And next field we have is a order number, which is like a varchar, and the SKU code, which is going to be another varchar, and we have the another field called as price and quantity, and of course we have added the ID as also as a primary key. So we want this table to be executed for the first time when we are running the Flyway migrations, when we are running our application. If we just go ahead and run the application, and I want to stop and rerun. So if you observe the logs, you can see that the current version of the schema order service is empty, and the Flyway recognized that there is one migration script to be executed. So it has actually resolved the name of the migration script as the number of the migration script as 1 and the name as init. So it started executing our migration script. You can see that log successfully applied one migration to schema order service, now at version V1. So our database is now at version V1. And if we want to add one more field, what I can do is I can right click on DB migration, and I can click on a new file. This time I have to create a new file called as v2 __ add column.sql, and I can write my logic to update or add some column. So in this way, we can have database migrations in a specific order, and we have all the changes in our database version, just like we version our source code using Git. We can also version our database changes using Flyway, right? So for now, we don't need this SQL file. We can just stay here on version 1. So another question you may have is, if I rerun the application, what happens? Will this file be executed again? Let's see if what is the case. So it's I've restarted the application, and you can see that Flyway has successfully validated one migration. It already maintains the state of all the migrations which were executed before. So it saw that the current version of schema is 1, so that's why it skipped migrating the version 1 of the migration script one more time, right? So if I add version 2, then it will start executing, but as version 1 is already executed, Flyway is smart enough to skip this particular migration script, and you can see the logs that schema order service is up to date and no migration necessary. So our application startup is going to continue, and this is how you usually use Flyway. So let's verify if the database tables are created successfully or not. So for that, I'm going to open MySQL Workbench, and in here I'm going to select the order service schema, and I'm going to right click and click on refresh all. And now you can see that we have some tables. So the first table is the Flyway schema history. So if I just right click and select the select rows option, you can see that it has saved the name of the migration script. So it's v1 underscore init.sql. So it's maintaining all the history of the scripts which are executed inside the flybase schema history table. And now we have, and then we have the t_orders table, which we created as part of the migration script. And we have our all the columns we added inside the SQL script. This is fine. So now let's go ahead and open Postman. So now I've opened Postman to test the REST endpoint to place the order. So for that, I'm just going to add the request URL has HTTP localhost 8081/API/order. The request method is going to be post, and we have the JSON with SKU code as -15, price as 1000, and I'm going to put the quantity for now as 1, and I'm going to click on send, and you can see that we got back the response, order placed successfully. Let's verify if the order is really saved to our MySQL database or not. So I'm going to again open MySQL Workbench, and I'm going to right click on t_orders table. I'm going to select the rows, and indeed you can see that the entry is really saved to the t_orders table. That's good. This is fine. We have implemented the REST endpoint and tested it manually. So now let's go ahead and write some integration tests. In the previous video, in the previous part, I have showed you how to write one integration test for the product service. So for this part, I'm going to refer to you to the written tutorial of the Spring Boot Microservices tutorial series. So here, if you search for integration tests for order service, you can see that I have the necessary code for the integration test and how to write the integration test for the order service. So you can refer to this blog post if you are stuck. So first, I suggest you to write the integration test on your own. And if you are stuck, you can always refer to this integration test from the blog post. So now we are going to start building our third service, that is the inventory service. So for that, I'm going to open the website start.spring.io. And in here, I'm going to select a Maven project with the latest Spring Boot version 3.2.4. I'm going to change the group ID as com_techie microservices, and I'm going to add the artifact ID as inventory service. The description, I'm going to provide it as inventory service. The package name is going to be com_techie microservices.inventory. I'm going to use the packaging as jar. I'm going to use Java 21, and coming to the dependencies, I'm going to first add the dependency Lombok, followed by the dependency Spring Web, and we are going to use Spring Data JPA as our database framework, and we are going to use MySQL as a database. We are also going to use test containers to run integration test, write integration test for our inventory service. Finally, we are also going to add Flyway as the database migration tool. So after adding all these dependencies, just click on generate button, then your project will be downloaded to your machine. All right, so now I've unzipped the source code and opened the source code in IntelliJ IDE. So the first thing I'm going to do now here is to create a Docker Compose file on the root level. So we will use this Docker Compose file to download to run MongoDB containers. So we can copy this from our order service. So as we already wrote this Docker Compose file to download MongoDB and start up the MongoDB container for order service. So I'm just going to paste this from the order service. So one thing we need to add is we need to add the init.sql file inside the MySQL folder. So I'm just going to add a new folder directory called as MySQL, and inside this directory I'm going to create a new file called as init.sql, and in here I'm going to write the SQL command, SQL script to SQL query to create the database for inventory service, right? So if you remember in part 2, in the order service, we also created the database for order service during the startup of the MySQL database. So let's also do the same thing here. So I'm going to write create database. If not exists, it's going to be inventory_service, right? So now let's go back to the Docker Compose file, and we should be everything should be fine. So now let's open the terminal and run docker compose up -d. So this should start up the MySQL database, and it should also initialize MySQL database with the inventory database. So let's go to the Docker dashboard and open MySQL and click on the MySQL container. And if you verify the logs, you can see that the docker entry point.sh is executed, and inside that we have our init.sql file that's also executed, and the database is initialized. So that's good. Now to verify that, let's open the MySQL workbench. So inside the MySQL workbench, I'm going to connect to the local host MySQL. I'm going to reuse the connections which I've created in the previous part. So if you go to the schema section, and here you can see that we have the inventory service, and of course we don't have any tables. We have to create the tables during the startup of the application through Flyway. So let's go ahead and do that. So first of all, we have to add configure MySQL inside the application.properties using the Spring Data JPA properties. So the first property I'm going to add is Spring Data Source driver class name is going to be com MySQL CJ JDBC.driver, and we have the Spring Data Source .url. It's going to be JDBC MySQL localhost 3306/inventory_service. Next we have the data source username as root, Spring data source password as MySQL, and we have the Spring Data GPA Hibernate DDL auto as none, and lastly we will add the server.port as 8082. So 8080 is taken by product service, 8081 by order service, and now we have 8082 for the inventory service. So now let's go to the db.migration folder, and here I'm going to right click and I'm going to create the first migration script to create the table for inventory. So I'm going to add a new file called v1__init.sql. So this I've already explained to you about how to use Flyway in the part 2 of this tutorial series. So if you need to revise, please verify the part 2 of the series. So now let's go ahead and create the table for the inventory. So I'm going to just copy the script to create the table inventory. So we have this create table command with the name as t_inventory. We have our ID, which is the auto incremented primary key. We have the SKU code and the quantity. These are the 3 fields we have in this table. So that's all we need to do to create the initial tables. So what we can do is we can open the inventory service application and we can run the application using the debug mode. So you can see that the application startup is successful, and you can also see that Flyway has successfully applied one migration to schema inventory service. So that's good. Now let's also add one more migration script to initialize the inventory table with some data, right? So for that, I'm going to right click on the db.migration package, and I'm going to create a new file called as v2, because as this is a second migration script, I'm going to increment the number as v2 __ add _ inventory.sql. So here I'm going to again paste the SQL query to insert some data into the t_inventory table. So we have provided the quantity as 100, and we have provided some sample SKU codes for iPhone 15, Pixel, Galaxy, and OnePlus. So now let's restart our application and see if this v2 _ add inventory.sql file will be executed or not. All right, so now you can see that we have the log message successfully applied one migration to schema inventory service, now at version v2. So the add inventory migration script is also executed. So now let's open the MySQL workbench one more time, and I'm going to refresh this schema, and you can see that we have again 2 tables. Now we are mainly interested in the inventory table, so I'm going to select some rows, and you can see that the data we have initialized is stored successfully inside the inventory table. So now let's continue to create our endpoint to create our inventory service endpoints. So for that, I'm just going to start by creating the model classes. So for that, I'm going to create on a new Java class inside a package called model, and this class is going to be called as inventory, and this class is going to be a Spring Data JPA entity. So for that, I'm going to add the entity annotation. It's going to add a table annotation, and the name of the table is going to be t_inventory. We need a getter annotation, a setter annotation, allogs constructor, noaux constructor from Lombok. So we are going to first add an ID annotation with a generated value with strategy as identity. So we need these annotations for the ID field, which is of type long. Next we have the field SKU code followed by the field integer field quantity. So the model class is very simple and very straightforward. So now let's create the repository. So for that, I'm going to right click on the package and click on new Java class. It's going to be repository dot inventory repository, right? So this is going to be a Spring Data JPA repository, which needs to be an interface. So now I'm going to extend this using a JPA repository of inventory, and this is going to be a primary key of type long. Now let's create the inventory service inside a package called service. So this is going to be a Spring Boot service. I'm going to add the Spring Boot service annotation followed by the required args constructor annotation, because we need to inject the inventory repository into this class. And we have a method called public boolean is in stock, and this method is going to take two parameters. The first one is going to be SKU code, and the next one is going to be a quantity, right? So inside this method, I'm going to add a method called to inventory repository, and here we are going to query the database for a SKU code with integer with the quantity greater than or equal to 0. So our query is going to be find an inventory for a given SKU code where quantity is greater than or equal to 0, right? So this is the query we need to write. So we can make use of Spring Data JPA to automatically create the query for us. So I can type in exists by SKU code and quantity is greater than equals. So I'm going to provide the SKU code and quantity, right? So I need to just rewrite this this method, and I'm going to create this method inside the Spring Data JPA repository, and Spring Data JPA will automatically create the necessary query in the background, and it will, whenever I call this method, it will execute the query and send us the response, right? One thing we have to change is the return type should not be void, but it should be a boolean. So now I can go back to the inventory service, and I need to just return this back to the method, and now I can remove this comment. So the next thing I have to do is I have to create the controller which exposes the endpoint, which calls this isInStock method from the inventory service, right? So for that, I'm going to create new Java class inside a package called as controller, and the name of the class is going to be inventory controller. This is going to be a REST controller with a request mapping as /API/inventory. I'm going to also add the required args constructor annotation, and I'm going to inject the inventory service here, and the endpoint I'm going to create is going to be of type get mapping, and the response status for this endpoint is going to be http status dot OK, and the name of the method is going to be public boolean is in stock, and we are going to take two request parameters. The first one is going to be the SKU code, and the next one is going to be quantity of type integer. So we just have to call the inventory service.isInStock method and pass in the SKU code and quantity. So after that, I just have to add the return statement to return back the response coming from inventory service back to the client. So this is a very simple endpoint to check if a given SKU code contains is in stock or not. So now let's restart the application and test if our service is running or not, is working or not. So I'm just going to restart the application. So it looks like we have an error. We have an error during the startup. So the error is called as property reference exception. No property is greater than found for type integer. So looks like we somehow messed up the configuration here. So looks like, so I made a small mistake while writing the query, while writing the method name. So what we need to have is greater than equal, but not equals. So if I just remove this S to the end, let's also update the inventory repository to remove the S to the end. And I'm just going to restart the application and see if this is going to work or not. All right, so the change I did is working. That's good. Now let's open Postman and test our endpoint. So I have the request for the get inventory call is in stock endpoint call ready. So I have the request HTTP localhost 8082/API/inventory, and I'm going to provide the parameter for SKU code as iPhone_15, and I'm going to add the quantity as 100, right? So we know that I have initialized the data with quantity as 100. So if I provide any number which is less than or equal to 100, then we should return a response as true. So let's see. I'm going to click on send, and you can see that we are getting a response as true. And let's search and let's query for quantity as 101, and you see that we are getting the response as false, right? So this is a very simple inventory service we built. Let's also add some integration test. So similar to order service, you can refer to the integration test. You can refer to the integration test inside the blog post. So let's search for integration tests, and you can find the integration test for the inventory service for the name called inventory service application tests. So make sure first to write the integration test on your own. And if you're stuck, just refer to this integration test where we are calling the same endpoint and we are asserting the response. So in the previous parts, we saw how to develop order service as well as the inventory service. And in the architecture diagram, we saw that our order service will be communicating with the inventory service in a synchronous communication fashion. So in this part, we will see how to establish this synchronous communication using a library called as Spring Cloud Find. So here I have a small diagram where we are going to discuss more about this synchronous communication. So here we have our order service. So whenever an order service takes a request from the client to place an order, we will implement a logic to call to check if the given product is in stock or not by calling the inventory service, right? So our inventory service is running on port 8082, and we'll be making a HTTP request which requests to the inventory service, and the inventory service will return us a response, and then the order service will go ahead and either place the order and then will throw an error. Here we are first making a request to the inventory service and then waiting for the response from the inventory service, and then we go ahead and process our request, right? So this process is called as synchronous communication. And we also have another part called as asynchronous communication, which we will also discuss in the coming parts, where the order service can send out a request to another service, and we don't care about the response, right? We don't wait for the response. We just fire the request and then we go ahead to submit the order. We'll discuss a bit more about this asynchronous communication in the coming videos, but for now, this is how the synchronous communication works. We fire a request and we wait for the response, and then once we receive the response, we go ahead with our use case. So to do this synchronous communication, we can use many REST clients in Spring Boot. We can use a REST template, we can use web client, we can also use REST client, which is the latest REST client in Spring Boot 3. But we will use something different. We will use Spring Cloud OpenFine. So this is a library which is based on the library called as OpenFine. So this is the documentation of the Spring Cloud OpenFine library. You can see that this is another library which provides us a declarative form of writing Java HTTP clients, and Spring Cloud OpenFine acts like a wrapper around OpenFine and provides us the good integration with Spring Boot. So we'll be using this particular library to make REST calls from our order service to inventory service. So let's go ahead and see how we can implement this in our project. All right, so now I've opened the order service, and now let's add the Spring Cloud OpenFine library to our pom.xml. So for that, I'm going to open the pom.xml of order service, and here I'm going to take the help of the Spring Initializer website to add the Spring Cloud OpenFine starter library. So for that, make sure you select the Maven project, and let's add the dependency with the name OpenFine. If you click on Explore, you can find the dependency information for Spring Cloud Starter OpenFine. Just make sure to copy this dependency. Go back to the IntelliJ IDEA, and here I'm going to paste the dependency for Spring Cloud Starter OpenFine. So this is not the only thing we need. We also need to also add the parent dependency where all the versions of the Spring Cloud libraries are maintained. So let's go back to start Spring Initializer website, and if you just scroll down, we also have to copy the dependency management section here. Let's paste this just below the dependencies tag and above the build tag. I'm going to press enter and paste this here. We need to also copy the Spring Cloud version. So for that, I'm going to go back to the Spring Initializer website, and I'm going to copy the Spring Cloud .version property and go back to order service, and I'm going to paste this just below the java.version property. Once this is done, let's click on the Maven icon on the top right corner of the IDE to force IntelliJ to download the necessary dependencies. So once this is done, let's verify if OpenFine is added correctly or not. So for that, I'm going to open the application class, the order service application class, and I'm going to just below the Spring Boot application annotation, I'm going to add another annotation called as enable fine clients. So this annotation will auto configure the necessary classes to use OpenFine in our order service project. So the next thing I'm going to do is to create an interface called as inventory client. So for that, I'm going to right click on the root package, and I'm going to click on new Java class. Here I'm going to select the interface, and I'm going to create this interface inside the package called as client, and I'm going to call this interface as inventory client. So now on top of this inventory client interface, I'm going to add another annotation called as fine client, and I'm going to name this fine client with a value as inventory, and I'm going to provide the URL of this fine client, the root URL as http localhost 8082, because this is the URL where the inventory service is running. So we have to provide the URL of the inventory service. And the next thing we are going to do is we have to define what kind of method this HTTP client is going to call. So this is going to be a get method. So for that, I'm going to add the request mapping annotation and provide the value for the attribute method as request method dot get, and the value of this URL is going to be /API/inventory. right? So if you remember, we have created the endpoint for inventory service in the previous part. So this service is going to return a value of Boolean, and the name of the service is in stock. And we have to provide also the request parameters for this call. So the first request parameter we need to add is going to be of type SKU code, and the second parameter is going to be of type integer, and the name is going to be quantity. So we just need to define this method inside the interface, and Spring and this OpenFind find client will automatically add the necessary implementation to call the inventory service using the get method, right? So this is very somewhat similar to what Spring Data JPA does to implement the logic to write queries automatically, right? So Spring Data JPA abstracts all this logic. All we have to do is extend the JPA repository, and the find all, find one, save methods are all implemented for us out of the box. So similarly, Spring Cloud OpenFind also provides this functionality where we can just define the kind of HTTP call you want to make, and you need to provide the necessary information like request mapping, what is the corresponding HTTP method, what is the value of the URI path you want to call, and we also have to provide the necessary information like request parameters, path variables, request body, etc. So this is only the get mapping. You can also do the same thing for post, put, or delete in the same way. So the next thing is to call this inventory client from our order service. So let's open the order service class, and in here the first thing I'm going to do is I'm going to inject this inventory client into the order service. So for that I'm going to write private final inventory client, and inside the place order method what I'm going to do is I'm going to call the inventory client dot is in stock, and I'm going to provide the two request parameters. The first one is going to be the SKU code, and the second one is the quantity, which is coming from the order request DTO. And let's store the return type in a variable called as is product in stock, and I'm going to add an if condition here. If product is in stock, so what we are going to do is we are going to simply save the order to the database, and if the order is not in stock, I'm going to add an else condition here. I'm going to throw a runtime exception. I'm going to add a message here, product with SKU code. I'm going to add the reference to the SKU code. It's going to be order request dot SKU code is not in stock, right? So let's keep this simple. We're just going to throw this error message, and the next thing I'm going to do is let's test this implementation. So for that I'm just going to run the application. So our application, order service application, has started successfully. We also need to make sure that the inventory service is also up and running. So let's also open the inventory service, and I'm also going to run the inventory service application. Make sure you run the Docker Compose here, Docker Compose up -d. So here we got an error. It says that the container with name MySQL is already in use by the container of order service. So here in the order service, we are also already using this MySQL with the same name, the container name as MySQL. So what I'm going to do here is I'm going to change the name of this MySQL instance by naming it as inventory service MySQL, right? So now let's run the Docker Compose command again, and we get another error. It's saying that the port 3306 is already taken by the existing service. So what I'm going to do is I'm going to change the port to 3316, and let's run the Docker Compose command one more time. And now the service is starting successfully on the port 3316, but we have to change also the JDBC URL to use the port 3316 but not 3306. Now let's open the inventory service application and run the application now in the debug mode. And now you can see that the application is running successfully on port 8082. And now let's open Postman. And now I'm going to make a call to the submit order endpoint on the URL localhost 8081/API/order. The SKU code is going to be iPhone 15, and I'm going to make a post request. So let's click on send, and you can see that we got a response order placed successfully. And if I place make the quantity as 101, you can see that we are getting an error, a 500 internal server error. Let's go to order service. You can see that we are getting exception with the message product with SKU code iPhone 15 is not in stock. So in this way, we can implement the synchronous communication in our project using Spring Cloud OpenFind. So till now, we have done the manual testing using Postman. So in the previous part, I showed you how to write integration tests for the product service. And also I gave you assignment to write integration tests for the order service as well as the inventory service. I hope you try to attempt to write the integration test. If not, I have also provided you the link to the blog post where you can copy the integration test and use them. So if I go back to the order service application test, we have the integration test. And now let's try to run this integration test and see if the integration test is running correctly or not. So you can see that the integration test is running fine. So what it is doing is it's actually trying to call the inventory service directly, because if I go to the inventory client interface, we have provided the URL of the inventory service. So now let's go back to the inventory service and try to stop this inventory service. And now let's run the test again. And of course, this test will now fail. You can see that the test failed with the connection refused error. So this is the problem we have to solve now, because our integration tests are directly trying to connect to the external service. But this is not a good idea because we can't directly connect to the external service using the integration test. It's not a good idea because if it's a paid API, then you don't want to call this API on again and again, because you have to pay a lot of money unnecessarily. So the better thing to do in this case is we have to mock this interaction to the inventory client, right? So exactly this call, we have to mock it out. We can do that in two ways, right? The first way is using Mockito, a mocking library called Mockito. So what Mockito will do is it will mock out the interaction to this method. So instead of calling directly the method in the inventory client, it will just provide a mock response, and then we can use this mock response to run our tests. And the second option is we can use Wiremock, right? This is a better option because if we use Mockito, we are just mocking the method, but we are not actually testing HTTP call. We can use Wiremock to actually mock out the API itself. And in this way, we can actually test the HTTP interaction. So let me show you with an example with a diagram. So in the real world, what we are doing is our order service is calling the inventory service, which is running on port 8082, right? So what we will do now in the integration test is our order service will call the Wiremock server, and the Wiremock server will stub the call to the inventory service. So we'll provide a stub, and then we'll provide a mock response for the ease in stock API call. All right, so now I hope you understood why we want to use Wiremock to test out the external API communication. So now let's remove this comment from the order service. And now to add Wiremock to our project, what we are going to do is I'm going to open the Spring Initializer website one more time. And here I'm going to add another dependency and I'm going to search for Wiremock. And if you search for Wiremock, you can see the dependency called contract stub runner. Let's add this dependency because the dependency is coming from a project called as Spring Cloud Starter Contract. So this dependency also includes the dependency to run Wiremock server. So I'm going to copy this dependency and I'm going to open order service. I'm going to open the pom.xml file, and here I'm going to paste this dependency. So once the dependency is downloaded, the next thing I'm going to do is I'm going to open the order service application, and I want to auto configure all the Wiremock related classes. So for that, I'm going to add the auto configure Wiremock annotation. And what this will do is if you go inside this auto configure Wiremock annotation, let's download the sources. And you can see that the description, this is an annotation for test classes that want to start a Wiremock server as part of the Spring application context, right? So this is exactly what we want to do. So for that, we have to provide also the port in which the Wiremock server should run. So what I'm going to do here is I'm going to provide the port option which is going to be 8080 by default. We don't want to use 8080, but we want to use a random port. So for that, I can just provide the value as 0. So Spring Boot will pick a random port and then it will assign this port to run the Wiremock server. So this is all we need to do to auto-configure Wiremock. So I'm going to create a stub for the inventory service. So if I open the diagram one more time, you can see that we have set up a Wiremock, and we also have to set up a stub so that the Wiremock server can answer the request and can answer the request from the order service. So for that, I'm going to go back to the integration test, and here I'm going to create the root package inside the test Java package structure. I'm going to right click and I'm going to create a new class called as inventory client stub, and I'm going to add this inside a package called as stubs, right? So let's add the package name as stubs and create this class, and here I'm going to copy some code to define the stub. So this is the code. I've defined a method called as stub inventory call, and this method is going to take two parameters. The first one is going to be the SKU code, and the second one is the quantity. And here I'm going to first define a stub by using the stub for method, and inside the stub for method I'm going to provide another method called as get, because as we want to make a get call, we are defining a get method, and this get method will be equal to /API/inventory. And apart from that, we also have to provide the request parameters. So this is the request parameters, SKU code and quantity. And whenever Wiremock will receive a request which is matching this URL /API/inventory followed by the request parameters, we are configuring Wiremock to return a response, right? So that's what this will return method will do. Wiremock will return a response with status 200. And we also want to make sure that this response is of type JSON. So that's why we need to add a header with content type as application JSON. And finally, we want to return a response with body as true. So this is how we can create a stub for Wiremock. So now the next thing we are going to do is we have to call this stub inventory call in our application order service application test. So the easiest way to do that is, let's make this void stub inventory call method as static, so that we can just simply refer this method inside the test. So let's go back to the order service application test, and just before the test here, I'm going to make a call to inventory client stub inventory call, and here I have to provide the SKU code value as iPhone_15 and the quantity as 1, right? So all I have to do is, before executing the test, we just have to call this stub inventory call method, and inside this we have configured the stub to return the response as true whenever the URL is equals to API inventory followed by the necessary request parameters, right? So now let's go ahead and run the test and make sure that the inventory service is not running. So let's go back and see that the application is not running, it is stopped. Now let's run the test, and now we can see that we are still getting the connection refused error. This is because if I open the inventory client, we have hard-coded the URL for inventory service as localhost 8082, right? So this is not a really good idea. What we have to do is we have to take out this URL and we have to create a property inside the application.properties. So what I'm going to do is I'm going to create a property called as inventory.url, and I'm going to provide the value of this property as localhost 8082, and I will use this property here instead of using the directly hard coding the value. So in this way, what I can do is I can override this property inside my integration test. So in this way, we can make sure that we don't hard code and use the real URL while running the integration tests. And now I'm going to remove this hard coded value, and I'm going to provide a Spring expression language variable by providing $, and I'm going to provide a curly brace, and inside this I'm going to add the definition of the property inventory.url, right? So in this way, we don't need to hard code the URL. We can externalize the URL configuration to the application.properties. And now what we can do is we can just simply copy this URL property, and let's go inside the resources folder. So we don't have the resources folder here. So we have to create this resources folder in the under the test folder. So right click and create a new directory, and this directory is going to be resources. IntelliJ is already providing the necessary information to create the resources folder, but let's go ahead and create the resources folder, and I'm going to add a new file here called as application.properties, and I'm going to paste this inventory.url property here, and instead of providing the URL for localhost 8082, I have to provide the URL for Wiremock. One problem we have here is we don't know at what port the Wiremock server is running. So if you open our integration test, you can see that we have defined the port as 0. So we have asked Spring Boot to use a random port. We don't know which port we want to use for our integration test. So in this case, what we can do is we can add one property variable. So I'm just going to remove the 8082 number, and I'm going to first add a Spring expression language variable by providing $ and providing 2 curly brackets, and inside this curly brackets I'm going to write Wiremock. So it's going to be wiremock.server.port. So this, by adding this particular variable, Spring Boot will automatically inject the port of the Wiremock server into our application.properties. So whenever our application is running, it will automatically dynamically assign the port of Wiremock server to here. So let's go ahead and test if this test is working or not. So I'm just going to run the order service application test. All right, so looks like our test is executing successfully. Let's see what is really happening here. I'm just going to expand this log, and here you can see that we have a log message from Wiremock. It says that request is received, and the request is received, and the received request contains a get method, and it is made to this particular API URL /API/inventory, and the SKU code is iPhone 15 and quantity is 1, and this is the response which is printed by Wiremock, right? It is returning a 200 status and the body as true, and with a header type as application JSON. So Wiremock is returning this response, and now as we have received the response as true, the order is placed successfully, right? So this is the positive case. We can also add a negative case. I'm not going to add the negative case here. In this video, we will learn about API gateway pattern and how to integrate this API gateway pattern in our Spring Boot microservices project. We'll be using Spring Cloud Gateway MVC as the API gateway library. So without any further delay, let's start the video. An API gateway actually acts as an entry point for all the requests into our system, and we can mainly forward the incoming requests to the downstream microservices using an API gateway. And also API gateway is a very commonly used component inside the distributed systems and microservices architecture. Let's see this with an example. So in our present system landscape, we have our product service, order service, and the inventory service. And the order service is running on localhost 8080, order service on 8081, and inventory service on 8082. If a user wants to call the product service, we are calling with URL localhost 8080. This is fine for the local dev environment, but if we move to production, we will be using a different URL, and at any point of time there can be changes to this product service. Imagine that if we want to create a new microservice from the product service called as product promotion service or product category service, the client has to manually change the URL of the service. So in this case, the client can be a web application, a mobile browser, or maybe a desktop application, whatever it can be. So another problem is we can have multiple instances of a service running inside our project, right? So for example, we can have 3 instances of product service, 2 instances of order service, and only just maybe 1 instance of inventory service. And if 1 instance of product service is going down, then if we hard code the URL of the product service, which is in the middle, then the clients cannot access a product service anymore. So this is not really an acceptable situation. So for this, as a solution, we can introduce an API gateway which acts like an entry point, as I said, for all the requests to our system. So if at all in the future there is a change to the product service, all we have to do is we have to change the path URL of the product service inside the API gateway, and the clients don't even know that something has changed inside our product service. So this is one of the advantages of using a API gateway. Another advantage is an API gateway handles cross-cutting concerns like implementing security, like authentication and authorization. It also helps us to implement monitoring, rate limiting, also SSL termination. We will see how to handle some of these cross-cutting concerns in this tutorial series. So there are also some drawbacks of using an API gateway. One of which is it increases the complexity of the system, as we have to maintain yet another component in our system landscape. Another disadvantage is it needs a lot of effort to maintain a new component, because this API gateway acts as a single point of failure. Because as you can see here, if the API gateway goes down, then the clients cannot access our application anymore. And another drawback of using an API gateway is it increases the latency of the client request, because the client first calls the API gateway and the API gateway calls the actual internal microservice. So this introduces a bit of latency whenever you want to use an API gateway in your project. So as I mentioned before, we'll be using Spring Cloud Gateway MVC project instead of Spring Cloud Gateway, because the Spring Cloud MVC based on Spring MVC and Tomcat. As you can see here in the documentation section, the Spring Cloud Gateway project provides libraries for building an API gateway on top of Spring Web Flux or Spring Web MVC. It also provides us out-of-the-box features to match the routes on any request attribute, and to be able to apply predicates and filters for the specific routes. It also provides us a good circuit breaker integration. We'll have a look at all these integrations and all these topics in this tutorial. So to get started with the API Gateway project, I'm going to open the start.spring.io website, and in here I've already pre-selected the project as Maven, the Spring Boot version as the latest Spring Boot version. I've provided some project metadata, the artifact ID as API Gateway, the Java version as Java 21, and I have added the dependency called as Gateway. So make sure that you add the dependency for Gateway but not reactive Gateway. So if you just click on add dependencies and search for Gateway, you will see another option called as reactive Gateway. Don't use this option, but just use the option Gateway, so that we will use the Spring Cloud Gateway MVC project. So once this is done, click on the generate button to download the project to your local machine. So I've opened the API Gateway project inside my IDE, and if I open the source main Java folder, here you will have the API Gateway application, which is nothing but a normal Spring Boot application. Here I'm going to create a new class called as routes inside a package called as routes. And on top of this class, I'm going to add the configuration annotation. And inside this class, we have to define all the routing rules for our API gateway, right? So if we want to access the product service, we need to define the rules to forward this request from the API gateway to the product service and order service and the inventory service. So for that, we need to create some beans. So for that, I'm going to add the bean annotation, and I'm going to type public router function of server response, and I'm going to call this method as product service route. And inside the method, I'm going to add a return statement, and I'm going to use gateway router functions dot route, and I'm going to provide the route ID as product underscore service. Next, I need to add the actual route definition, where we have the first argument as a request predicate. So I'm going to provide a request predicates dot path, and in here I'm going to provide the path of the predicate as /API /product. And now I'm going to type handler functions dot HTTP, and in here I'm going to provide the value HTTP localhost 8080, and then I'm going to end this by adding the build method. So what we are doing inside this method is we are using a different programming model called as functional endpoint programming model. So if I open the Spring Web MVC documentation, you can see that Spring Web MVC includes webmvc.fn, a lightweight functional programming model in which functions are used to route and handle requests, and contracts are designed for immutability. So we all know that in a normal Spring MVC, we use annotations to define get mapping, post mapping, and other mappings. Using functional endpoints, we can do this we can write the same endpoints using a different programming model. So for example, if you want to define a get mapping, all you have to do is route.get. We have to define a method called as get. And inside this method, we have to provide the URL in which we have to define the get endpoint, and we can define the headers. For example, we want to have an accept header of application JSON. And finally, we can provide the handler method, which will be executed whenever get endpoint is called. So if you see that here inside this get person, we have one method which is taking a server request as an input, and it is giving the server response as the response. So this is an alternative way of creating endpoints using functional endpoint style. So we'll be using this same mechanism also in Spring Cloud Gateway MVC. So let's go back to our IDE, and now going back to the route definition, here we have defined a route for the product service, and inside this route method we are defining a rule where if the URL path is /API/product, then we have to forward this particular request to the URL HTTP localhost 8080. We are doing this with the help of handler functions.http method. So inside this request predicates method, we have a lot more methods. Path is the one of the method. If I go inside the request predicates class, you can see that it's an implementation of a request predicate that implements various request matching operations such as matching based on path, HTTP method, etc. So the path method here matches based on the URL path. So this is one option. So we have other options like headers. So if you want to make sure that whenever there is a header called header A inside the request, then we want to forward this to product service. So we can also create a predicate based on the content type and the accept header. So in the same way, we can also create a predicate for get method. So you can see that it matches this predicate if the request HTTP method is get and the given pattern matches the request pattern. So we can also rewrite this particular path method as get and provide the string pattern which we want to match. So now let's do a test if this particular route is working or not. So I'm going to run the API Gateway application, and you see that we are getting an error because the port 8080 is already taken by the product service. So we have to use a different port. So for that, I'm going to open the application.properties file, and I'm going to write server.port equals 9000 because now I want to use the port 9000 for the API Gateway. So let's run the application again in the debug mode. Now you can see that the application has started successfully on the port 9000. So now I've opened Postman, and here I have the request localhost 9000 to the path /API/product. So I'm going to click on send here, and let's see if we are getting a response or not. Indeed, we are getting a response. So our API Gateway is able to successfully forward the request to the product service, and it is also displaying the response from the product service to us. So in the same way, let's go ahead and implement the routes for the product service and the inventory service. So I'm going back to the IDE, and inside the routes class, I'm going to just copy this product service function, route function, and I'm going to paste this and rename the method as order service route and the route ID as order_service, the path as /API/order. The host name to which we want to forward is going to be localhost 8081. In the same way, I'm going to copy and paste it and rename the order service to inventory service. Change the route ID from order service to inventory service, change the path to /API/inventory, and finally I'm going to also change the URL to localhost 8082. So after adding this configuration, I'm going to restart the API Gateway application, I'm going to click on stop and rerun. And now I'm going to open the Postman and I'm going to find the request for the submit order. So here I have the request for localhost 9000/API/order. I'm going to provide the body to the request payload to create the order, to submit an order. So I'm going to click on send, and you can see that I got a response, order placed successfully. So let's also make a call to the inventory service. So I'm going to find the request for the inventory service, and here I already have one request which is ready, which is making a call to inventory service, which SKU code as iPhone 15 and quantity as 10. So let's make a call, and you can see that we are getting a response as true. That's good. Let's now make another call. Now this time I'm going to provide the quantity as 110 instead of 10, and you can see that we are getting the response as false because we have defined the quantity for iPhone 15 as 100. So that's why if we want to have a quantity of 110, then we will get a response as false. So in this way, we can create a API gateway which can act as an entry point for all our microservices. So that's it for this video. I will see you in the next part where we will implement security in our project using Keycloak. So I will see you in the next video. Until then, happy coding techies. So in the previous video, we saw how to integrate API gateway into our microservices project. In this video, we are going to secure our API gateway using a auth server called as Keycloak. So without any further delay, let's start the video. So now let's understand what is Keycloak. Keycloak is an open source identity and access management solution we can use to secure our Java applications. So it has the ability to add authentication to applications and microservices with minimum effort. Keycloak provides many different features like single sign-on and user federation, identity brokering, and social login. So using Keycloak, you can automatically implement the functionalities like sign in with Google, sign in with Facebook, and other social networks. So it has support for a wide range of protocols like OpenID Connect, OAuth2, and SAML. So we'll be using mainly Keycloak to secure our API gateway, as I mentioned before. So if you want to learn more about Keycloak, what is OAuth2, and what is all this OAuth2 and OIDC terminologies, you can refer to my Spring Boot 3 Keycloak OAuth2 tutorial with Spring Security on my YouTube channel. It is like nearly 1 hour long, and I've covered everything in depth in this tutorial. So make sure to watch this tutorial before going ahead with this video, because then you will be ready to implement the security for our microservices project. So without any further delay, let's go ahead and implement Keycloak in our project. All right, so now I'm inside the API Gateway project, and the first thing we are going to do is to download Keycloak. So for that, we are going to use Docker Compose and Docker to download Keycloak, as we did for all other software in the previous parts. So I'm going to right click on the root project and going to create a new file called as dockercompose.yaml, and in here first I'm going to add the version as 3.8. I'm going to add services here. So first of all, we need to have two services here. The first one is Keycloak. Of course, we need Keycloak, and the second one is Keycloak usually needs a database as to store all the metadata which is created by Keycloak. So for that, we need to use MySQL as the backing database for Keycloak. So let's go ahead, and what I'm going to do now is to get all this configuration. I'm going to make use of the written tutorial here. You will find the link to the written tutorial in the description section. So here I'm going to scroll down until I find the section download Keycloak, and you can just copy the whole Docker Compose file from here and go back to IntelliJ and just paste this inside the Docker Compose file we just created. So here first we have the Keycloak configuration for Keycloak container. So the container name is Keycloak, and the image we are using is for the Keycloak version 24.0.1, and the startup command we are using is the start dev command to start Keycloak in the dev environment. And we also have the import realm argument, which is passed to the start command. We will understand about this flag and command shortly. So next we have the environment, where we are providing the DB vendor environment variable as MySQL, and we also have some metadata about the MySQL database, like the database name, username, password, and we also have an environment variable called as Keycloak_admin, where we provide the admin name and also the admin password. We provide it to the Keycloak_admin_password. So we have to note both these admin username and password, because we need this when we start up the container and we want to log into Keycloak. We need these username and password. So the next we have the ports section, where we are configuring Keycloak to run on port 8080. But as port 8080 is already taken by the product service, we will be mapping the local port 8181 from the Docker container, so you can access the Keycloak on the port 8181. And finally, we have the volumes section here. I will come back to this section. I will explain it later once I explain all the concepts about Keycloak. And of course, lastly, we have the depends on section, where we configure that this Keycloak container depends on the Keycloak MySQL container. So here we have the normal MySQL configuration of using the image name MySQL with version 8. We also defined a volume similar to how we defined for order service and as well as the inventory service. And finally, we have our environment variables, where we have defined the MySQL database name, username, password, and also the root password. So now let's open the terminal and run docker compose command. So I'm going to run docker compose up -d. So as I already have these two containers, Docker images on my local registry, the Docker has simply started running these two Docker containers. So if you're running this for the first time, of course, it will take some time to download the images from the Docker registry. And after that, you will see that the two containers will be in the state running. So now let's go back to the browser and open the URL localhost 8181. So here you can see the localhost 8181. You can see a login page for Keycloak. So here we have the username and password form. So I'm going to provide the username as admin and also password as admin, as we saw before. I'm going to click on sign in. Okay, I'm going to click on close. And here you have the homepage of the Keycloak dashboard. And here to the left side, we have a drop down where it says Keycloak. So just click on this drop down, and here you can see the existing realms. You can have the option to create a realm. A realm is nothing but a container where you can have a set of users, clients, roles, and all the users all configured inside one place, so that if you have one project, usually you create one realm and create all the related clients, users, and credentials inside this realm. And these realms are usually isolated and from each other. So if you have two different applications, you can create two different realms, and the users and clients which are created in one realm cannot access the other users or other clients created in another realm. So again, all these concepts, I have explained this in detail in my Keycloak tutorial. So just refer to that tutorial. And so now let's continue with our Keycloak configuration. So here I'm going to provide the realm name as Spring Microservices Security Realm, and I'm going to click on create. So you can see the message realm is created successfully. And here you see that we have various options. We have the options to create for the clients. So these are the clients which are created by default by Keycloak. And here we are mainly interested to create a new client to access our API gateway. So I'm going to click on create client, and here I'm going to provide the client ID as Spring Client Credentials ID, something like this. You can of course provide whatever ID you like. So I'm going to click on next, and in this page what we have to do is we have to select the client authentication option as on. So you also have one info message here. It says that this defines the type of the OIDC client. When it's on, the OIDC type is set to confidential access type. When it's off, it is set to public access type. Basically, we want to access the API gateway through a Postman client or maybe a REST client. So we won't be accessing the API gateway through the web browser in this tutorial. So as we'll be accessing using a standalone REST client, so we have to add the client authentication option as on. And after that, the authentication flow, we have to select the service accounts role option, and we don't need the other two options because again the standard flow is used whenever you are using the authentication where you're authenticating from the browser. And the direct access grants is also not needed because by using this direct access grant you can basically authenticate using a username and password. We also don't want that. We will be mainly using client credentials to authorize our client. So for that we need the service account roles option. So that's why I created this option. Now let's click on next. And also this, we don't need to provide any information. This is optional. Finally, let's click on save, and you can see that the client is created successfully. And next thing we are going to do is we have to note the credentials which are going to be created, which are created for us automatically. So I'm going to click on the credentials tab, and here you can see that the client authenticator is defined as client ID and secret, and the client secret is automatically generated for us. So if we click on this view button, you can see this is the client secret which was generated for us automatically. I'm going to click on this option to copy the client secret to the clipboard. If you like, you can also regenerate the client secret. So this is one option you have. So the next thing we are going to do is we want to configure Keycloak in our project. So for that, I'm going to click on this realm setting options, and here you can see all the settings for a given realm. And here I'm going to click on the OpenID configuration endpoint, where this will open the page of the auth2 configuration. You have the options like issuer URL, token endpoint, introspection endpoint, user info endpoint. So we also need this URL later, so we'll come back to that. For now, let's go back to the IntelliJ IDEA and let's configure Keycloak in our project. So for that, I'm going to open the pom.xml file, and in here I'm going to first add a dependency inside the API gateway. Basically, to enable OAuth2 in our API gateway, we have two options. We can configure our API gateway as an OAuth2 client, or maybe an OAuth2 resource server. So as we will be communicating with the API gateway only through a standalone REST client without any browser, we'll be using API gateway as a resource server, but not an OAuth2 client. So for that, I'm going to add a dependency called as Spring Security OAuth2 resource server, and the group ID is going to be org spring framework.security. So to download this dependency, click on the Maven icon to the top right corner, and once this dependency is downloaded successfully, let's open the application.properties file under the source main resources. And in here, I'm going to add a property called as Spring Security OAuth2 resource server.jwt.issuer URI. And in here, we have to provide the issuer URI for the Keycloak realm we have created before. So let's go back to the Keycloak configuration we have opened before. So here you can see that we have the issuer URI, localhost 8181, realms, Spring Microservices security realm. So I'm going to copy this particular URL and go back to my project, and I'm going to paste this issuer URI inside the application.properties file. The next thing we are going to do is we also need to add some security configuration. So let's expand the Java package, and under the gateway package, I'm going to right click and going to create a new class under the package called as config. I'm going to call this config.securityconfig, and I'm going to add the configuration annotation on top of the security config class. And in here, I'm going to add a bean, and I'm going to call this public security filter chain, and the security filter chain is going to be taking a parameter of type HTTP security. Okay, looks like we don't have the HTTP security class. So that means we did a mistake in the importing the dependency. So let's go back. So basically we have defined the artifact ID for Spring Security OAuth2 resource server. So this is incorrect. So what we really need is Spring Boot Starter OAuth2 resource server, and the group ID is going to be org spring framework.boot. And now let's click on this Maven icon again, and once this dependency is downloaded, let's go back to our security config, and now let's type out HTTP security. Okay, now we have HTTP security, and yeah, now the error is gone. That's good. So what we have to do here is inside the security filter chain method, I'm going to first initialize this security configuration. So I'm going to type in http security dot authorize http request, and inside the authorize http request method, I'm going to call a lambda called as authorize dot any request dot authenticated, and after that I'm going to type dot auth to resource server. This is going to be auth2, and let's define another lambda called as auth2.jwt, and inside this JWT I'm going to add this customizer dot with defaults option, and let's add the build method to actually take all this configuration and build a HTTP security filter chain and build a security filter chain object. And let's finally add a return statement here to this method. And of course, this authorize HTTP request is actually throwing an exception. So for that, we need to add the exception to the method signature. Let's do that. So once this is done, we have configured our API gateway with string security and also as a resource server. So now all we have to do is we have to go to the API gateway application and start the application in debug mode, and you can see that the application has started up successfully on the port 9000. Now it's time to call our API gateway. Make sure that you also have the product service, order service, and the inventory service up and running. Now let's open the Postman client, and here we have the request to localhost 9000/API/product to call the get product endpoint. So now if I try to call the get product endpoint without any authentication or authorization information, so if I click on send, you can see that we are getting a 401 unauthorized exception here, which is good. That means our gateway is working correctly. So now what we have to do is we have to first get a token from our auth server and then use the token as a bearer token to call our API gateway, right? So for that, have to request the access token first of all. So for that, I'm going to click on the authorization tab, and in the type, I'm going to select the type as OAuth 2.0. So if I just scroll down here, you can see that we can configure a new token. So the grant type is going to be client credentials, and here we have to provide the access token URL. You can get this access token URL by going back to the browser to the page we have opened before from the Keycloak realm settings. Here you can see the token endpoint URL. So I'm going to click on this endpoint, and I'm going to copy the URL, and I'm going to paste it here. So we also need the client ID and client secret. So we have to go back for that to the Keycloak portal, and I'm going to click on the clients option here, and I'm going to go to the client which I've created. It's going to be Spring Client Credentials ID. So I'm going to copy this and paste it here inside Postman. Let's go back and also copy the client secret by clicking on this copy to clipboard button. I'm going to paste it here. And finally, we leave all the options as the default, and let's come back here. Let's scroll down and you click on the get new access token button, and you can see that the authentication is completed. And now if we click on proceed, you can see the token which was sent as a response from the authorization server. Here you can see that we got an access token. Token type is bearer token. So the expiration time for this token is 300 seconds. And we also have an ID token. If we want to have the information about the user, we can use the ID token. And we also have some other metadata of this token. So you can use the option. So let's click on the option use token. And now you can see that the token will be added to the bearer, to the authorization header automatically. So if I now click on send, you can see that our request has reached API Gateway, and now API Gateway has routed our request to the product service and is showing us the response. So let's also do the same thing for the submit order endpoint. So I'm going to click on the submit order endpoint here, and I'm going to do the same thing. Here, I'm going to select the type as OAuth2. So here you see that the token we have created before is automatically populated here. So though we don't need to request another token. So I'm going to click on option send here. You can see that we got the response order placed successfully. In case if the token is expired for you, you can just scroll down here and click on get new access token, and you can then use this token. So now let's delete the first token we have requested. So now let's click on this option, use token, and click on send. And you can see that we received the response order placed successfully. So in this way, you can implement security for our API gateway using Keycloak. So that's it for this tutorial. In the next tutorial, we will see how to implement resiliency in our project by using Resilience4j and Spring Cloud Circuit Breaker project. So I will see you in the next video. Until then, happy coding techies. In this video, we will learn how to document our REST APIs using the Open API specification. We'll be using Swagger as the tool to document the REST API, and to use Swagger, we'll be using the Spring Doc Open API library to provide integration with Swagger and document our REST APIs. We'll be mainly documenting our three services: the product service, order service, and the inventory service. And we'll see how to expose the REST API documentation over the API gateway. Without any further delay, let's start the video. So first of all, let's understand what is this Open API. So Open API is a specification that provides a formal standard for describing the HTTP APIs, as it says here inside the website. So it mainly standardizes the practice of documenting your APIs, so that it describes all the things like how your API looks like, how to access your API, which authentication methods you have to use to access your API, what is the request body, what is the request parameters, all the information we need to access the API. This will be documented, and Open API provides a specification on how to document your API. And we have a tool called as Swagger, which uses this Open API specification and provides us a library to document our REST APIs. So a good analogy to describe the relation between Open API and Swagger is similar to how Hibernate and JPA works. Right. So in the Java universe, if you want, JPA standardizes the way how we can interact with the databases using a specification, and Hibernate is actually an implementation of the JPA specification. So similarly, Open API provides us a specification on how to document our APIs, and Swagger provides us some tools and libraries using which we can implement REST API documentation. So specifically, as we are using Spring Boot, we cannot directly use Swagger. We can use it using a library called as Spring Doc Open API. So the Spring Doc Open API provides us a Java library so that we can document our REST APIs. It also provides us auto configuration features to automatically generate the documentation in the form of JSON, YAML, and HTML formats. You can see that here the library supports OpenAPI 3, Spring Boot version 3, and it also provides the features like Swagger UI. It also provides good integration with OAuth 2, and it also provides support of GraalVM native images. Let's go ahead and implement this library in our projects and document our REST APIs. Alright, so now let's start documenting our REST APIs with the product service. So I'm inside IntelliJ, and I opened the product service project, and here I'm going to go inside the pom.xml file, and I have to add the dependency for Spring Doc OpenAPI library to the pom.xml. For that, I'm going to take the help of the documentation which I showed you before. So I'm going to go back to the documentation here, and I'm going to click on the getting started section. So if you open the documentation, you can go to springdoc.org website, and here I'm going to click on getting started, and here you can see that we have first dependency called as Spring Doc OpenAPI Starter Web MVC UI. So this dependency provides us capabilities to generate documentation of our project of a REST API in HTML format. So for that, I just have to copy this dependency, and let's go back. We also have the possibility to generate the documentation in the form of in the JSON and YAML. For now, we will just use the Web MVC UI option to generate the documentation using in HTML format. So let's go back to the project, and here I'm going to add the dependency, and I'm going to click on the Maven icon to the top right side corner to force IntelliJ to download this dependency. The next thing we are going to do here is we have to change the path of the URL, so where the Swagger documentation is accessible. So for that, I'm going to open source main resources, application.properties, and I'm going to add a property called as springdoc.swagger UI.path, and this path I'm going to define it as /swaggerui.html. So by defining this path, we can access the REST documentation, REST API documentation in the, for example, in the path http localhost 8080/swaggerui.html. So when you open this URL, then you can access the REST API documentation in the HTML format, right? So actually this is this is the very basic thing you need to do to define to generate the REST API documentation. So now make sure that you have the Docker Compose up and running to run the MongoDB database, and let's restart our application, the product service application. Okay, so once this is done, I'm going to go open the browser. I'm going to open the browser and I'm going to go to the URL localhost 8080/swaggerui/index.html, and you can see that the library has automatically created a nice looking documentation using in the HTML format. And here you can see that we have the product controller and the two endpoints we have. We have one post endpoint which is used to create the product, and one get endpoint which is used to read the product. So all the required definitions like the payload. So this is the payload we are taking, and this is the response our API is sending back. So all this information is nicely documented for us. So if you want to have a look at the schema of the payload, you can see that the product request is added as a schema, and inside the schema we have the fields ID, name, description, and price. And if you just expand here, you can see what kind of data type this particular field is. So you can see that the price is a number, and you can also see examine the product response. So of course we have the almost similar response, similar fields like product request here. But you can understand this is really helpful whenever you want to onboard a new user into a new client, new client to consume your API. You can just provide the link to this API documentation, and the client or consumer will automatically will get a good overview of how to access your REST API by just referring to this documentation, right? So this is one of the advantages of also documenting your REST API, so that it provides transparency and clarity on what your API is providing. This is the very basic thing you have to do, and of course you can customize this documentation by providing much more information. So if you want to instead of providing the information like open API definition, customize this to display it as product service REST API, something like that. So let's go ahead and do that. I'm inside the IDE again, and let's create a configuration. So let's configure our REST API documentation to provide more information about our service. So for that, I'm going to expand the Java package, and I'm going to create a new package here called as config. And inside this package, I'm going to create a new Java class called as OpenAPI config. And I'm going to add the configuration annotation on top of this OpenAPI config class. And here I'm going to create a bean with the type as public, and I'm going to call it as OpenAPI. This will be the return type, and the bean name is going to be product service API. And in here I'm going to add a return statement, and I'm going to create an object for OpenAPI class, and here I'm going to add the information through the info method. And to the info method, I'm going to type in new info dot title is going to be product service API, if I can spell service correctly. And we can have some other fields like description, contact, extensions, license, summary, version number. So you can provide a lot of information here. So let's provide the description as this is the REST API for product service, and I'm going to provide the version as version 0.0.1, and we have to provide also the license. So for the license, I'm going to provide object for new license dot name, and I'm going to provide the license as Apache 2.0. And once this is done, I'm going to also add some links to the external, so some additional information like external docs. So you can provide also some external documentation. That means if you want to have include the links to some other extensive documentation, you can also provide the links here. So using the external documentation section. So inside the external docs method, I'm going to create a new object for external documentation dot description. I can add a description like you can refer to the product service wiki documentation, and we're going to provide the URL as https product service dummy url.com/docs, right? So in this way, we can provide some documentation about our documentation to describe your service inside OpenAPI. Let's rerun the application and let's see if this information is reflected in the Swagger UI HTML documentation or not. So let's go back to the browser and refresh. And here you can see that this information is reflected correctly. So we have this product service API and the description that this is the REST API for product service. We have the license information, and we can also see that the URL for the external documentation. You can refer to the product service wiki documentation. If I click on it, nothing will happen because this is a dummy URL, but you get the idea. So now let's also see how to expose the REST API documentation in the JSON format. So for that, I'm going to go back to the OpenAPI documentation, and here I'm going to go to the getting started section again. And if you just scroll down, you can see the Spring Web MVC support section, and here I'm going to copy this dependency Spring Doc OpenAPI Starter Web MVC API. So this is mainly used for if you want to access the documentation as an API. I'm going to go back to the IDE, and I'm going to go to the pom.xml, and I'm going to paste this particular dependency in here, and I'm going to click on the Maven icon to the top right side corner to force IntelliJ to download the dependency. And once this is done, I'm going to go back to the application.properties file, and I'm going to type in springdoc.api-docs.path, and I'm going to provide this as /API docs. So if you access the URL, for example, http localhost 8080/API docs, then you will see the REST API documentation in the form of JSON. So let's restart our application and go back to the browser. And if I replace the /Swagger UI with API docs, you can see that we can see the REST API in the form of a JSON. So here we see that we have this info object with the title product service and all the information we gave also about the external docs. We have the information about the servers. We have the information about the paths. So we have the /API paths, which is using for the get method, and also the post method. We have it here. And we also have other information like product schema, the schemas like product request and product response. So all this information is provided in the form of a JSON. So if you want to access the API, REST API in the form of JSON API, then you can use this option. So now we saw how to document our API, our REST API in HTML and JSON formats. So now let's do the same thing for the order service as well as the inventory service. So I opened the order service in my IDE. So here what we have to do is very simple. We just have to copy and paste the dependencies and the configuration from the product service. So I'm going to open product service here, and I'm going to go to the pom.xml and copy these two dependencies. The first one is this WebMVC UI and WebMVC API. Let's go back to the order service, and in here I'm going to paste these two dependencies inside the order service pom.xml and click on the Maven icon to the top right side corner, and let's go to the source main resources folder, and here also let's go back to product service and go to the application.properties, and I'm going to copy this two properties, and I'm going to go back and paste this to properties here. And finally we have to create a configuration class for the OpenAPI config. So for that I'm going to create a new Java class inside a package called as config, and I'm going to call this class as OpenAPI config. So also for this we can just copy and paste the whole configuration from the product service. I'm going to copy the whole class except for the package statement. I'm going to go back to the order service, and here I'm going to paste this just inside the class, and I'm going to rename the bean name from product service API to order service API, and I'm going to change the title of product service to order service, and let's replace all the occurrences of product with order. All right, so now that's all we need. So let's start the application. Okay, and you can see that the application is running successfully on port 8081. So now let's open the browser, and let's go to the URL localhost 8081/API docs. And you can see that we first see the API information in the form of a JSON. That's good. So now I'm going to open the Swagger UI/index.html page, and also here we see the order service API is documented correctly. So we have the documentation for the /API/order endpoint. Of course, this is a post method, and it's taking the payload, order numbers, queue code, price, and quantity. Everything seems to be correct. And also in the schema, we have the order request with the same fields. So order numbers, queue code, price, and quantity. And also here we see the data types of all the fields. That's good. So now let's do this also for the inventory service. I'm not going to show this again because this is the same thing I have to do for inventory service. So I will do this offline, and I will come back to you once everything is done. All right, so I've made the changes, and I've opened the URL localhost 8082/swagger UI/index.html. And here you can see that the documentation for the REST API documentation says inventory service API. We also see the endpoint /API/inventory, which is a get endpoint. If you expand, you can see that we have two query request parameters, queue code and quantity, and the response here we are sending the boolean as response with the status code as 200. So this is the API for the inventory controller. So we have documented all the three APIs. We also have the let's also see the documentation in the JSON format. So if I just click on here, it will open a new URL, new tab, which is pointing to localhost 8082/API docs. And here you can see the API documentation in the JSON format. So we have documented all the three services: product service, order service, and the inventory service. But the one thing you may have already observed is that we are accessing this API through the services itself directly, right? So this is fine for now, but as we progress inside the course, we will restrict the access to the order service, the API service, and inventory service. So we will not allow direct access to the services. We will only allow the access through the API gateway. So in the next part, what we will do is we will try to aggregate all this information and provide a way to access this information through the API gateway itself. So we will see how to do that in the next video. And I will see you in the next video. Until then, happy coding techies. So in the previous video, we saw how to document our REST API documentation. And in this video, we will see how to aggregate all the REST API documentation in one place in the API gateway so that it is easy for us to access the documentation. And also we will be doing some refactoring where we'll be replacing the library Spring Cloud OpenFind starter with the REST client starter. So without any further delay, let's start the video. So now I've opened the API gateway project, and inside this project I'm going to go to the pom.xml file, and the first thing we are going to do is to add the Swagger dependencies, the Spring Doc OpenAPI dependencies to the API gateway project. So for that, I'm just going to go inside the dependencies section, and I'm just going to paste in the two dependencies which we have added in other microservices. The first one is the Spring Doc OpenAPI starter web MVC UI. So this dependency will help us to generate the REST API documentation in the HTML format, and it will also provide a nice GUI to view the documentation. And the next dependency is the Spring Doc OpenAPI starter web MVC API, which will allow us to expose the REST API documentation as a YAML or a JSON file. So after adding these two dependencies, what we have to do is we just have to make sure that these two dependencies are downloaded by clicking on the Maven icon to the top right side corner of your IDE if you're using IntelliJ. And after that, we are going to go inside source main resources, and inside the application.properties file, I'm just going to add some properties. First one is going to be springdoc.swagger.ui.path, and I'm going to define the path as /swaggerui.html. So after defining this path, I can access the API documentation on this URL path. After that, I'm just going to add dependency the property spring.api docs path is going to be /API-docs. So after that, I'm going to define some other properties called as spring.doc.swaggerui.urls. So here I'm going to provide the URLs of our product service, order service, and the inventory service. So by providing these properties, OpenAPI will aggregate all these URLs and it will show us in a drop down in the API documentation page. So here what I have to do is the URLs property is actually taking a set of Swagger URLs. So for that, we have to define the URLs property as a set. So here for the first element of the set, I'm going to define I'm going to give an index of 0, and I'm going to define the name property as product service. And similarly, I'm going to provide the URL for product service. So this URL, I'm going to define it as /aggregate/product service /v3/API docs. So this will be the URL where we can access the product service Swagger documentation in the form of a JSON format. So we're just going to provide this URL, and after that we are also going to create a route to match this particular path and then route it to this particular URL of the product service. For now, let's copy this one more time and then define property for our order service. So I'm just going to define the index as 1, and I'm going to replace the product service with order service. Similarly, I'm going to define another property with index 2, and I'm going to name it as inventory service. Like this, we have provided the list of URLs to Swagger, and Swagger will aggregate and display this URLs in the UI. So the next thing we have to do is we have to create routes so that whenever a browser is sending a request for this particular path, we have to route them to the product service. So now to define the routes for this URL, we can go to the routes class inside the routes package, and I have already defined some routes. similar to how we define the routes for the product service, order service, and the inventory service. And the route bean I've created is called as the product service swagger route bean. And here you can see that I have defined the route ID as product service swagger. And similar to how we have defined the route for /API/product, I have also defined the route for /aggregate product service v3 API docs. And for the handler function, I'm going to define the handler function to refer to the URL HTTP localhost 8080. So this is the URL of the product service. And you can see another interesting function call here called as filter. So what this filter will do is, before calling the actual URL, what this will do is it will set the path instead of this /aggregate product service so on, it will set the path as /API docs, right? So instead of making the call, routing the URL to, I can show you an example. So instead of routing the URL to this location, what the filter will do is it will replace this whole path with /API docs, right? So at the end, the call which is being made to the product service will be HTTP localhost 8080 /API docs. So this is the URL where we are exposing the our REST API documentation in the JSON format. So this is what this bean will do. So similarly, I've created the same beans for order service. So for order service, you can see that the route is taking for the predicate path of /aggregate order service v3 API docs, and it has the handler function URL has HTTP localhost 8081. And also here we are defining the filter to set the path as API docs. So the same thing is going to happen also for the inventory service service swagger URL. So I'm going to set the same path for inventory service v3 API docs, which is pointing to localhost 8082. And I'm going to again set the path as /API docs. So this is the configuration we need to do to enable to aggregate the documentation inside the API gateway. So what I'm going to do now is to restart the application of the API gateway. So once the application is restarted, I'm going to open the browser, and in the browser I'm going to open the URL localhost 9000 /swaggerui.html. And you can see that it is returning us an error 401 because if you remember, we have defined the security configuration for the API gateway. So if I go to the security config, we have defined the security configuration for our API gateway. And here we are configuring that all the requests should be authenticated. And as we want to make this endpoint freely available, what we have to do is we have to permit some endpoint that can be accessed without any authentication. So for that, what I'm going to do is I'm going to define a string array called as free resource URLs. And inside this free resource URLs, I'm going to define some list of paths called as /swaggerui.html. So this is the actual path where we are exposing the HTML documentation, and /swaggerui, this is also a path where it will serve the other resources like HTML and JavaScript and CSS for the Swagger documentation. And the /v3 API docs is also the URL, by default URL, to expose the API documentation. And likewise, we have added all the URLs where we want to allow without any authentication. So the one thing you have to remember is I've also added the path /aggregate /star. So that means all the calls to this particular URL are also permitted without any authentication. So after adding this particular array, what I'm going to do is I'm going to define this inside the security configuration. After the authorize variable, I'm going to type in .request matchers, and I'm going to provide the free resource URLs here to the request matchers, and I'm going to call the method permit all. So what this configuration will do is it is going to permit all the author requests for this particular request matchers. So once you restart the application now and go back to the browser And now if I reload the application, now you can see that we are able to see the inventory service by default. And to the top right corner, you have the text called as selected definition. And if you click on this drop down, you can see that we are able to see the 3 services we have. So if I select order service, you can see the REST API documentation of the order service. So if I just expand, you can see that we have all the related information, the schemas, the request bodies, and the response information and all documented here. Likewise, we are also going to do the same thing for the product service. So the product service also has the schemas and the related API endpoints inside the documentation page. So that is how you are going to aggregate all the REST API documentation in the API gateway. And we are also going to do one refactoring now, as I mentioned. So what we are going to do is we are going to replace the Spring Cloud OpenFine library with the inbuilt REST client. So I had to do this because I realized after releasing the video that Spring Cloud OpenFine is actually not actively maintained anymore. And if you open the documentation of the Spring Cloud OpenFine, and if you click on the Learn tab and click on this reference documentation, right on this first page, it says that as announced in Spring Cloud 2022, we are now treating the Spring Cloud OpenFine project as future complete. We are only going to be adding bug fixes and possibly merging some small community feature PRs. And we suggest migrating over to Spring Interface clients instead. Right? So if you go to the Spring Interface clients, what this means is to use this REST client, which is coming from the Spring Boot, the latest Spring framework. So this is actually the preferred way to do the inter-service communication in Spring Boot. So we'll be migrating our logic to the REST client. So along with the REST client, what we are going to do is we are going to make use of the HTTP interface, where we can define the REST calls as a HTTP interface. So this, you can see this documentation that the Spring framework lets you define a HTTP service as a Java interface with HTTP exchange methods. So this is very similar to what our Spring Cloud OpenFine client is doing. So instead of, if I go back to the order service and the inventory client, you can see that we have defined the inventory client and we have annotated this with find client annotation, and we have defined the request mapping annotation with the request method here, right? So instead of doing that, what we have to do is I can just remove this find client annotation and also the request mapping annotation. And if I go back to the documentation, you can see that we can define an annotation called as get exchange. So just we can copy this get exchange and I'm going to paste this here, and I'm going to import this class from the web service annotation package, and I'm going to provide the path as /API/inventory. So that is all you need to do to define the interface, HTTP interface, and the request parameters and everything is going to be automatically taken care of by the Spring framework. So let's remove this unused annotations here. And another thing, so this is the interface we have to define, and we also have to define an implementation for this interface. And for that, we need to just create a bean for the REST client. So if I go back to the documentation, if I go to the REST client section, you can see that we can create a REST client in basically 3 ways. We can use the REST client class, you can use a REST template, you can use a web client. So as of now, the preferred approach is to use REST client, because you can also use REST template, but this is not favored anymore because the REST client provides us a much more easier API to write the calls, the REST calls. And for web client, it is coming from a completely different project called as Webflux. So if you want to use web client, you have to also add the Webflux dependency into your project, which is not really necessary if you just want to use web client. So we'll be using the implementation of the REST client in our project. So if I just click on this REST client class, you can define the REST client configuration in this particular manner. So we are just going to go back to our project and we are going to create inside the config package, I'm going to right click and create a new Java class called as REST client config. And I'm going to add the configuration annotation on top of this REST client config class. And here I'm going to just paste in one method called as inventory client. So I'm going to create a bean for the inventory client method, and I'm going to inside this inventory client, I'm going to first define the REST client by calling the REST client builder dot base URL, and for the base URL we have to pass in the URL of the inventory service. So for you have to create this particular field called as inventory service URL. And if I just open the application.properties file, here we have the inventory URL, inventory service as the inventory.url. So what we have to do is we have to add this inventory.url. We have to reference this inventory.url inside our REST client config class. So I can do that by using the value annotation. And here I'm going to provide the inventory.url here. So if you just have one property to bind to this class, you can use the value annotation, or else what you can do is you can also create a configuration properties class. So this is the recommended way to use the configuration properties class. If you have multiple properties, if you want to bind to the class, you have to use the configuration properties option. And or else you want to inject into one property value, you want to inject into the class, you can just use the value annotation here. So after defining this particular inventory service URL variable, what you are doing is we are creating a REST client adapter, and we are passing a REST client into this adapter class. And after defining a REST client adapter variable, we are providing this into the HTTP service proxy factory, and we are going to build a proxy factory, and inside this proxy factory we are going to create a client. So what this actually is doing is it's actually binding the REST client to the HTTP interface we have created in this particular interface, right? So you can see that this is like an interface, and this interface you can provide the implementations for different ways. So this implementation is specific for REST client. You can also create this same implementation for web client and also the REST template if you like. So this is the main thing you need to do to change the configuration from Spring Cloud Fine to the REST client using HTTP interfaces. Some other thing we have to do is we have to remove all the references to the Spring Cloud OpenFine starter. So for that, I'm just going to open the order service application class, and I'm going to remove this enable fine clients annotation. And the next thing I'm going to do is I'm going to open the pom.xml file, and I'm going to scroll down until I find the dependency Spring Cloud Starter OpenFine, and I'm also going to remove this dependency, and just make sure to click on the Maven icon to the top right side corner to force the IntelliJ to load the Maven changes. So once this is done, I'm going to restart the order service application. So now I've opened the Postman client, and here I have the configuration to call the submit order endpoint. I'm going to call the HTTP localhost 9000/API/order endpoint, and here I'm going to provide the body, the required body for the submit order endpoint, and I'm going to go to the authorization tab and select the auth 2.0 option. And I'm going to provide the client ID as Spring Cloud client ID. So this is the client ID we have created in the previous videos. So if you just open the browser, you can see that I've provided the client as Spring Cloud client ID, and inside the credentials tab, I can just copy this client secret. And let's go back to the Postman client. I'm going to make sure that I copy the client secret here. You can click on get new access token, click on proceed, and click on use token, and let's just submit this particular request. And if you click on send, you can see that we have the text order placed successfully. That means the order was placed successfully by using the REST client configuration and without the Spring Cloud OpenFine configuration to call the inventory client. So this is the small refactoring I want to do as part of this video. And in the next video, we are going to see how to implement circuit breaker pattern inside our API gateway and also the microservices. So we will also learn about why circuit breaker pattern and why to use the circuit breaker pattern. I will see you in the next video. Until then, happy coding techies. In this video, you will learn about circuit breaker pattern and how to implement circuit breaker pattern in our project using libraries like Resilience4j and Spring Cloud Circuit Breaker. So without any further delay, let's start the video. So what is circuit breaker pattern? A circuit breaker pattern is like a general best practice which is used in the real world distributed systems whenever our applications are calling some remote services or remote APIs or remote services. So in our project, if we take our project as an example, we have many services here. We have our product service, order service, and inventory service, and all three services can be accessed through the API gateway. And what can happen sometimes is any of these three services can go down or respond very slowly because of some performance issue on the database or on the network level or for whatever reasons. So when this kind of things happen, what happens is when the API gateway is calling the other service, for example, product service, which is responding very slowly, the API gateway has to wait for the response for the product service. As more number of calls are in waiting state, waiting for the response from the product service, what can happen is the API gateway can also gradually degrade its performance and can also be crashed. Right. So this is one of the issues which must be addressed when we are working with microservices or maybe distributed systems. And the other case is product service can also be crashed or maybe down. And the API gateway, whenever it receives any request, will keep calling the product service, even though we know that the product service is down, right? So is down and unreachable. Right. So what we can do is we can use the circuit breaker pattern, which is very similar to the circuit breaker we find in our homes, which will protect our electrical appliances. So in general, whenever you get a huge power spike at your home, what will happen is the circuit breaker will be tripped and the circuit breaker will block all the incoming power to the electrical appliances, right? So in the same way, the circuit breaker in the distributed systems, what it will do is whenever it recognizes that there are large number of calls which are failed due to the large number of API calls that are failed, what it will do is it will block all the outgoing requests from our service to the service which is not responding. So if we take our project as an example, so if the product service is unreachable or maybe slow, the circuit breaker will switch on and it will block all the requests from API gateway to the product service. So in this way, we can also implement the circuit breaker between the communication between order service and the inventory service. So if the inventory service is not working for any reason, the circuit breaker which is configured in the order service will block all the outgoing requests to the inventory service. So in this way, we can also save a lot of network calls, and it will also improve the performance because this can lead to cascading failures. That means if the order service is calling inventory service and maybe the inventory service is calling some other service, right? And this some other service is the actual reason for the failure. So then you are making some unnecessary calls all the way from API gateway, order service, inventory service, and then the other service, right? So what we can do in this scenario is we can already stop making calls from the API gateway itself if we know that the response from the order service we are receiving is not valid one. Right. So that's the circuit breaker pattern. So we can implement the circuit breaker pattern using a library called as Resilience4j. So I'm on the homepage of the Resilience4j library. So you can see that the Resilience4j is a lightweight fault tolerance library designed for functional programming, provides also higher order functions with circuit breaker, rate limiter, retry, or bulkhead. So these are all the resiliency patterns. Circuit breaker is one of the resiliency pattern which makes sure our application is resilient enough to external failures. The Resilience4j also comes with a rate limiter which makes sure that our application is not making a large number of calls to the external service. We also have a retry pattern and the bulkhead pattern. The retry pattern mainly deals with making sure that whenever there is an error, it will also retry the same call to make sure that it is not a one-off issue that is causing the failure. right? So we will have a look at some of these patterns in this tutorial. So we will also use Spring Cloud Circuit Breaker to implement the resiliency patterns using Resilience4j. So this is Spring Cloud Circuit Breaker is like a library which will help us to integrate this library, this Resilience4j and the circuit breaker pattern easily into our applications. So you can see that it provides an abstraction across different circuit breaker implementations. So Resilience4j is one of the implementation to provide the circuit breaker feature, and the other one is also Spring Retry. You can also use Spring Retry to use a circuit breaker pattern. So now without any further delay, let's go ahead into our project and implement the circuit breaker pattern in our project. So now I opened the API Gateway project, and as I mentioned before, we will start implementing the circuit breaker pattern first in the API Gateway, and then we will also look at the order service and see how we can implement the circuit breaker pattern over there. So for the first thing, what I'm going to do is I'm going to open the pom.xml file, and inside the pom.xml file, I'm going to add a dependency, two dependencies actually. The first one is going to be the dependency for Spring Cloud Starter Circuit Breaker Resilience4j. So this will add the Spring Cloud Starter Circuit Breaker and also the Resilience4j libraries to our project. And the second library is going to be Spring Boot Starter Actuator. So this actuator dependency will provide us the endpoints which we can use to track the metrics of our application. So this is useful also when you want to see the status of the circuit breaker. You can refer to the endpoints, the health endpoints, which is provided by the actuator, and determine in what state the circuit breaker is in our application. So after adding these two dependencies, make sure to click on the Maven icon to the top right side corner if you're using IntelliJ to force IntelliJ to download the dependencies. And after that, what we have to do is we have to configure the Resilience4j in our API Gateway project. So for that, I'm going to open the application.properties file, and here I'm going to add in some properties. So I'm going to explain, don't worry, I'm going to explain all of these properties in detail. So the first properties, the set of properties is going to be the properties for the actuator endpoints. So here we have this property management health, circuit breakers enabled true. So as the name suggests, we are going to enable the circuit breaker feature in the actuator health endpoint. So for that, we're going to we should define this particular property and set it to true. And we are also asking actuator to enable all the endpoints, to expose all the endpoints that it provides. We can also, of course, narrow it down to some specific set of endpoints. So for now, as this is like a demo project, I'm going to expose all the APIs, which are all the endpoints which are there in the actuator. And I've also added some property management endpoint health show detail always. So this particular property will make sure that we have all the health details about the application which are displayed always. These are the three endpoints for actuator. Next comes the properties for the Resilience4j. So this is where we are configuring our circuit breaker. We have this Resilience4j circuit breaker configs.default. So this is the property path. Whenever you want to apply the Resilience4j configuration as a default settings, you can use this path. And after that, we have this register health indicator property, which we also need to set it as true because we are also enabled the circuit breakers on the health endpoints. So if you also add this register health indicator, then it will make sure that the information is synchronized correctly. Then we have the sliding window type. That means the sliding window makes sure that how we want to determine the criteria to switch on the circuit breaker. So what we want to do here is we want to count the number of requests which are coming to the API gateway, and if the request threshold has crossed a certain limit, then we want to switch on the circuit breaker, right? As we are using the criteria to count the number of requests, I'm going to provide the sliding window type as count based. So if I just click on this, control click on this particular value, you can see that we have the sliding window as also time based. So you can also configure the sliding window to be activated after a certain threshold of time. So for now, we are just going to use the count based because this is the most reliable way for us to introduce the circuit breaker. So after that, we also have to define the sliding window size. So what is the number of request criteria we want to determine to activate the circuit breaker? So for that, I'm going to provide the size as 10. So it will count 10 requests at a time, and it will determine if we need to switch on the circuit breaker or not, right? And next comes the property failure rate threshold. That means if we set it as 50, that means in the 10 requests, the circuit breaker will be switched on whenever the 50% of the calls are failing, right? So in our case, if we set the sliding window size as 10 and the 50% of the calls are failed, that means 5 requests are failing, then the circuit breaker will be will be opened, right? And we also have this property wait duration in open state as 5 seconds. So for this to be able to understand this point, I have to explain you the different states of circuit breaker. So yeah, this is how the different states of circuit breaker looks like. So by default, the circuit breaker will be in the closed state, and whenever the circuit breaker is identifying a failed calls, then it will be changed to the open state. That means circuit breaker is active and it is blocking all the calls to the external system, right? And after the in open state, it will of course it cannot stay in open state indefinitely, right? So it also has to allow some of the calls to make sure that if the request is now reachable or not. So for that, it will we have the state as half open. That means we can configure circuit breaker to go from open to half open state after a certain time limit, right? For example, after 10 seconds, after 1 minute, whatever time limit, we can configure the circuit breaker to go from open to half open state. So in the half open state, the circuit breaker will still allow some of the calls, but not all calls, to make sure that to know if the other service is working or not. If the other service is still failing with the same errors, it will go back to the open state. That means it will continue to block all the requests to the external service. And if the circuit breaker identifies that, okay, then we are now getting a successful response from the external service, it will move the status back to the closed status. That means all the requests to the external service are now not blocked by the circuit breaker, and they are just transferred, and they are sent to the external service as it is. So these are the 3 different states when we are dealing with the circuit breaker. So now we are going to configure the time limit, make sure that the circuit breaker stays in the open state before going to the half open state. So for that, the time limit, we can configure it using the wait duration in open state as 5 seconds. So after 5 seconds, the circuit breaker will move from the open state to the half open state. And how many requests the circuit breaker will allow in the half open state, we can also configure that using the permitted number of calls in half open state as 3. So for my example, I'm going to make sure that I'm going to allow 3 calls to the external service in the half open state. If any of these 3 calls are failing, then I will make sure that then the circuit breaker will go back to the open state. And if any of these 3 requests are passing, then the circuit breaker will be set as closed. So at last, we have this automatic transition from open to half open enabled. So we are going to make it as true, because we want to, after 5 seconds, we want the circuit breaker to go from open to the half open state. So that's why we have on to add this property as true. So next up, we have timeout properties for Resilience 4J. So here you can see the property Resilience 4J, time limiter configs default, timeout duration. We have provided the timeout duration as 3 seconds. So we're going to use timeout whenever Resilience 4J is detecting that the external service is not returning the response in the determined amount of time. So that means if the external service is not returning any response in 3 seconds, what Resilience 4J will do is it will fail the request then and there, and then it will increment the counter for the circuit breaker. So if this kind of timeout happens 5 times in a row, as per our configuration, then the circuit breaker will be open, and all the further calls to this particular endpoint, the slow endpoint, will be blocked until the circuit breaker is in the half open state. This is for the configuration of timeout. So the next thing we are going to do is we are going to change the configuration of our routes to include circuit breaker. So what we did is we defined the circuit breaker configuration for the project, but we have to assign this configuration for the routes itself, because as if you remember, we have configured the routes manually inside the routes class. So we have to define now the circuit breaker to assign the circuit breaker to this particular routes. One thing I've also added is I've added a bean called as fallback route. So if you remember, this is we are using Spring Cloud Gateway MVC, and this Spring Cloud Gateway MVC, we are using the Web MVC functional endpoints. So using the functional endpoints, using Spring Web MVC functional endpoints, you can define a route using the route method, and then we can call the get method and pass in the path of the get method. So what this will do is it will create a get endpoint similar to how we do in Spring MVC world. We create usually a REST controller and then the get mapping method, right? So similarly, we can do all this very easily using this functional endpoints. So inside this get method, the first parameter is going to be the path, and the second parameter is going to be the lambda of the request. So whenever a request is received, we are going to execute this particular statement and then return the response, right? So what we are doing is whenever we receive a request, we are actually sending out a status as HTTP service unavailable with body service unavailable, please try again later. So this is far better than showing some blank response with error status. So whenever our circuit breaker, whenever the request is failing, we will be actually showing this error message, right? So coming to the actual configuration itself, what we can do is we have to define the circuit breaker as a filter. So we can define that by adding the .filter method here, and I'm going to add circuit breaker filter functions .circuit breaker, and this circuit breaker is going to take first parameter as the ID. So the ID is going to be product service circuit breaker, and the second parameter is going to be fallback URL. So whenever we receive a fail request, the circuit breaker will be calling this fallback URL. As we have already defined the fallback route with the endpoint path as fallback route, so what I'm going to do is I'm going to define a URI with the help of URI.create, and here what I'm going to do is I'm going to forward this request using this forward keyword to the fallback route. So that's all you need to do to configure our routes to use this circuit breaker. So let's copy this this particular method call, and I'm going to update all the other routes. So I'm going to just below the route method, I'm going to copy this filter with the circuit breaker filter function. So I'm going to change the ID as product service swagger circuit breaker, and now I'm going to again copy this and then do the same thing also for the order service. So that's all you need to do to add the circuit breaker to the routes. And one last thing we can also do is we can define the retry from Resilience4j. So I'm going to add a property for Resilience4j retry properties, and here I'm going to type in circuit breaker resilience4j.retry.configs.default.max atoms is going to be 3, and after that I'm going to wait a maximum duration of 2 seconds. So what I'm going to do is before the timeout occurs, I'm going to retry the slow request for a maximum of 3 times, and then I'm going to wait for 2 seconds for a maximum of 3 times, and then I'm going to retry only after waiting for 2 seconds. So if the external service is not returning a response in 2 seconds, then I'm going to retry this with a maximum of 3 times. If the retry is also not working, then the timeout will kick in, and then we'll actually open the circuit breaker. So this is all you need to configure the Resilience4j and circuit breaker patterns in your API gateway. Alright, so I've forgot to add one more property for our Resilience 4J circuit breaker configuration. So the property is going to be I'm going to add a property with name minimum number of calls. So this minimum number of calls is the minimum threshold to consider a circuit breaker. So if, for example, if we have a sliding window size of 10, and if we don't define this minimum number of calls, the circuit breaker we expect the circuit breaker to open if half of this number, if 50% of these requests are failing, right? So if we don't define this minimum number of calls, what will happen is a circuit breaker will not open until all the requests of the sliding window size are failing. So if I don't set this amount, if they don't set this property, then the circuit breaker will not open until all the 10 requests are failed. It will not take the failure rate threshold into consideration. So to avoid that, what I'm going to do is I'm going to add the minimum number of calls option as 5. So what the Resilience 4J will do is it will start consider the failure rate threshold once it reaches a minimum number of calls 5. As we have the failure rate threshold as 50%, then if the number of calls which are failing is 5, circuit breaker will now go into from closed to open state when 5 calls are failed. Now what I'm going to do is I'm going to start the API gateway application, and then we are going to test this implementation of the circuit breaker for API gateway. Alright, so now I'm going to open the Postman HTTP client. And here I have the call to get all the product information from the product service. So this call is of course made through the API gateway. And the first thing I'm going to do is I'm going to request a new access token from the Keycloak server. And I'm going to click on proceed and click on use token. So now I'm going to before making a call to the product service, I have already stopped the product service. So if I make one call to a product service, so if I make a call to the product service, then the request will fail. So before doing that, let's open the actuator health endpoint of the API gateway. So for that, I'm going to open the URL http localhost 9000 actuator health, and I'm going to make use of the token which I have requested just before, and I'm going to click on send. And you can see that the circuit breaker status is unknown. So that means none of the circuit breakers are yet registered, because we didn't make any request yet. So what I'm going to do now is I'm going to make a call to the product service, and you can see that we got the response service is unavailable. And if we now check the health endpoint again, you can see that the status of the product service circuit breaker, the health is up. But if you go into the details, the state of the circuit breaker is closed, right? And you can see that the number of failed calls is 1. So as the threshold of our number of failed calls is 50%, and we have to make a minimum of 5 calls, I'm going to make 4 successive calls now, as I've already made one call, 1, 2, 3, 4, and click on send. And you can see that the status is circuit open, and the state is now in the open state. And now after waiting for 5 seconds, if we try to check the health endpoint again, so I think 5 seconds is already passed. So if I click on send, you can see that the circuit breaker is going to the half open state, right? This is because we have the configuration to wait a maximum of 5 seconds in the open state and then go back to the half open state. So that's why the circuit breaker in the half open state, and if there are any past requests, now successful requests going to the product service, then after minimum of 5 requests, the circuit breaker will go back to the status of closed. So now I'm inside the product service. I'm going to start the product service application. If I click on send for the get product request, you can see that the response is fine. We are getting the response from the backend. And if you check the health endpoint, you can see that the status is still half open, right? So now let's make 4 other calls, successful calls, 1, 2, 3, 4, 5. And if I check now the status, that the product service breaker is in status up and it is now in a closed state. So the next part we are going to cover is to test the timeouts. So to simulate a timeout, what I did is to, inside the product service, get all products endpoint, I've added a thread.sleep, a wait for 5 seconds, so that it simulates a slowly responding API. So I just add this thread.sleep for 5 seconds, and then I restarted the product service application. And now if you open Postman and again make sure you get a new access token and use that token, and if you call the products service, you can see that we are getting a slight delay, of course, because there is also a retry and timeout. It's happening on the API level, API gateway level. So this is one request. So now let's make 4 other requests, because this is the minimum number of calls for circuit breaker to activate. So for the 5th request, you can see that the response is instantaneous. We are not getting any delay because the circuit breaker is now went to the open state, is now in the open state. And if you stay in this open state longer, then you will be redirected. Then the state will be changing to the half open state. So now if I want to check the actuator health endpoint, you can see that now the circuit breaker is in the half open state. So now if I try to send another request, you can see that now the circuit breaker is in state open. Now if I go back and then remove this thread.sleep and then restart my application, and now if I try to call the get product endpoint, so I get the response pretty quickly. And now if I check the actuator health endpoint, you can see that now the state is closed. Alright, so in this way you can see that we can also implement the timeout feature, so that our application, our API gateway is not affected even with the slow performing services, and there is also not degradation of the user experience in this way. Alright, so now it's time to implement the circuit breaker pattern inside the order service, mainly with the communication from the order service to the inventory service. So for this, the implementation is very similar, but there are only some small changes. So for that, I'm just going to walk you through the changes. So I will not be doing the live coding for this part. So the thing we have to we have to do is we have to make sure first that the 2 dependencies, for the first one is circuit breaker resilience 4j, Spring Cloud Starter circuit breaker resilience 4j, and the Spring Boot Starter actuator dependencies are added to the order service pom.xml file. And after that, inside the application.properties file, so I'm going to add the same properties which we have added inside the API gateway, but the only difference here is in the property. Instead of adding the property resilience4j.circuitbreaker.configs.default, so that is the property prefix we added for API gateway. So if I open the API gateway, you can see that the prefix is resilience4j circuit breaker configs.default. But now what we want to do is we want to add this to a particular instance of our REST client. So that's why we are going to use the prefix circuit breaker.instances.inventory, and also the name of the client is our REST client is also inventory. So that's why I added the name as inventory here. So to actually apply this changes, what we have to do is we have to open the inventory client, and what I did here is to add 2 annotations. The first one is the circuit breaker annotation, and the next one is the retry annotation. It's important to provide the name of the circuit breaker, the name of the resilience4j instance as inventory, because this name should match with the instance name we have provided in the properties file. And again, in the API gateway in the API gateway configuration, we have added the fallback route by providing forwarding the request to the fallback route and then sending the response as service unavailable. But here what we will do instead is we will handle this more gracefully by providing a fallback method, and inside this fallback method we will be just logging this information that we are not able to access the inventory service, and we are just going to return the inventory as false. That means it makes the order service will identify that something is wrong with the inventory service, because the order service will not able to accept any orders because the inventory service is not working, but we will not face any degradation of the user experience. So this is for the circuit breaker and the retry annotations, but we have another thing we have to implement, that is the timeout. We can use for the timeout, we can use the time limiter annotation from Resilience4j, but to implement that we need to complicate the things a lot. So instead of adding this time limiter, what we can do is we can add the timeout to the REST client itself. So we can just configure the REST client to have a connection timeout and as well as a read timeout. So if we don't get a response back in a stipulated amount of time, then the REST client will automatically terminate the connection. So to do that, what we can do is we can open the config package and we can open the REST client config class. And in here, I've added some configuration for the REST client. So I've added for the REST client builder, I've added the .request factory method here, and inside that I'm going to call the get client request factory method. This is the method I created, and inside that we are calling the client HTTP request factory settings class, and we are using the default option of the client request factory settings. Instead of defaults, we can also use other implementations, because there are many implementation of the client HTTP request factories. So if you go into the request factories, you can see that in the get method, it can support multiple request factories. The first one is HTTP components client HTTP request factory, a Jetty client request factory, and OK HTTP3 and simple client HTTP request factory. So we don't want to bother ourselves by picking one of them. So I will just make use of the default client HTTP request factory by just calling the defaults variable, and then we can construct our timeout and the read timeout by calling the with connect timeout and then with read timeout methods. And to this methods, I am just going to provide a duration of 3 seconds, because I want to have a connection timeout and as well as the read timeout as 3 seconds. So once this is done, what I'm going to do is I'm going to get the client HTTP request factory from the HTTP request factories class, and then this is going to return and then set the request factory before we build the REST client. So once we configure all of these things, then we are ready to test our changes. So I'm going to start the order service application now. So once the application is up and running, we can go ahead and test our changes. So I'm going to submit an order. So first I'm going to get a token from Keycloak. I'm going to use the token and then click on send. You can see that we are getting a 500 error response. This is because we are not able to because the inventory service is not working, but we are able to gracefully handle this inside the fallback method. So you can see the log cannot get inventory for SKU code iPhone 15, and the failure reason, we also have the failure reason, the reason of the failure. So we have IO error on get request for the inventory service URL with the reason as connection refused. So instead of seeing the reason as connection refused, we are now seeing the error 500. Of course, we can make it even more better by not throwing a runtime exception, but maybe doing some other fallback logic here. So that's not necessary for our tutorial. So I'm just going to keep this simple. So in this way, you can configure also the order service with the circuit breaker functionalities. I hope you learned something new in this tutorial, and I hope you liked the content. I will see you in the next tutorial. And until then, happy coding techies. In this video, we will learn how to set up the Angular application for our Spring Boot microservices project. So we'll be mainly covering how to set up the Angular application and how to run the application on your local, and I will do also a quick walkthrough of the application. So we'll be not doing a detailed coding of the whole application, but I'll be providing you a link to the guide on how to develop the application step by step, so that you can read it on your own pace and read it at your own pace, and then follow along and then try to build the application from the ground up. So without any further delay, let's start the video. So you can find the link to the blog post in the description section of this video. So as you can see that, so this is a detailed blog post on how to build this Angular application step by step. So I'll be covering all the steps on how to build the Angular application. So after looking at through this code walkthrough video, you can just follow this tutorial and build the application on your own. So the first thing before we start and try to set up the application, we need to install some prerequisite software. So the first one is going to be the Node.js. So you make sure that you have the latest version of Node.js installed on your machine, and we also need to download the npm package, so that you can download the necessary npm JavaScript packages onto your machine and to run the Angular application. And last but not least, we have to download also the Angular CLI. For that, I have also added the link to download the Angular CLI in the blog post. So make sure to check out these 3 links and install the software before we go ahead and start our application. Right. So once you installed all these 3 software, all these 3 CLI and software, you can go ahead to GitHub. To this microservices shop frontend repository. I will also leave the link to this repository in the description section. So what you can do is you can just check out this particular repository. So here it has all the code for our application. So just make sure to download the code to your machine, and then we will open this code in the IntelliJ. So after opening the project in IntelliJ, so just make sure to expand and check you have all the necessary files. You need to have the source folder, the public folder, the screenshot folder, and also the main ones are this AngularJSON, package.json, and the tailwind config.js files, right? So after you download the repository, you just have to run npm install to make sure that all the packages from this package.json are installed, and all the application and the whole application is installed and ready to run on your local machine, right? I've already installed this, so I don't want to run this one more time. So make sure to run npm install before you do anything else as a first step, right? So after that, we are almost ready to run our application. So what we have to do is we have to run npm start. So this npm start will actually run the command ngserve, which will start up the application on the port 4200 on the port 4200. So just run this npm start command, and you can see that the application is running on the port 4200 at the local host. So if you try to open, try to open a new tab and then restart this local host 4200, reload this page, you can see the screen like this. You have that message that there are no products found, and you have the option to click on to login here. So if you click on login button, you will be redirected to the login page. Of course, if you are doing it for the first time, you may get an error, but I will just show you the application walkthrough, and then I will show you how to set up a client in Keycloak to be able to log into our application using your front end, right? So I have created a new user called test user. So I'm going to enter the username and password as test user, as you can see, and I'm going to click on sign in. And you can see that there are 2 products which are coming from the product service, and these are the product is iPhone 15 with price 1500, Pixel 8 with price 900, and you have the options to click to order a product by clicking on the order now button, but we have to make sure that we have to provide a quantity. So because if you click on order now, you will see that the order is failed because quantity cannot be null. So if I provide the quantity as 1 and click on order now, you can see that the order is placed successfully. So in the background, if I open the developer tools and go to network, if I now click on order now one more time, you can see in the dev tools that we have we made a call to the backend microservice. We are calling the localhost 9000/API/order endpoint with the token, and the API gateway is returning the response 201 created, right, with the response as order placed successfully. This is how we are going to communicate from our front end to the back end. We also have the other functionality to create the product. So if I click on create product, you can provide the SKU code, name, description, and the price. So you can also see that we are doing client-side validation on the form level. So if the SKU code, name, description is not provided, then we are showing an error message that the SKU code, name, and description is required, right? So I will not add this information again. So just let's add this SKU code. So like test SKU code, test, and the price is going to be 1. So I'm going to add the product, and you can see that the message product is created successfully. If I go back by clicking on the Spring Boot Microservices shop heading, you can see that we are able to see the product we just created called as test. So we can also log out from the application by clicking on the logout link here, and you can see that we are not showing any products for the users which are not logged in. So this is a high level overview of how our application GUI will look like, our Angular application GUI will look like. So now let's go ahead and start to set up our Angular setup configure Keycloak to make sure to configure our Angular front end with the OAuth capabilities. So for that, I'm going to open the localhost 8181, and this is and you will see the URL, the login page for Keycloak, and here I'm going to provide the username as admin and password as admin, and click on sign in. And here we have our realm, Spring Microservices security realm, which we have created previously. So here I'm going to click on clients, and I already have the client which created here. So I'm going to delete this client one more time. I'm going to recreate it one more time so that you can follow along. So I'm going to click on the button create client, and here I have to provide a client ID. So this is very similar to how we created a client for accessing the API gateway. So the name of the client is going to be Angular-client, and I'm going to click on the button next. And here it's important that we have to select client authentication as off, because this is a public client. The client we have created before, the Spring Cloud client ID, is a private client, so confidential client. So we need to select the option confidential. But for our option, I think I've clicked on back. So let me go ahead and create this client one more time. The client ID will be Angular client, and I'm going to click on next. And for our case, we will have to select the client authentication as off, and we have to select the standard flow, because here we are using the authorization code flow mechanism with PKCE variant. So if you're not aware of all these flows, what is standard flow, what is direct access, what is service account roles, make sure to check out my Keycloak tutorial already available on my YouTube channel. In there I've already explained in detail what are the different flows in OAuth 2 and how to configure them in your in Keycloak. So for now we don't need this direct access grants, because using this direct access grant we can directly access the client using the username and password of the user. So we don't need that. So I'm going to unselect this option, and we'll just go with the standard flow. So I'm going to click on next. Next, I'm going to provide the valid redirect URIs. So this will be the URL from which Keycloak will redirect after successful authentication by the user. So we want to navigate after the successful login. We want to navigate back to the home page of the Angular application. So the home page is going to be http localhost 4200. And the web origins, and we have to provide it as star, because we don't want to restrict any URL to access our application. We want all the URLs, we want our client to be accessed by everywhere by all the websites. So I'm just going to provide the option as star. So if you have a functionality where you want to allow requests only from a certain website, certain origin, then you can provide the link of the origin, the URL of the origin here. So for example, if I want to make sure that my client is accessible only from localhost 1200 or maybe 5200, so then I have to provide this URL. If I don't have those kind of restriction, I can just provide star, and then it will include it will allow requests from all the origins. So you can also read about this in the pop-up here. So after adding this configuration, I'm going to click on save, and this is what you need to do to create the client ID for our Angular application. It's the name Angular client. So after adding this in a configuration, we are now ready to start our application. So make sure to stop this application by typing Ctrl+C and then start this application again by running the command npm start. And now if you go back to localhost 4200, you will be again able to log in. And one more option I forgot to add is you can allow the user to self-register themselves by providing a link to register. So if I click on register, I can register myself as a user. So to enable this functionality, I have to go to Keycloak and then click on realm settings, and I'm going to go to the option login, and here make sure to select the option user registration. Make sure to have the option as on. So once you do that, the Spring Keycloak will automatically enable this functionality, and you can just provide the information like test user1. The password is going to be test user1. I'm going to provide the same value again. The email is testuser@gmail.com, and first name is test1 and the last name is user1. So of course Keycloak is not going to do email validation out of the box. You can also you can also do a lot of things. Like if I go back to the Keycloak administration, you can see that we can enable the forgot password, you can enable the remember me, and you can also enable the functionality to verify the email. So if you want to also select this option, then you need to configure a lot of things like an SMTP server to send out emails to this particular URL. So I don't want to complicate this with this information, so I'm just going to leave everything aside and then click on the register button, and our application is logged in automatically. So after the successful registration, and the Angular application is logged in, and you can see that we are able to see the application name as test user1. So this is the username. So, and if I click on logout, I will be logged out from the application. So this is a high-level walkthrough of the application. Now let's go into the code and see how the code is implemented. So we have so I'm right now in the IntelliJ, and the first file I'm going to show you is the package.json file. So this is the like a pom.xml file for our Spring Boot project, where you have all the information about the dependencies and how our project is built. So we have the commands, the build, where you can run npm run build, and this will start the command ng build, which will build our Angular application. So you can also run the tests by running the npm run test command. And we have the dependencies here. So mainly we are using the Angular version 18 for this project. This is the latest version as of developing the project. And to enable the OAuth 2 functionality, I'm using the dependency Angular OAuth OIDC client, which is also the latest version as of now, which is 17.1.0, which is compatible with the Angular version 18. And we have some supporting libraries like RxJS, TSZone.js, which is our prerequisite for our Angular project. Coming to the dev dependencies, the interesting thing here is the Tailwind CSS. So this is Tailwind CSS, if you're not aware, is like a CSS framework. Implement CSS, nice looking CSS in our application. And of course, this is not a beginner level tutorial. So if you're completely new to Angular, I prefer you will be lost. So I suggest you to refer to a good beginner level Angular tutorial first. See how to build a small application, a to-do application on Angular, and then come back here and then try to follow this tutorial, because then it will make more sense. Because if you're a complete beginner to Angular, then you will be lost, because this is a lot of information for you to process and then take action, right? So having said that, let's move on to the next file. There's going to be this tailwind config.js. This is the configuration for our tailwind. So here under the content array, we have to provide to which files we have to apply the tailwind configuration. So this is going to be all HTML files and TypeScript files, because we can essentially also have HTML inside the TypeScript component files. So that's why I have included the tailwind to be applied to both HTML and TypeScript files. Once this is done, let's go to the source. Let's go to the source, and here we have the index.html file. This is nothing new. This is just a normal index.html which is coming out of the box from Angular. And we have our styles.css file. Here I have provided the different layers for Tailwind directives. So we have added the Tailwind base directive, components and utilities functionalities from Tailwind. And if I expand the app folder, you have different files here. One thing, if you are used to Angular prior to Angular 17 or prior to Angular 16, one thing you can observe is there is no app module.ts file, right? Because in Angular 17 and Angular 16, there is a huge change of paradigm on how you develop the application, because modules are no longer prerequisite to develop Angular application, and there are lots of changes. So we are going to go with the latest approach on how to build the Angular application. So the first thing we are going to have a look at is the app component.html file. And here we have the app header, which is a component we have created to have the header to display the header. So if I go command click on this app header, you will be taken to the header component, which is there under the shared folder. You have the header, and here we have the header component.ts file. So here you can see that this header component is implementing onInit interface, and inside the ng onInit we have the call to the is authenticated method from OIDC security service. So this OIDC security service, we are injecting it into the header component class, and this is the main class of where you can access the auth functionalities from the Angular auth OIDC client dependency. So if I just click on OIDC security service, command click on the security service, you can see that it has a multiple methods which we can use to implement the security functionality, authentication and authorization. So we are trying to query the is authenticated method from OIDC security service, and we are subscribing to that particular response and then assigning this response to the is authenticated Boolean variable, because we will use this is authenticated Boolean variable to either show the login or logout links, right? So we'll have a look at it in shortly. But let's complete what is the configuration inside the ng onInit. So then the second part is we are calling the user data method from the OIDC security service. So what it will do is it will fetch the user information from our Keycloak server, and in the user data we are mainly interested in the preferred username variable. So I'm going to assign this particular preferred username to the username variable which I've defined on the class level. So, and we have methods to do the login and also the logout. So in the login method, I'm calling the authorized method of OIDC security service. So, and in the logout, I'm calling on the logoff method of the OIDC security service. And as this logoff is going to return an observable, I've just subscribed to it and then added a message to the console, just so that the logoff will be executed successfully. So let's go to the header component.html file now and see how the HTML is looking like. So here we have our heading called as Spring Boot Microservices shop inside an anchor tag. and which is redirecting to the home page, to the localhost, the home page. And next we have our logic to display the login or logout links. So if the user is authenticated, then I'm going to display a anchor tag with the text as logout. And I'm also going to display the username by providing the text as hi followed by username. And if the user is not authenticated, I just see the the link with the name as login. And if I click, and I also provided a click directive, so whenever the user clicks on login, it will call the OIDC security service.authorize method. And in the same way, when the user clicks on logout, the user will be logged out through the logoff method from the OIDC security service. So again, if you are not able to understand, if this is fast, and if you're not able to understand, feel free to check out the guide for which I've linked in the description section. This is not, I've actually not planned to include this as part of the tutorial, but I thought I saw many of you were requesting this, and then I added it as a bonus. So please try to see it like that, and don't and it's not possible for me to create a full-fledged tutorial on Angular because that will unnecessarily drag out the whole series, right? So moving ahead, there are other, this is the header component. There are also other components under the pages folder. So under the pages folder, we have the home page. So if I open the homepage.component.ts, here we are also implementing the ng and onInit interface. And here we have the ng onInit method, where we are again calling the is authenticated method from OIDC security service. And then we are assigning it to the Boolean variable. And here what we're also doing is we are calling the product service to read all the product from the product service. We are doing this using a method called as getProducts. So if I click on getProducts method, you can see that we are using the HTTP client, which is coming from Angular HTTP module. So we are making a get call to the URL http localhost 9000/API/product. So this is the URL to access the product service through the API gateway. And this is going to return us an array of product. So I also created a model class to hold the response for the product. So if I click on product, you can see that I've created it under the model package called as product.ts, and it has an interface with fields IDs, Qcode, name, description, and price. And one thing I have to tell you is this Qcode is initially not included in the product service. I've added it just for this tutorial. So I've also adapted the product service to take in this Qcode. So if I'm going to open the product service. So, and I've added Qcode as one of the fields for the product request record. And I'm inside the create product method, I'm also populating the value for Qcode here. And of course, I've also added this field inside the product class. So make sure to adapt this logic also accordingly in your code. So let's go back to our Angular application, and here I'm going to go back to the product service, and you can see that this get products is returning an observable of array of product. So that's why I am subscribing it and assigning the result to the products variable. So this is nothing but an array of products, and I've initialized it to an empty array by default. And here we have also the method to go to the product page. So go to the create product page. So I will come back to this part later, but we have also the method called as order product, where we are taking in a product and the quantity, and we are first calling the user data endpoint to get some user information, because if you want to create an order, we also need some user information. So from the user data, I'm extracting the information about the email, first name and last name, and storing it in the user details variable. And here we are doing a check such that if the quantity, which is a string, which if it is not defined, then I'm going to provide the status as false, because we are tracking the status using some Boolean variables. So we have this variable called as order failed. I will be setting it as true, order success will be false, and quantity is null will be true. And if the quantity is valid, I'm going to create a object of type order. So in this order, we have the SKU code, price, quantity, and the user details. I've populated all this information, and I'm going to call the order product method of the order service. So I also created the order service, and I'm going to click on order product. And here you can see that we are making a call to the endpoint HTTP localhost 9000 /API/order. And this is going to be a post request, right? We have also defined the headers to make sure that we are expecting the information as JSON, the content type as JSON. And as this order product submit order endpoint is returning us a text called as order processed successfully, we have also explicitly defined the response type to be text, and we need to read it as a JSON. After executing this order product, we are going to subscribe to that result, and based if it is a successful response, then we are going to set order success as true, and if the order has failed due to some reason, then I'm going to set the order failed as true. So this is not going to be false, but this should be true. So once this is done, now I can go ahead and show you the home page. So if I open the homepage.component.html file, you can see that in the HTML, first we have the h1 tag where I'm have the title called as products, and I'm going to show you the length of the products which we are reading from the backend. So if the products array is empty, then you will just see the products as 0, and if the user is authenticated, then we are showing a button called as create product. So if the user clicks on this create product button, then we'll go to the create product page, and inside this method we are just navigating to a new URL called as add product. So we'll see again what is this add product, what is the code of this add product. So let's go back, and after that we have a check which says that if the product's length is greater than 0, that means if there are really some products to show, then we are looping through all the products using the new first statement from Angular 17. And then we are looping, and we are just displaying the product information. So inside a span, I'm going to display the product name, the product price, and I'm also product price. And I also have a button called as order now, where if you click on this button, again, as I showed before, we'll call the order product method, which will call the order service endpoint. So in the else case, we are showing the error message, no products found. So that's what we do. Like if there are no products to be displayed, or if the user is not logged in, we'll just show the information no products found. So that's it with the homepage component. So now let's see the add product component. So let's expand this add product and go to the add product.component.ts file. And here you can, if I just scroll up all the way up, here we have the add product component, and inside the constructor, we are defining a form builder object, injecting a form builder object into our component, and inside that we are creating a form group called as add product form. Because if you remember, let me log in one more time. Let me log into this application one more time. We have the create product form. So this is the form we want to build. So here we have 4 fields: the SKU code, name, description, and price. And we have created a form group to accommodate the values of that form. So this add product form has a form group for the field SKU code, name, description, and price. And we have added the validators for each one of them. We have added the validators as required. And after constructing the product form, during the initialization of the add product component, we have the onSubmit method. So let's have a look at it later. We'll go to the add product.component.html file, and here you can see that we have a h2 tag with a title called as add product, and we have a form with the form group as add product form. And whenever this form is submitted, we are triggering the ng submit directive, and this directive is calling the onSubmit method. And inside this form, we have again just a normal HTML where we have the input for SKU code, and the form control name is SKU code. Here you have to make sure that the form control name matches in the HTML as well as the product form here inside the form group, or else the logic will not work, because or else the validation and all will not work. This is one thing you need to keep in mind. So again, we also have this ngIf, where we are checking if this Q code value is valid or not. Next, we have the field called as name. So likewise, we have the same logic for the name field. We also have the same validation. We have the field for description, and lastly we also have the field for the price. So once this is done, we are adding last one we have is the button, which is of type submit, and which has the text as add product. So whenever this button is clicked, then Angular will call the onSubmit method, and it will execute all this logic here. It first checks if the product form is valid, and if the product form is valid, then we are going to create an object called as product, which contains the information Q code, name, description, and price. And this information we are getting it from the add product form .get method, and we are populating all this information and passing it to the create product method of the product service. So inside the create product, you can see that we are calling the HTTP post endpoint for API gateway. So this is the post endpoint of the product service, and we are passing the product as the HTTP request payload, and this is going to return us an observable of product. So we are subscribing to this observable of product, and then we have the variable product created. We have set this value as true, and whenever a form is submitted, we want to reset the form, because we don't want to see old values again and again. We want to reset the form, so that's why we have this logic this.addProductForm.reset. Right. So once this is done, this is the main logic we have also for the add product component. So now let's have a look at the configuration of OAuth 2 in our Angular product. So for that, we have the auth-config.ts file. So in our Spring Boot project, we have added the properties inside the application.properties file. But for Angular, we have to do it a bit. Of course, we have to do these things a bit different. So inside the config object, we have to create an object called as config, and here we have to provide different values. The first one is going to be authority. So this is the issuer URI we are using in our project. So if I open the API Gateway project, you remember that we have provided. If I open the API Gateway project, you remember that we have provided the issuer URI as this URL. So we just have to copy this and then provide this value here, so that our application can talk to this issuer URI and then start the OAuth flow and all. And we also have the redirect URI, which is going to be the location of the present browser tab, is going to be localhost 4200 in our case. And the client ID, as we have created before, it's going to be Angular client. And the scope I've provided it as some default scope called as OpenID, profile, and offline access. The offline access makes sure that your tokens are refreshed automatically. So it will enable the refresh token functionality. So make sure you also add this offline access scope. And then lastly, we have the response type as code. So then our Angular application will use the authorization code flow mechanism. And this is how you configure the Angular OAuth to OIDC client dependency in library in your Angular project. So once this is done, we also have to have a look at how we also have an interceptor. So you can see that we have different calls from our services, the calls in the product service, the product service, which is making a call to the API gateway, and also the order service. But here one important thing is missing, that is the access token. The access token is not assigned manually when we are doing the calls here, but we want to do this automatically for all the outgoing requests from our application. So we can do that with the use of an interceptor. So that's why I also created an interceptor inside the interceptor package. And this interceptor is going to be, here inside this interceptor, I'm first injecting this OIDC security service. And then I'm calling it as auth service, and then I'm calling the auth service.get access token method, and I'm subscribing to this method. And then if the token is valid, then I'm creating a header, authorization header with a bearer token. and then adding it to the request by using the request.clone method, right? So what this will do is it will add the bearer token to all the outgoing requests from our application, and this will only happen if the access token is valid, right? So if if there is a call which is being made to Keycloak for the very first time, then this logic will not be invoked, because this get access token will return an undefined value, right? So in this case, this logic will not be executed because we have using it inside the if condition. So only valid token value will be taken into account. So after adding all this information, one thing I have to explain is the appconfig.ts file. So this is the main configuration we have, and here we have to enable some options to be able to access the HTTP client, to be able to enable the auth to functionalities, and also able to enable the routing. So for that, we are using the provide router method, and we are providing the routes variable here. So if I just click on routes, this is coming from the app routes file, so approutes.ts file. And here we have nothing but the route configuration on the home page. If you don't provide any URL path, so if you are just accessing HTTP localhost 4200, so that means you are using the path as empty. There is no path URL path variable. So in this case, the Angular will route this path, and it will route to the homepage component. And if we have the path as add product, then it will route to the add product component. So that's why inside the homepage.component.html file, if I scroll all the way up, we have this create product button, and on the click of this button, we are going to execute this go to create product page, right? So inside this create product page, we are using the Angular router to navigate to the URL /add product. So that means whenever this create product button is clicked, then the Angular application will load the add product component, which is because we have defined the route as add product inside the routes array. So if you want to enable all this functionality, we also have to use this provide router and pass in the routes here, or else the routing will not work. So similarly, have to pass this auth configuration we saw before. This whole auth config object, we have to pass it to the provide auth method, and finally, to be able to instantiate this interceptor, to be able to register in interceptor, we will be using the provide HTTP client method with interceptor as auth interceptor. So we are going to provide the reference of the auth interceptor to the provide HTTP client with interceptors method call. So after adding all this information, then our application is configured completely. So I think I have covered all the relevant parts, almost all the relevant parts of this Angular application. So again, if you are not sure, just have a look at this video, understand on a high level how this works, and go to the blog post and try to implement this yourself, because I will just provide some more context about this application, and you will see step by step how to build this application by referring to the blog post. So I hope this video is helpful for you, and I will see you in the next video. And in the next video, we will have a look at how to implement event-driven microservices using Spring Kafka. We will also have how to work together with the schema registry. We will use the Kafka broker together with the schema registry, and we'll see what are some best practices used in the event-driven communication with Kafka when you're working with Spring Boot projects. And I'll see you in the next video. Until then, happy coding techies. In this video, we will learn how to integrate Kafka into our microservices project and see how to build event-driven microservices using Apache Kafka. We'll also integrate some best practices like using schema registry, and also learn how to write integration tests when you are dealing with Apache Kafka and Spring Boot. So without any further delay, let's start the video. Alright, so let's start by learning what is Kafka. So Kafka is a distributed event streaming platform or a messaging platform which is used to build event-driven architecture, event-driven applications. So this is a very widely used software in the industry right now. So whenever you are going to use a messaging platform, you will have an option to use Apache Kafka because it's very reliable. It has some features like high availability, so it can have highly available clusters set up across different availability zones. And also the core feature of Kafka is it provides a permanent storage of the messages, and of course it is very scalable and it provides very high throughput of messages. So if you're new to Kafka, I suggest you to go to this kafka.apache.org website and explore explore about Kafka. We will mainly deep dive into how to integrate Kafka into our project and with Spring Boot. So to integrate Kafka with our application, Kafka with our project, we'll be mainly using the Spring for Apache Kafka library. So it provides good abstraction and libraries to integrate with Kafka. We have some Kafka template which helps us, enables us to easily send messages to the Kafka topic, and also Kafka listener annotation, which creates a listener which will read the messages from the Kafka topic and helps us to process the messages. So we'll also see how to use this library. So if we go back to our architecture diagram, you see that our order service will be making the asynchronous communication with the notification service. So we'll be using Kafka here for the asynchronous communication. So what I'm going to do now is to enable the Kafka integration in the order service, and after that we will create the notification service, which is actually sending out emails to the customer by reading the messages from the Kafka topic. So now let's open the order service. Alright, so I'm inside the order service project, and the first thing I'm going to do is to install Kafka in our project. So for that, I'm going to open the Docker Compose file, and I've already added some Docker Compose, some services to the Docker Compose because it's easy for me to just explain this Docker Compose file instead of you watching me type all the services one by one into the Docker Compose file, right? So what you have to do is just go to the blog post, which will be linked down in the description section. So if you go to the blog post here, in the first section, installing Apache Kafka through Docker, you can just copy the whole Docker Compose file. It contains all the necessary services to run Kafka. So if you go back to our IntelliJ, you can see that the first service we have is Zookeeper, something called as Zookeeper. So Zookeeper is also an Apache project. So this is mainly used to orchestrate different clusters of Kafka, right? So Kafka can run in a clustered environment, as we saw in the previous in the Kafka website. It's highly available. That means it runs across different clusters. So Zookeeper acts as an intermediary where it manages different clusters, right? It manages the state of different Kafka clusters, and it has centralized storage to manage state of the Kafka clusters. So Zookeeper is used mainly as an orchestrator. So that's why we need Zookeeper. So for Zookeeper, we are using the image Confluent Inc. CP Zookeeper version 7.5.0, and I'm going to call the host name as Zookeeper and the container name as Zookeeper. And of course, I'm also going to expose the port 2181. So this is the port in which Zookeeper will be running. So I'm going to expose Zookeeper on the same port. And finally, I have two environment variables, Zookeeper client port as 2181 and Zookeeper tick time as 2000 milliseconds. So this is the configuration for Zookeeper. In the latest version of Apache Kafka, there is no need to use Zookeeper anymore. You can use something called as Kraft, but I'm not going to use that right now. So just as an information that you can also use Apache Kafka without Zookeeper. So next comes the service Kafka itself. So I'm going to call this service as broker. Instead of Kafka as broker, and we are going to mainly use the image Confluent Inc. CP Kafka 7.5.0, the version 7.5.0. The container name is going to be broker, and here I'm going to expose two ports, 9092 and 29092. And this Kafka service depends on Zookeeper because before running Kafka, it needs it needs to register itself with Zookeeper. So that's why we depend on this container first. And we also have some environment variables, the Kafka broker ID, which is uniquely identifying the broker. And after that, we also have to provide the environment variable to which service the Kafka should connect for Zookeeper to register itself with Zookeeper. So for that, we have Kafka Zookeeper connect environment variable, which is we are providing it as the container name Zookeeper followed by the container port 2181. Finally, we have some security configuration like Kafka listener security protocol map. So here, as we are using just in the local development, I'm just going to provide the security protocol as plain text. So, or else you can use SSL and TLS security protocol when you are using it for production. And we also have Kafka advertised listeners. That means these are the listeners where Kafka is accepting the connections, right? So we have two listeners, plain text on the name broker 29092, and for the plain text host, localhost 9092. So mainly if you are communicating from one container to other, so if you want to access Kafka from one container, from a different container, you will usually use this 29092 port. And if you want to use this from your localhost machine, you use localhost 9092. So that's why we have exposed two ports, 9092 and 29092. Finally, we have the Kafka offsets topic replication factor environment variable. We are going to set it as 1. And we have another service here called as schema registry. I'm going to come to this part later. So let's to make you understand why we need schema registry, first we have to try to develop the logic to send out messages to Kafka from our order service, and then we will come and enhance it with schema registry. So lastly, we have the service called as Kafka UI, which provides a nice UI where you can view the topics and the messages which are there in the Kafka topics. So for that, we are going to use the image Kafka UI from Provectus Labs. I'm just going to use the latest image, and I'm going to run this container on the port 8086. Internally in the Docker container, it's going to run on the port 8080, because as we are already using the port 8080, I'm just going to map this into a different port 8086. And this Kafka UI is going to depend on the broker and the schema registry, because it needs both of them before we run this application. So for now, we can just remove the dependency to schema registry. We'll add this back once we want to integrate again the schema registry. And lastly, we have to have the environment variables. Kafka cluster's name is local. That means we are just going to use the local cluster here. And the cluster bootstrap servers, I'm going to provide the address as broker 29092, because here you can see that the Kafka UI is running in its own Docker container, right? And if it wants to connect to this Kafka running in a Docker container, so it has to use the name broker followed by the 29092 port, right? So finally, we also have the schema registry environment variable. So I'm going to just comment this out. And lastly, we have this dynamic config enabled as true. This is not really necessary for us to go deep into this configuration. This is specific to this Kafka UI project. So we are just happy by using the defaults here. So once this is done, I'm just going to go to the terminal, and I'm going to run the docker compose up -d command again. And you can see that the Docker containers are all started successfully. So if I go to the Docker desktop and go to the broker, you can see that we don't see any errors, at least for the Kafka container. So let's go back. And also for Zookeeper, we don't see any errors. Looks good. So we have installed, in this way, we have installed Apache Kafka using Docker Compose. So again, if you need something from the Docker Compose file, just make sure to refer to the blog post. Now let's go ahead and install the libraries to enable Kafka integration in our Spring Boot project. So for that, I'm going to the pom.xml file, and the easiest thing we're going to do is to open the browser and open a browser new tab, go to start.spring.io, and here I'm going to add dependencies, make sure to select the project Maven and click on add dependencies and search for Spring for Apache Kafka, Spring for Apache Kafka, and also search for test containers. So if you add both of these dependencies and click on explore, you can see the dependencies for Kafka. So the first one I'm going to use is this Spring Kafka dependency. So just copy this configuration here and go back to IntelliJ and paste it somewhere below the dependency of Spring Boot Actuator. And the next thing we need is the dependency for Spring Kafka test. I'm going to again paste this below the Spring Boot starter test dependency. And lastly, we also need the dependency for Kafka test containers. So I'm going to just paste this below the test container MySQL dependency, right? After adding all these dependencies, just make sure to click on the Maven icon on the top right corner to load the changes. So once this is done, the Kafka Spring for Kafka library is downloaded successfully on your machine. So the next thing we are going to do is to configure Kafka in our Spring Boot project. So for that, I'm going to open source main resources folder, and inside the application.properties file, I'm going to add a section called as Kafka properties. So here I'm going to type the property spring.kafka bootstrap servers. This is the address of the servers where Kafka is running. So if the Kafka is running in a clustered environment, you will provide the list of all the URLs of the Kafka cluster. So that's why it's called as bootstrap servers. So as it's only one server running on our side, so we are going to provide the name as localhost 9092. And we also have to define the name of the topic, which we have configured for order service. So we can do that by typing spring.kafka.template default topic. And I'm going to name this topic as order placed, right? And for now, let's go ahead with these two properties. So after configuring these two properties, now we have to write the logic to send out a message from our Spring Boot application to the Kafka topic. So for that, I'm going to open the package, the Java package, and here we are going to send out a message inside the order service, inside the place order method. So as soon as the order is saved to the database, so we have to send the message to Kafka topic. And we have to also decide what we want to send as part of the Kafka topic, right? So as we are sending the message to the notification service, which is responsible to send out emails, the main fields which it requires, it will be the order number and the email, right? So for now, we will just use these two fields to send out an email, order number and email. So for that, I'm going to create a new class called as order placed event. So I'm going to create a new package called as event, and I'm going to create a new class called as order placed event. We can also use a record, but I'm just going to use this as order placed event because going forward, we will replace this class with class which is generated by the schema registry. I'm just going to show you the flow of how everything looks like. So I'm going to create a class called as order placed event. This is going to be data, all logs and noaux constructor to just generate the boilerplate code. So I'm going to add a field called as order number, which is of type string, and another field of string called as email. So these are the two fields inside the order placed event. So let's go back to the order service. So here what I'm going to do now is create a object for order placed event. So order placed event equals new order placed event, and I'm going to pass in the email as order.get. So I'm going to pass in the order number, so order.get order number and order.get email. So the email is coming from the order request. So I'm going to provide order request dot user details dot email. So these two events, so the email is coming from the order request user details. So if you're not aware, I think I've added this order request user details as part of the last part where I have added the integration to Angular. So what I'm going to do is I just created a record called as user details, and here I'm going to provide the information: email, first name and last name. So these are the details which are coming in from the UI, so that our application has information about the user and not only the order. If I go to the order service, we are just for now using only the email. So I'm created the order placed event object. So what I'm going to do now is to use a class called as Kafka template to send out messages from our order service to the Kafka topic. So for that, I'm just going to first inject the Kafka template class. So Kafka template, and I'm going to call it as Kafka template. And you can see that IntelliJ is showing us a warning that we cannot use raw use of parameterized class Kafka template because it expects a generic arguments. So we have to provide what is the key and what is the value. So key is usually the name of the topic which we are going to send messages to. It's going to be string, and the value is also going to be the value which we are sending, of course, to the topic. So this is of the type order placed event. So we have to make sure to always specify the generic arguments while declaring the Kafka template. So let's copy this Kafka template variable, and just below the order placed event object, I'm going to call Kafka template dot send. I'm going to send a message to the topic. So the topic is going to be order placed, and the value is going to be this order placed object, right? Because as we have defined the key value pair as string, key as a string and order as order placed event, we have to also send in the same way the key followed by the value. So if I just replace this with order, you can see that it will throw an error because it is expecting a type of order placed event, but we have passed something else, an object of type order, right? So in this way, Kafka template enforces the type safety by just providing the generic arguments. So let's now go ahead and replace it with order placed event, and also let's add some logs. So logged.info is going to be start sending order placed event to Kafka topic order placed, and here I'm going to provide this order placed event and also add a message to inform that the message is sent to the topic successfully by adding this end statement log here. So after adding these two configurations, we need to add one more thing to our Kafka properties. So here we have defined the key as a string and order placed event as a value. So we have defined this in the Kafka template, that's fine, but we also have to define how to read this particular information for Kafka, right? So Kafka will usually send out messages in the form of bytes, so it needs to know exactly in which type we are sending the key and the value, right? So for that, we have to define the serializer on the Kafka properties. So for that, I'm just going to go to the application.properties file, and here I'm going to define a new property called as spring.kafka.producer.key serializer. So this is going to be the serializer for class for keys. So this is going to be of type string. So for the string, I'm going to use org.apache kafka.common.serialization.string serializer, right? I'm going to use the string serializer class coming from Kafka library, and we also have to define the value serializer. So for that, I'm going to define spring.kafka.producer value serializer, and this is going to be org.springframework.kafka.support.serializer.json serializer, right? So we're going to point to the value serializer to the JSON serializer because we are just providing the Java class. So usually we serialize as JSON, so we are providing it as the JSON serializer. So we have to provide these two information, how Kafka needs to serialize this particular information we are sending into the topic. So what I'm going to do now is I'm going to start the order service application, and you can see that the application is started successfully without any errors. That's good. And I'm going to open the UI on the address localhost 4200 and make sure you log into the application. So I'm going to provide my username and password, and here I'm going to order 1 pixel 8. Click on order, and you can see that the order is placed successfully. And if you now go to the order service, you can see some logs. So first of all, let's go all the way up. You can see that we have received the request. So you can see the log start sending order placed event, and it Kafka has produced the logs of the producer config. So if you just look at the configuration, it has the bootstrap servers as localhost 9092. And if you just scroll down, it has the key serializer as the Apache Kafka string serializer. And if you scroll all the way down, you can also see the value serializer information. So it's using the JSON serializer. That's good, because it's always useful if something is going wrong in the producer. If you're getting an error, just make sure to check these values so that you know what is the value Kafka is picking up. And if there is some mismatch, then you will know easily that you're doing something wrong. All right, so and we have some information about the Kafka itself. And finally, you can see that the end message saying that the order placed event is sent successfully. That means now our application has successfully sent the message to the Kafka topic. Now we can view the messages. We can also verify that the message is really sent to the Kafka topic or not by looking at the Kafka UI. So I'm going to open localhost 8086, and here this is the Kafka UI, and we can configure the cluster here inside the Kafka UI. So I'm going to click on configure new cluster, and I'm going to provide the cluster name as localhost. The host is going to be broker, port 29092, and just click on validate to make sure that the configuration is valid. So as you can see that the configuration is really valid. And I'm going to click on add bootstrap servers. So it's going to be submit, not add bootstrap servers. So you can see that now the cluster is visible here. And if I click on topics to the left hand side, you can see that the order placed event is visible, and it has number of messages as 1, right? So this is the message which you have just placed into the order placed topic. And you can see that in the messages tab, we have one message which I have produced. So you can also preview the message. So you can also view the message. So this is the key, this is the value, and you can also produce some messages here. So we'll come back to this later. But there's also possibility to produce messages through the Kafka UI. So this is very useful for you to explore. Now let's go ahead and configure the consumer for this Kafka topic. So in our architecture, this is going to be the notification service. So to create the notification service, I'm going to go again to the website start.spring.io. Make sure that the project I've selected is the Maven project, and the group ID is going to be com.techie.microservices. The artifact ID is going to be notification service, and I'm going to change the description as notification service, and the package name I'm just going to leave it as notification. And let's use Java 21, and in the dependencies we are going to use Kafka, Spring for Apache Kafka. We're going to use test containers. We are going to also use a Java mail sender because we'll be sending out emails from this notification service. So that's all you need. So make sure to generate this project. So it will download the notification service to your machine. And let's open this inside the IDE. All right, so we have the notification service. I've opened the service in the IntelliJ. So here we just have to first go to the warm.xml, and you can see that we have the dependency Spring Kafka followed by the Spring Kafka test dependency, which is also coming from Spring Boot. And we also have the dependency for the test containers for Kafka, right? And we also have the dependency to Spring Boot starter mail, which adds the functionality to send out emails from our Spring Boot application. So here the first thing I'm going to do is to configure Kafka for the notification service. So for that, I'm going to go to the Spring source main resources application.properties file. And here I'm going to first define the Spring application name as notification service. And let's add the Kafka consumer properties here. And it's going to be spring.kafka.bootstrap servers. It's going to be localhost 9200. And we are going to add a property called as Spring Kafka consumer.group ID. So every consumer should actually define a unique identification ID called as group ID. So if you are a consumer, then you need to have a group ID when you are reading messages from a Kafka topic. To be notification service. And the next property we have to define is going to be the deserializer. So a while back we have defined the serializer for key and value while producing the message to Kafka, right? So in the same way, we also have to inform Kafka how you want to deserialize this information, from the topic. So for that, we also need to go back to the notification service, and here I'm going to type in the information here I'm going to type in the property spring.kafka.consumer.key deserializer. It's going to be org.apache.kafka.common.serialization.string deserializer. And spring.kafka.consumer.key, not key but value deserializer, is going to be org.springframework.kafka.support.serializer.json deserializer, right? So we are just using the same classes, the deserializer classes. For string serializer, we are using string deserializer. And for JSON serializer, we are using JSON deserializer. So these are the properties we need also on the consumer side. So now let's go ahead and write the logic to read the messages from the Kafka topic. So for that, I'm going to open source main Java. I'm going to create a new class called as notification service. And I'm going to add this inside a package called as service. So I'm just going to add the package name to the in front of the class, and I'm going to click on the class and click on add. So this will create a notification service class in the service package. And I'm going to add the service annotation, the required args annotation, and the SLF4j annotation from Lombok to add the logging. So here I'm going to first define an annotation called as Kafka listener. So if you go inside, so this is going to be a listener annotation, which will Kafka listener annotation, which will make sure it will start Kafka listener in the background and will read all the messages from the topic which we want to read. So you can provide the name of the topic to the topics field here, topics attribute. So let's go back here, and I'm going to provide the topics value as order placed. So this is going to be the topic which we are reading the messages from, and I'm going to call this listener as listen, method as listen. So this listen method is going to take the order placed. So this is the method which listens to the order placed topic. So what we have to do now is also we have to create the class where we can read the messages from the payload, the schema, the class, which is the order placed event class. So I'm going to create this inside a new package called as order, and I'm going to create a new class called as order placed event, right? So, and I'm going to create data logs and nogs constructor, and I'm going to call this as private string order number, private string email, right? So inside the notification service, now let's add this to the arguments here called as order placed event. And here inside the listen method, what I'm going to do is I'm going to first add a log called as got message from order placed topic, and this is going to be the order placed event. And here what I'm going to do is send email to the customer. So we have to add the logic to send out the email to the customer. So for that we have already added the dependency for Spring Boot starter email. So what I'm going to do now, I'm going to copy some code here into the listen method. So let me add some import here, import class for my message helper, and the mail exception class I'm also going to import. And what I'm going to do now is inject a class called as Java mail sender. So this is the main class which is responsible to send out emails from our Java application. So here what we have is I'm creating an object called as my message preparator, and inside this I'm going to create an object called as my message helper, which is setting the from email address. So I'm just going to give a random email called as springshop@email.com, and I'm going to set the to email address. So this is coming from the order placed event, so we don't need this toString call. And I'm setting the subject as your order with order number is placed successfully. I'm going to use the string.format method to fill in this information dynamically here and create this string. And we are setting the body of the mail as your order with order number is now placed successfully, something like that. And finally we are going to send out the message by using this my message preparator object by just passing it to the Java mail sender.send method. And finally we are also going to log this message, order notification email sent. So this is all we need to send out an email from the Spring Boot application. So this is the actual code which send out the email, but we also if you can observe that there is one error which IntelliJ is showing that the Java mail sender bean cannot be auto-wired because it cannot find any Java mail sender bean. That's because Spring Boot will automatically auto-configure the Java mail sender bean by detecting some properties related to the mails, like the SMTP server related properties. We didn't add these properties yet, so that's why Spring Boot is complaining that there is no bean of type Java mail sender. So for that, what I'm going to do now is I'm going to create another set of properties called as mail properties. And here I'm going to provide the springmail.host, springmail.port, spring.mail.username, spring.mail.password. So we have to provide all these 4 properties. And the question is, how do we get these properties, right? So basically we'll be using some SMTP server to send out emails for us. So this is used to send out test emails from your application. So it's like a email delivery platform to send out emails from your application. So you can sign up. This is free. You can get there is no need to pay anything. Everything is free. So after signing up, you just need to create your demo inbox, and in there you will find the details like the username, password, and the host and the port. So we are going to use this information. So I'm just going to click on this host information. So just copying it by just clicking on this row. So I'm just going to go back and paste this host information. The port I'm going to use as 2525, and the password and the username I'm going to copy, and also password I'm also going to copy this. I will do this off screen. So once you have done everything, so you can go back to the notification service, and you can see that you don't see any errors because now Spring Boot has detected that the Spring Mail properties are defined, and now when you start the application, it will auto wire the Java mail sender bean, right? So in this way, you can configure your application to send out emails. So now what I'm going to do is let's start the application and see if everything is working fine or not. So I'm just going to click on the run application in the debug mode. So we are getting this class not found exception. This is because we forgot to add the dependency for Spring Boot Starter Web, because Spring Boot Starter Web contains all the dependencies to enable the JSON support in our application. So what I'm going to do now is I'm going to add the dependency Spring Boot Starter Web. So this is one of the dependencies we need, because they can see that the class not found exception is coming from the Jackson class, which is everything is there inside the Spring Boot Starter Web. So if I go inside the Spring Boot Starter Web, just for you to know, you can see that Spring Boot Starter JSON is coming directly from the Spring Boot Starter Web dependency. So it's better to use this Starter Web dependency now in our application. So after that, I also made one error. So for the Bootstrap servers, it's not localhost 9200, it's 9092. So let's also change this port to 9092. This is the correct port. And after that, I'm just going to restart the application. Looks like the configuration is not yet configured correctly. So I'm just going to click on reload all Maven projects. So just so that our configuration is reloaded. And if I click on start, you can see that the application is started successfully without any issues. And you can see some messages that a partition is assigned successfully for the group ID. All right, so now let's go ahead and test if this is working or not by opening our UI. I'm going to click on login one more time. And I'm going to now order an iPhone 15. Click on order now. You can see that the order is placed successfully. And if I open notification service, you can see that there are a lot of errors, right? So I'm going to stop this notification service and see what is the issue here. So you can see that error deserializing key or value for partition at offset 1, past record to continue consumption. So if I just scroll down, you can see that we are getting an illegal argument exception. The class order placed event is not in the trusted packages. If you believe this is the safe to deserialize, please provide its name. So we have to add one more configuration here, and inside the notification service, we are expecting a message of type order placed event, but we did not tell to Spring Boot how to deserialize this message. So for that, we need to add another property called as Spring Kafka Consumer Properties Spring JSON Type Mapping. So we have to provide the JSON type mapping explicitly. I have to provide the reference to the class. We have to deserialize this object. So for that, I'm going to provide the name as event as this is a prefix we have to add, and I'm going to add this com.programming.microservices.order.event.order placed event. And I have to make sure that I place this order placed event inside a package called com.techie microservices order event package. So previously I added it to the order package. I just now changed it to order event, because this is the same package structure as the order service, because in the order service we are using this com.techie microservices order event package. We also have to use the same package here for Kafka for notification service. So once I add this information and make sure that this order placed event is inside the respective package, I can just restart the application. And now let's try to consume this message, produce this message one more time. So I'm going to order this time 2 quantity of iPhone 15, and of course I have to first log in and order 2 quantity of iPhone 15. Order is placed successfully. So if I go to the notification service, you can see that order notification email is sent, right? So our application, our notification service is consuming this application, consuming this message and sent out the email. So let's test if this email is really sent or not. So I'm going to go open Mailtrap, and here you can see that a few seconds ago there is an email. Your order with order number is now placed successfully, right? So this is how you can configure our notification service. And there is one improvement we can do to enhance this notification service is right now you can see that we are constructing the payload, this order placed event messages manually, right? That means we are creating this class manually inside the notification service as well as the order service. So one question I got when I was developing this microservices series previously, 1 year back, was how can we make sure that there is no duplication of the classes in the order placed event as well as the order placed event class inside the notification service as well as the order service. So this is one concern, because now you can see that this order placed event is duplicated across 2 different services. Even though it's fine because these are 2 decoupled services, we can make sure we can use a single point of truth for this schema, for this message. So what we can do is we can create a schema out of this order placed event, and we can use this schema as a reference to generate the class automatically, right? So to do that, we can make use of something called as Apache Kafka schema registry. So that's why we need a schema registry to maintain a stable schema of the messages we want to send. So this helps us to make sure that both producer and consumer are on the same page by following a predefined schema. So this Kafka schema registry is provided by the Confluent, by the company called Confluent. So you can see that in the documentation, you can read about schema registry more if you want. So you can see that schema registry provides a centralized repository for managing and validating schemas for topic message data and for serialization and deserialization of the data over network. So this is a best practice which is used usually in the real world projects when we use Kafka. So now, as you can see inside the order service Docker Compose file, we have already added the schema registry. So we are already running the schema registry on the port 8085. So here we are provide the schema registry. We are providing the host name as the schema registry. We are providing the reference to the Kafka Bootstrap servers as broker 29092, and we are registering the schema registry listener at the schema registry port 8081. So by default, schema registry is running on the port 8081. So that's why we have to expose this particular port. So the next question is how to integrate this schema registry into our application, right? So for that, I'm just going to open this application.properties file. And what I'm going to do now is I'm going to delete this particular event class, right? And what we are going to do is we are going to create this particular class from the schema we are going to create. So to create the schema, the first thing we are going to do is we are going to use something called as a communication format called as Avro. So for that, we have to create a file called as an Avro schema file with the AVSC extension. So for that, I'm just going to right click on the resources folder and click on the directory. And I'm going to call this as Avro. And here I'm going to create a new file called as orderplaced.avsc. So this is the format for the Avro schema specification. So for the Avro schema, what I'm going to do now, I'm just going to paste some of the information here. So this is a JSON object of type record, and I'm going to name this as order placed event. The namespace we have to provide where we can find this particular where we want to create this particular class. There's going to be com-techie microservices order event, and the fields which are part of the schema is the order number of type string, email of type string, first name and last name. Right, so these are the schema definition. So this is the schema definition we want to use. So and after that, what we have to do is we have to add some dependencies to enable the schema registry in our application. So for that, I'm going to open the pom.xml file, and I'm going to add some dependencies. To copy these dependencies, I'm going to take help of the blog post one more time. So here I'm just going to scroll up all the way into the area called Spring Kafka, and here I'm going to copy these dependencies: Kafka Avro Serializer, Kafka Schema Registry Client, and Avro. So I'm just going to copy these 3 dependencies and paste it inside my pom.xml file. Alright, so we have these 3 dependencies. First one is Kafka Avro Serializer. So this adds the dependencies, the functionality to serialize this Avro schema file to the to Kafka, to add the capability to serialize this particular Avro file. And we also have the dependency to register with the Kafka Schema Registry Client. And finally, we also have the dependency to enable the Avro functionality in our application. So finally, we also have to add one more plugin to generate the or order placed event class from the schema file. So for that, I'm going to go back and I'm going to copy this plugin information from the blog post, and I'm going to paste this inside the plugins section, under the plugins section. So just below the Spring Boot Maven plugin, I'm going to add this plugin, this Avro Maven plugin. So what is going to do is it going to find the, so we have to provide the source directory where we have the Avro schema file, and what it will do is it will automatically scan this particular Avro schema file, and it will create a Java class, and it will create it inside the source main Java folder under the same package of the namespace. So it will create the class inside this package, right? So now if you try to run Maven clean compile, you can see that we are getting a compilation error because I think the creation of the class is done successfully. So you can see that the class is created successfully, but there is no constructor. So we have to change this definition of the order placed event a little bit. So if you see some compilation error, make sure to reload the, click on this reload all Maven projects, so that Maven, the Avro dependency is applied to your project inside IntelliJ and you don't get any compilation errors. As you can see now, I have clicked, after I clicked on this reload all Maven projects button, the compilation error is gone. So now I have to adapt this order placed event using the setter methods. So order dot get order number, and I'm going to place order placed event dot set email order request dot user details dot email. And you can see that we have also added 2 new additional fields, the first name and last name. And let's also populate this information here. So there's going to be order placed event dot set first name, order placed event dot set last name, order request dot user details dot last name, right? So this is all the information we need to populate before sending out this message to the Kafka topic. So now let's go ahead and do the Maven compile one more time. So this time it should not give any compilation errors. Right, so you can see that the build is successful. That means our project has created successfully the order placed event class from the Avro schema file. And we have to do one last thing, is we have to change the value serializer. So right now we are using a JSON serializer. What we can do is we can use the Kafka Avro serializer, because we are actually serializing in the form of Avro schema, Avro format, but not a JSON format. So for that, what we have to do is we have to change the value serializer to the class io.confluent.kafka.serializer.kafka-avro-serializer. So we can use this particular serializer. So that means our Spring Boot application will so that means Kafka will use this Kafka Avro serializer to serialize this message into a Avro format. So this is one thing we need to keep in mind, and we also have to define the URL to refer to the schema registry where this schema will be registered. So for that I'm going to call spring.kafka.producer.properties.schema.registry.url is going to be http 127.0.0.1 So after adding all this information, so what I'm going to do now is I'm going to restart this application, and you can see now that the application is restarted successfully. So now I'm going to go back to the UI, make sure I log in one more time because it's going to be expired. The token is going to be expired. I'm going to provide the quantity as 1 and click on order now. And you can see that the order is placed successfully. So also see the confirmation message inside the order service class. So let's open now the Kafka UI and see if the message is visible or not. So if I just go to the messages, there are actually 4 messages. This is the latest one which I have. So this is the latest one which I have created. So you can see that all the previous messages are in the form of JSON, but if you click on here, you can see that it's using a different format, using an Avro format. So this is one difference you can already see. But now if you go to our notification service, maybe you can see that it's screaming out loud that it cannot understand what this message is about. So for now, just stop this service and let's understand what is the issue. So you can see that it's not able to identify, it's not able to deserialize this particular message from the notification from the order service. It's because we have provided the deserializer as a JSON, but what we are really sending is like a message in Avro format. So what we have to do now is we have to change this deserializer, but before that we also have to add the Kafka registry and the Avro dependencies also in the notification service. So let's go to the order service, and I'm going to copy all the dependencies here from order service to the notification service. So this is going to be the Avro dependency, schema registry client, Kafka Avro serializer. All these 3 dependencies I'm going to copy and paste it just below the Spring Kafka dependency. And I also have to copy the plugin. So this plugin is going to be Kafka. So this Avro Maven plugin, I'm going to paste this inside the notification service. Just under the Spring Boot Maven plugin, I'm going to paste this Avro Maven plugin, and this is going to be the same configuration. There's nothing needs to be changed here. And one thing I'm going to do now is to create the schema file also inside the notification service. So for that, let's open the order service. And also copy this Avro folder as it is and paste this inside the resources folder. Click on add. You can see that we are using the same schema file here. And now we are just click on the Maven icon and click on reload all Maven projects so that the Avro dependencies and all the dependencies are downloaded successfully to your machine. And now I'm going to open the application.properties file, and here I'm going to type io.confluent kafka.serializer.kafka Avro deserializer. So this is the configuration I need to provide, and I also have to provide the URL to the schema registry. So there's going to be spring.kafka.consumer.properties.schema.registry.url equals to http localhost 80 8085 127.0.0.1 8085, and the last property is going to be spring.kafka.consumer.properties specific.avro.reader equals true. So we have to also provide a hint that we are using an Avro reader to the Kafka consumer. So that's why we need to add this property. So now if you go ahead, so that's all you need to do, and we can actually delete this particular class, and because the Avro Maven plugin will actually create this for us. So what I'm going to do now, I'm going to click on Maven clean compile, and you can see that order placed event is now created successfully without any compilation errors. So of course we have to maybe adapt this order placed event one more time. I have to import this class one more time, and I have to change this order placed event to get email dot to string, because by default it's using a character sequence type. Now we just have to change it to a string. Right, so now you can see that the order placed, we also have the information about first name as well as the last name inside the schema. So what I'm going to do now is I'm going to add some more information to the email. So I'm going to add two new fields here, so the first name and the last name, and I'm going to populate this and I'm going to add a placeholders for this string, and I'm going to populate this using the order placed event dot get first name dot to string and order placed event dot get last name dot to string. So in this way we can adapt the email so to display the first name and the last name. So now let's go ahead and start this application and see if everything is working fine or not. And you can see that the application has started successfully, and as soon as it started, it understood that there are some pending messages in the topic, and it's automatically sent out this particular email. Right, so now let's go back to our, so now let's open the mail trap platform, and you can see that a few seconds ago a mail was sent, and now you can see the first name and last name also in the email. So hi test user, your order with number is placed successfully. Right, so this is the functionality we have added also on the notification service. So we saw how to install Kafka using Docker Compose. We saw how to create a producer. We saw how to create a consumer. We saw how to also use Kafka schema registry to make sure that the schema changes are replicated correctly across producer and consumer. And the last thing which is pending is the integration test. So I will have a link to the so I will add this integration test in the blog post. So to make sure that you check out the integration test and make sure to write the integration test on your own. And that's it for this video. I will see you in the next video where we will see the concepts of observability, of how to implement logging, traces, and monitoring in our Spring Boot application. I will see you in the next video. Until then, happy coding techies. In this video, we will learn how to implement observability in our microservices project using the Grafana stack. The Grafana stack is nothing but the software stack which consists of Grafana, Loki, and Tempo. So we will implement observability using these three software along with Prometheus to fetch the metrics. So without any further delay, let's start the video. So before we go ahead in the video, I have to tell you that I've already created a video on my YouTube channel that demonstrates how to implement observability in your Spring Boot 3 applications using Grafana stack. So just have a look at this video. So what I'm going to do is I'm just not going to explain a lot of things in detail because I've already covered this in this 41-minute video. So I'm just going to follow the steps which you need to do to implement observability in our project. And as a companion, you can also refer to the blog post, this Spring Boot 3 observability with Grafana stack. So I'm just going to go through this blog post and implement the important details into our project as part of this tutorial. So if you want to know more about observability itself, just please refer to this video. Alright, so let us start with the question, what is observability? So observability is a process of understanding the internal state of your application with the help of different indicators such as logs, metrics, and tracing. So logs means nothing but the debug information we usually log into our application console. This is helpful to understand what is the state of the application and what is the state of the processes which are the flow of the process which is going on in our application. So and this is very useful if you want to debug anything and you want to know what is the request, what is the state of the request for your application. Then logs are very important to have to maintain your application. Likewise, we also need metrics to understand what is the state of your application. If your application is overloaded, what is the state, what is the memory used for your application, what is the CPU usage of your application, and different kind of metrics are useful to understand also the internal state of the application, right? So finally, we have the tracing, also called as distributed tracing. This is especially important in a microservices architecture, because if you have a look at our architecture, we have so many services here. So we have this API gateway, which is calling product service, and then it is also calling order service, and order service is calling inventory service, and we are also making an asynchronous request to the notification service. So imagine that we have some issue in the inventory service or maybe in the notification service. So imagine that for now we have an issue in the inventory service. For some reason, some random calls to the inventory service are failing, and we need to understand what is the criteria of why these calls are failing, right? So in this case, we have to isolate each request coming in from the user, right? So the user will making a request through the API gateway, and it's ending up in the inventory service, right? So we need a way to somehow isolate the request, each request from the user. So we can do that using the tracing information. Without this tracing information, because there will be a lot of requests coming into the API gateway and a lot of requests hitting the inventory services, so inventory service. So we need some way to differentiate each request, right? So we can do that using this distributed tracing mechanism. So if you go into this in detail, so you can see that our user is calling the API order API, and this is first hitting the API gateway, and then it's forwarded to the order service, and then it's forwarded to the inventory service, right? So if a request is failing here, we need some way to track the whole request from the start to the beginning, right? So we can do that using something called as a trace. So a trace is nothing but some information added to each request that helps us to of course, trace the request from its start to the end. So we can do that using something called as trace ID. So each request is assigned something called as trace ID, which is used to trace the request at any point of time. We also have something called as a span, which is nothing but a unique identification of the request in one particular service, right? So if for example we have a trace ID called as 123, then we can have a span ID for API gateway, a span ID for order service, and span ID for inventory service. So these three span IDs will be unique for each service, but the trace ID will be the same for each unique request coming from the user. So having said that, let's go ahead and implement these three topics in our project. So for that, I'm going to open the blog post one more time, and here I'm going to first add logging using the Grafana Loki. So for that, I just have to add the dependency called Loki log4 logback appender. So I'm going to copy this particular dependency, and I'm going to first start implementing this from the product service. So I've opened the product service and the pom.xml. So here I'm going to paste in the dependency of Loki logback appender right below the Spring.doc Open API Starter WebMVC API. I'm going to click on the Maven icon to the top right side corner, and let's go back to the blog post. And here you can see that I'm creating a Spring logback spring.xml file. So this is the configuration which actually tells to our Spring Boot application to send all the logs which are produced by our application to Loki, right? So here you can see that an appender called as Loki4j appender is configured, and here we have the HTTP URL, which is the pointing to the URL of Loki, right? So Loki is exposing this particular URL, and we are pushing the logs to this particular URL and store it in Loki. So all we need to do is I'm just going to copy this particular file, and I'm going to create this under the source main resources folder a file called as logback spring.xml. And if you dig deep, you can see that the first property we have is the include property, which is importing the configuration from the base XML file, which is defined for logback. So we are importing some base information from this base.xml file. And after that, we are also defining a Spring property called as Spring application name. And we are defining a property called as app name that is pointing to the spring.application.name property of our application. So in this case, the spring.application.name would be the product service. Right? So we need this property because then we can uniquely identify the logs for each application. Right? Then we have the appender. Of course, I've went through this. Inside the appender, we have the configuration for the HTTP URL, and we also want to define a format for our logs. Right? So the format means, so for each log, you need to see the information of the app name, the host name, and the level of the logging. So this level can be a debug logging, info logging, and also the trace logging. So this is again taken from the Spring Boot itself. And we also have some information called as file log pattern, and also how we want to sort the logs. We want to sort this by time, and that's why we provided the value as true. And finally, we have the root level info. This is some configuration to define the kind of logs we want to expose by default. So by default, we will be using the info log level. We can also include the debug log level here. So then all the debug logs produced by our application will be visible in the logs. So this is the configuration for the logback spring.xml file. And let's go back to our blog post. And after defining this particular file, what we have to do is we have to first define the Docker image to download Loki. So for that, I'm just going to copy this particular code here. And now I'm going to open this in API Gateway. Let me open the API Gateway project. I'm going to define this inside the API Gateway project because I want to have all the infrastructure related things in one place, which are not tied to one particular application. So right below the Keycloak, I'm just going to add the image for Loki. So here you can see that we have defined a service called as Loki, and the image is pointing to Grafana Loki main. And we have a config command. We have a Docker entry point command, which is pointing out the config file as etc loki localconfig.yaml. So this is one internal startup command. We don't need to go in depth about it. And we are exposing the ports 3100 because the Grafana Loki will by default run on the port 3100. I'm going to expose this port into our local machine. So let's verify that in our product service we are using 3100 or not. So you can see that we are using the 3100 port for Loki. So that is how we can configure Loki in our application and then configure logging in our product service. So let's now go ahead and do the next part, that is how to generate metrics for our application. So for that, I'm just going to go open the blog post one more time. And the next part is the metrics. For that, we need to add one dependency called as Spring Boot Starter Actuator. So I'm going to copy this dependency and then open the product service one more time. And right below the Loki logback appender, I'm going to add the Spring Boot Actuator dependency, and I'm going to refresh. And also I need some other dependency called as Micrometer Registry Prometheus. So I'm just going to copy this dependency, go back to my IDE and paste it. And the next part is I need to add some properties to our application.yaml file. So I'm just going to copy this particular 3 properties, go back to the application.properties and then paste this. So here we have the property called as management endpoints, web exposure include. So here we can define which endpoints we want to expose from our Spring Boot application. That will provide information about our Spring Boot app, right? So we have different endpoints in Spring Boot Actuator. One is the health endpoint, which defines, which sends the metrics of how the health of your application. The info endpoint, which just sends the generic information about your application. Metrics, that sends the real metrics like the JVM statistics, memory, CPU usage, and all are included in this metrics endpoint. And Prometheus endpoint is an endpoint which is custom made for Prometheus, which defines all the metrics in the format that Prometheus can understand, right? So we want to expose all these 4 endpoints in our project. And after that, we have a next property called as management metrics, distribution, percentiles, histogram, HTTP server request true. So here we are actually defining a property that sends all the HTTP metrics in the form of a percentiles histogram. So it can be distributed. So this is an internal property of Prometheus. So we need to add this property as true. Next, we have the management observations key value application, not as loan service, but this should be product service. So by adding this particular value, all the logs, observations of your application will have the key value, the key as product service. So it's easier for you to query Prometheus and the tracing information by adding this key as product service. So after adding this information, I'm just going to click on refresh on the Maven icon. So now let's go back to the blog post. And here the next thing we have to define is the image for the Prometheus. So I'm just going to copy this particular Docker file, and I'm just going to copy this particular code and paste this inside the Docker Compose file. So I'm going to go back to the product service, not the product service, but in the API gateway. And in the API gateway, right below the configuration of Loki, I'm going to paste in the configuration for Prometheus. So here we have the Prometheus configuration. We are reading from the Prometheus version 2.46.0. You can of course also use the latest version of Prometheus here. So this is the version I'm using right now, and we are exposing the ports 9090. So we want to use the port 9090 for Prometheus. And the next thing we have to do is we have to define some kind of configuration. As you can see that we are we are mounting the file called as prometheus.yaml into the etc prometheus.yaml folder. So for that we need to go back to the blog post and we need to create a file called as prometheus.yaml file. I'll just explain to you why we need this file shortly. So for now I'm just going to copy this file and I'm going to add this file inside prometheus.yaml file under docker prometheus.yaml file. I'm going to paste this here. And so this prometheus.yaml file contains the configuration to scrape our Prometheus endpoint. So Prometheus by default fetches the metrics from our application, scrapes the metrics from our application in a particular interval. So for that we need to define how often Prometheus should scrape our application for the metrics. So and what all applications it actually should scrape, right? So to define that particular configuration, we need to create this prometheus.yaml file. We have so inside that we have this global scrape interval, and I have set it as 2 seconds. You can also set it as 5 or 10 seconds as you like. And the evaluation interval is also, I have set it as 2 seconds. Next comes the scrape configs. So here we actually define different kinds of jobs we want to have. So the first job is like the Prometheus, which is pointing to the Prometheus 9090 endpoint. Next job is should be the product service. So here inside the product service, we are going to define the metrics path as /actuator/Prometheus. And the target is going to be host.docker internal 8080. We need to provide host docker internal because the Prometheus will be calling from inside a Docker container to our local host, right? So for that we need to provide the host name as a host docker internal. And of course this should only be used in the production purposes. If you want to run it in production, you will actually replace this with the name of the product service container, right? Or pod or whatever you are running in. So after product service, we have the order service. So this is going to be order service actuator Prometheus host docker.internal 8081. So of course we have again the order service. So like this, we can create configuration for all our services. So I'm going to just copy and paste some information which defines these jobs for all our services. So we have our API gateway running on the port 9000. We have the product service running on port 8080. We have the order service on port 8081 and the inventory service on port 8082. Finally, we have the notification service which is running on port 8083. So we also, one thing we need to observe is we also added labels so that it is easily identifiable for Prometheus. So labels followed by the application. So we have added the application label as the name of each service. So this particular label is missing for the notification service. So let me add this label and call this as notification service. So after adding this configuration, that's all we need to do for Prometheus. Let's go back to our blog post and see what is the next step. So you can see that this is the final step for metrics using Prometheus. So the next step is going to be to implement tracing. So for that, I'm just going to copy these two dependencies, micrometer tracing bridge Brave, zipkin reporter Brave. So I'm just going to copy these dependencies. And again, if you want to learn about this, just refer about these dependencies, why we are using it, just refer to this particular tutorial. I've explained this in detail. So I'm just going to copy this particular information and let's go back to our product service. And then inside the pom.xml file, I'm just going to paste this under the micrometer registry Prometheus dependency. I'm going to click on load Maven changes. Let's go back to the blog post. And here we will come back to this particular dependency. So this dependency is called as data source micrometer Spring Boot. So if you want to trace also the calls to the database, then you can use this dependency to understand what is the time taken by your database to resolve the queries, to fetch the results of your queries. So this is really helpful if you want to debug some database performance issues. So we'll come back to this when we are implementing the observability for order service or maybe the inventory service. So let's scroll down until we found the class called as observation config. So to enable observation in your application, we need to create a class called as observation config and define a bean called as observed aspect. So for that, I'm just going to copy this particular code and go back to the product service. And here I'm going to create a class called as observation config. And I'm just going to paste this inside the class. So we have defined a bean called as observed aspect, which is like a prerequisite when you want to use observations in your project. So let's go back to our blog post, and to enable this particular observation, we need to also add the Spring Boot starter AOP dependency. So I'm just going to copy this particular dependency and then paste this below this zipkin reporter Brave dependency. And I'm going to load the Maven changes. And finally, we also have to add a property called as management tracing sampling probability as 1.0. We need to add this property because by default, the Spring Boot application will generate traces for only 10% of the requests, right? So we need to add the sampling probability as 1.0 so that it will generate traces for 100% of all the requests which is processed by the application. So this is a mandatory thing, or else you will find that the traces are not generated always. So after that, the next thing we have to do is we have to create the Docker Compose configuration for Tempo. So for that, I'm just going to copy this particular code, and I'm going to go to the API gateway and paste this here. So it's called as Tempo, and here we are again defining a config file as a startup as a startup command, and we are also mounting the configuration called as tempo.yaml file into the /etc.tempo.yaml inside the container. So for that, we need to create a file called as tempo.yaml. So under the Docker tempo folder, I have a tempo.yaml file, and here we can see I've already added this particular code here. So here we are defining the server to listen on port 3200, and we have some default configuration which is applicable for tempo. So after adding this configuration, the next thing we have to do is to add service to run Grafana. So we've added Loki, we have added Loki, we have added Tempo, we have added Prometheus. So now the Grafana is the missing piece in the Grafana stack. So I'm just going to copy this code for service for the Grafana Docker Compose service, and I'm going to paste this under the Tempo section. And here I'm going to define a Grafana image 10.1.0, and finally I have the configuration to expose the port 3000 to access Grafana. So after adding this, let's go back, and we need to add a file called as datasources.yaml. So I'm going to copy this particular whole file, and I'm going to go to the API Gateway project under the Docker Grafana. I am going to paste this under the datasources.yaml file. So this is nothing but a configuration for Grafana to find out the locations of Prometheus, Loki, and Tempo. Right? Of course, Grafana is like an aggregation application which aggregates all this information and displays it to us. So for that, we need to provide a hint where you can find this information. So that's why we have this data sources object, and inside that we have the configuration for Prometheus, which is pointing to the URL Prometheus 9090. We have configuration for Tempo, which is pointing out to Tempo running at port 3200. We have configuration for Loki, which is running at port 3100, right? So we need this particular YAML file before starting up the Grafana. After adding this information, let's go back, and yeah, that's all we need to define these three software in our project. So now what I'm going to do is I'm going to run Docker Compose up -d command on the API gateway. That will start all the three services. Particularly Loki, Prometheus, Tempo, and Grafana. So now what I'm going to do is I'm going to open the URL localhost 3000, and you can see that we are greeted to the welcome page of Grafana. So if you click onto the menu, to the toggle menu to the top left hand corner, you can see the section called as Explore. So if I click on it, you have a drop down menu here, and if you click on it, you have the option called as Loki, you have option Tempo, Prometheus, and of course Grafana, but we are not going to use this option. So for now, let's see if the logs are visible in Loki or not. So I'm just going to click on Loki, and I'm going to select the label as application, and you will see the information of all the applications like our product service, order service, notification, and the API gateway. So of course we didn't configure all these three other services. We only configured the product service. These are visible because I've already configured it before. So what I'm going to do now is, first of all, start the product service. Let's go to the product service and start our application. So just make sure that you have the Docker Compose file up and running, and I'm going to click on start application. And once the application is started, let's go to the Loki, and here in the drop down, I'm going to select the application as product service and click on run query here. So you can see that the logs are now visible for our application for the product service. And if you select the option Prometheus, and here you can select the filter of what application you want to select. So for that, I'm going to click on the label filters and select the label as application and select the value as product service here. And I'm going to run the query, and you can see that there is a graph showing you the metrics which are read from the product service. So these are all the different metrics. Of course, you cannot see this correctly. you can see this properly. The right way to view this metrics is using a Grafana dashboard. So for that, what we have to do is we have to create a dashboard to display this information. So for that, I'm going to click on this toggle menu, go to dashboards, and we need to create a dashboard to display the information. So you can do that by clicking on new and import, and you can import a dashboard in different ways. You can upload a JSON file, you can import it from the grafana.com, or you can just import the JSON, the dashboard via the JSON. So what I'm going to do is I'm going to upload the JSON file, which will be present inside the API gateway Docker Grafana dashboard.json. So this particular, I'm going to copy this particular information, and we are going to upload this into the Grafana. So I'm not going to do this one more time because I've already done this. So I'm going to click on cancel. And after you import this particular JSON file, you can see an entry called as Spring Boot statistics. I'm going to click on this information, and you can see that for product service, we are able to see different kind of metrics, like what is the uptime of our application, what is the start time, what is the heap memory used, what is the non-heap memory which is used, what is the CPU usage, and different kind of JVM statistics are visible for our application. You have very extensive information about your application. So this is really useful while doing monitoring of your application. And the last thing we have to now check is the tracing information. So for that, it's really helpful to, so we can only check whether the tracing is working or not if we enable it also for the other services. So what I'm going to do now is I'm going to go to the API gateway and follow all the same steps which I have outlined in this particular tutorial. So I'm going to do that, and then I'm going to come back and see and how you can really trace the requests in your application. All right, so now I've made all the changes in all the services. So that means I've implemented logging using Loki. I've adding the logback configuration. I've added the necessary properties to enable metrics and also the traces. I've done this for all the services. We have the product service and we have the notification service, which is up and running again. I've created the observation config also here. One thing we need to understand here is we need to enable observation for the Kafka. So for Kafka to enable observation, we have to add some additional configuration. So we need to add we have to enable observation inside the Kafka listener. So for that, we need to first auto-wire this concurrent Kafka listener container factory bean, and then we have to add the set observation enabled property as true. So or else if we don't add this information, then there will be no trace ID for the messages which are sent through the Kafka. We want this information to be present for all the requests. So when a request is coming from order service to the notification service, by adding this configuration, the trace ID will also be propagated, right? Likewise, inside the order service, I'm going to the order service and I'm going to go inside the REST client configuration. And here also we need to add some additional changes for the REST client. So while defining the REST client bean, we have to first inject the observation registry and then provide this observation registry to the REST client builder. So in this way, our REST client will understand that we have to also propagate the trace ID whenever we are making calls to the inventory service. So this is mandatory, or else this is mandatory before testing out your changes, or else you will find that the trace ID is not propagated to the inventory service properly from the order service. So after adding this information, let's go back to our browser and open Grafana, and let's go back to the home page and click on the toggle menu and click on explore. Now if you go to Loki, let's check first Loki if we are able to see the logs for our application or rest of the applications or not. So in the label filters, I'm going to select application, and now first I'm going to select the API gateway and click on run query. and you can see that we are able to see the logs which are generated by the API gateway. So these are the recent logs which are generated. So let's see the same thing for the order service. Click on run query, and you can see that during the same timestamp we are able to see the logs for the order service. Same for the inventory service, we are able to see the logs, and finally we also have the notification service where we are also able to see the logs. So now let's test out this feature by making one request. So let's go to localhost 4200 and let's do the login. And one thing which you have already maybe observed is that whenever we are creating the Docker container, we are recreating the Docker container for Keycloak, all the information is actually lost, right? All the information, all the client information. So all the client information which we have created will be lost. So to get around that, what we can do is we can export the realm details from Keycloak and import it, import it while creating the Keycloak Docker container. So we can do that by first going to the localhost 808181. So this is the Keycloak administration UI, and here I'm going to log in using this admin password, use admin credentials. So, and here I'm going to select the Spring Microservices security realm. This is the realm which we have created, and under the realm settings, what you can do is you can click on action and you can say partial export, right? Then it will export all the realm information, like what are the clients which are defined inside our realm. So you can select the option to export the clients and also the groups and roles. So after clicking all this information and you click on export, it will generate a file called as realm export.json, which looks something like this. So I've already downloaded this and kept it under the Docker Keycloak folder. The realm export.json, you will see all the information about the realm, and here you can find also the information about our client. So the client we have created is Angular client. So you can see the client ID. We have a client called as Angular client, and it has all the information about our client which we have created, right? So by exporting this particular realm, we don't need to create the clients again and again. So this is one of the advantage of using this realm export functionality. So after exporting this realm, what we have to do is inside the Docker Compose file, we have already configured the Docker Compose file according to this. So what we are doing is we are exporting all the files which are there under the Docker Keycloak realms folder into the OPT Keycloak data import folder. So in this way, whenever the Keycloak is starting up, it will read all the information from this realm export.json file. Having said that, let's go back to our Keycloak. And one thing we need to do is we need to define this login option, the user registration option. We have to switch it on. And then whenever we are logging into our application by going to this localhost 4200, I'm going to click on login. I have to register. Test user. I'm going to put email as testuser@gmail.com, first name as test, last name as user. So I'm going to, now the registration is done. So I'm now going to order this particular iPhone. I'm going to click on order now button, and you can see that the order is placed successfully. Okay, let's go to now tempo, and let's do a refresh. So this time I'm going to select the resource. So I'm going to, I think we have to refresh the application. This time I'm going to select inside the resource server name, I'm going to select the resource server name as API gateway. Click on refresh, and you can see this, all the requests which are made through the API gateway. This time we are interested in the /API/order endpoint. So if I click on this particular trace, you can see all the request communication all the way from API gateway. So you can see that from API gateway, it is actually executing some information in the security filter chain, and then it's hitting the circuit breaker. Through the circuit breaker, it is sending the post request to the order service, and the order service sent a request to the inventory service, And you can see that in the inventory service, there is a call to the database. So that's why you see an icon with light orange color or something like that. This is the query which the inventory service has made to the database. We have also able to see the query here. So if I click on it, you can see also the query which is made by the JDBC driver. You can see that we are not able to see it completely, but if needed, you can also get the query, right? So you can see that this is the query which is made by our application. Okay, so let's go ahead. Now again, you see that from the order service, we've made a request to the notification service, and the notification service is also visible here. So in this way, you can have a very nice outlook of the request flow right from the start of the request to the end of the request. So again, this can be a little fast if you have not heard about observability before. What is AP, what is logging, what is metrics, and what is tracing. This tutorial can be quite fast for you. So that's why I really request you to first look at this Spring Boot 3 observability video and then come back to this tutorial so that you will be able to quickly understand what's going on around this observability space. So I hope this tutorial is helpful for you, and I will see you in the next video. So with this video, all the development related stuff is completed for this project. So the next part is actually to deploy this using Docker and Kubernetes. So I'll see you in the next videos, and until then, happy coding techies. Welcome to the final part, the part 13 of the Spring Boot microservices tutorial series. So in this part, we will be mainly concentrating on Dockerizing our application and then deploying the application to the Kubernetes cluster. I will cover all the services and the necessary infrastructure, and will show you how to create the Kubernetes manifest file and then manage all the manifest file using Kubernetes. So without any further delay, let's start the video. So before starting the video, a small disclaimer that this is a practical course, I cannot cover the basics of Kubernetes in the same video. So that's why I suggest you to refer to a beginner level Kubernetes tutorial. So once you have the necessary basics of Kubernetes, like what is a pod, what is a deployment, what is a service, and what are config maps, etc. So just if you understand the basic workloads of Kubernetes, then you are ready to start with this practical tutorial. So please do this favor and learn the basics of the Kubernetes, and then you can start watching this tutorial so that it will make much more sense for you. Alright, so now let's go further and dive into the tutorial. Alright, so in the previous videos, we saw that I've developed each service as an individual microservice, as an individual repository. So what I did here is I created one parent project called as Spring Boot 3 microservices course, and I embedded all the services and components we are using inside this parent project. So you can see that we have this API gateway, the front end, inventory service. All the services are embedded inside one parent project here. So what you can do is you can directly check out this GitHub project, and to follow along, you can check out the initial branch. So if I go to the initial branch here, you can see that this is in the same state as in the part 12 of this tutorial. So everything is up to date. So we have this front end service and also the other services which are in line with part 12 of this tutorial series. So whatever changes I'm doing, make sure to first check out this initial branch and then start coding along with me, so that you can gradually work your way up to the final part, which is you can find the final part of this source code in the master branch. So if I check out the master branch, you can see that there is a folder called as Key8, which contains all the necessary manifest files and configuration for the Kubernetes. So now I already have this project in my local, and I'm on the initial branch. So the first thing I'm going to do here is to Dockerize our services, right? So we have our Docker folder. So we have our Docker compose file. Here you can see that we have all our infrastructures like MongoDB, MySQL, Zookeeper, Kafka, and all the infrastructure we have created the Docker compose file for it. But the actual services like the product service, order, notification, inventory service, these 4 services, and also of course the API gateway, for these 4 services did not yet create the Docker file and the Docker images. right? So for that, what we have to do, so let's do that right now. So basically we can create a Docker image for a project using two ways, right? The first one is using a Docker file, where you add a Docker file inside the root project. So like, for example, I can create a new file called as Docker file, and I can write out all the instructions of how to create this Docker image, right, inside the Docker file. And when I run the Docker build command, it will take the instructions which is present inside this Docker file, and it will create the Docker image for us, right? I hope you are familiar with this. So this is one way of creating a Docker image. And another way is by using something called as cloud native build packs. So if you Google for cloud native build packs, you can see this buildpacks.io website. So if you click on this, you can see that the cloud native build packs is a way of creating Docker images automatically from your source code itself, right? So you can see that the cloud native build packs transform your application source code into container images that can run on any cloud. So this is a industry standard way to create Docker images out of your source code. So one advantage of using cloud native build packs is you don't need to manually maintain the Docker files, right? So if your Docker image is straightforward, you don't need to, you can just rely on the cloud native build packs to generate the Docker image instead of writing and maintaining this Docker file. You can make use of the cloud native build packs. That will make our life far more easier to generate the Docker images. So to use this cloud native build packs, we can make use of the Spring Boot Maven plugin, which provides in out-of-the-box support for the cloud native build packs. So we will be using Spring Boot Maven plugin to generate the Docker images of all our services. So let's go ahead and do that now. Before that, I'm just going to delete this Docker file. I don't need this anymore. What I'm going to do now is I'm going to the pom.xml on the Spring Boot 3 microservices root project, and I'm going to scroll down. And here you will see that there is a plugin called as Spring Boot Maven plugin. So this is coming out of the box from the Spring Boot starter itself, out of the box from the Spring Boot starter project itself when we create it from the start.spring.io website. And you already have the command to build the Docker image by, if you go to the Maven, if you click on the Maven icon, and if you just expand the Spring Boot 3 microservices and then go to the plugins, and you have the plugin called as Spring Boot, just expand this plugin and you see different goals which the Spring Boot Maven plugin is providing us. So one of the goals, the first one is the Spring Boot build image. So what this image will do is it will automatically generate the Docker image for us. So if I try to double click on this Spring Boot build image, it will identify the Spring Boot project, all the projects, and it will try to run the Spring Boot build image goal, right? So you can see that it is automatically building the image for the API gateway right now as we speak, and it is pulling a builder image, an image called as builder jammy base, which is coming from the Paketo build packs. And using this base image, it is trying to create a Docker container for Docker image for the API gateway service, right? So this is how the build image can be created automatically. So as you can see that I did not add any other configuration. Everything is present inside our Spring Boot project itself. So you don't need to create any other external Docker files or anything else to create the Docker images. So I'm going to stop this for now, and we'll come back to this later. So we need to do some small change here because I'm running this project inside an Apple machine. So for that, if you want to run this you want to run the build packs using an Apple machine, you need to use a custom image so that you don't face any configuration issues. So for example, you can see that by default we are using this builder jammy base image to create the container images, to create the Docker images for our API, for our services. But instead of this builder jammy base, what I want to do is I want to use a different image. To use the different image, I'm going to go inside the configuration section of the Spring Boot Maven plugin, and I'm going to type a tag called as image, and inside this image I'm going to use a builder called as Doshon builder tiny. So this builder is compatible with Apple devices when if you're using M1 chip, M1 silicon chip, or M3 or M1, M2 or M3 silicon chips. Make sure to add this particular builder so that Docker image which is created is compatible and runnable on your Apple machine. So after adding that, we need to add some other configuration, we need to also add the name of the Docker images which we want to create. So we don't want our Docker images just to have some random names. So it's better to have some predefined names. So for that, I'm going to add a name attribute inside the image tag, and inside the name attribute, I'm going to add my username of the Docker Hub account, and I want to have this as new $project.artifact ID. So the $project.artifact ID is referring to the artifact ID of the project which is being built. So if I click on this, you can see that for this pom.xml, the artifact ID is Spring Boot 3 microservices. So if I go to the API gateway, the pom.xml, the artifact ID would be the API gateway. So I have to make sure that the Docker image I'm creating for each project is using this particular format for the name. So this is the username of my Docker Hub account, and after that I have the slash, and then this is going to be new the project artifact ID. So for example, for API gateway, this is going to be my username / new API gateway. This would be the name of the Docker image I'm going to build. Right. So you may be asking why there is a prefix called as new, because I already have a Docker image with the same name called as API gateway, because I've created it in the previous Spring Boot microservices tutorial. So I just want to not override this particular image. That's why I added this prefix called as new to the Docker image. All right. So after adding this particular configuration, I also want to push this Docker image to the Docker Hub. So for that, I need to add another tag called as publish true. So what this will do is it will try to publish, not only build your Docker image for all the projects, but it will also try to push this Docker image to the Docker Hub, right? So the next step, so the next question is, of course, if you try to push this Docker image to the Docker Hub, we have to also provide the credentials to the Docker Hub. So how to do that? So we can do that by creating a different tag here called as Docker. And inside this, we can provide the publisher registry information. So you can see that GitHub Copilot is already suggesting me some configuration here. So I'm going to use this. So the username, the GitHub Copilot got it correct, but the password is not this one, of course. And I can also remove the URL because I can use the default registry URL. So I just need the username and the password. So to get the password, you have to open the Docker Hub. So I'm inside the hub.docker.com portal, and I've logged in with my Docker account. And after logging into the Docker account, you can see that we have the repositories of the Docker registries, the Docker images, which we have in your account. So if you don't have any Docker images pushed to the Docker account, so you don't see anything here, of course. So what we have to do is we have to go to the profile to the top right side corner and click on account settings. And here we have something called as personal access token. So click on this personal access tokens, and you can generate a new access token. So we can just put a description, something called as token, and then we need to have a read, write, and delete permission here. After selecting this option, make sure to click on generate. It will then show you the access token you want to use. Make sure to copy it, and then save it for the future, because we want to use it, of course, inside our project. So after generating the token, what you can do is you have to use this inside this password tag. I would not suggest you to simply copy this particular token inside the pom.xml, because that is not so good. So we should not store any kind of secrets inside our source code, especially the sensitive secrets like the secrets for Docker Hub account. So as an alternative, what I would suggest is to create a property inside the properties tag called as Docker password, and let's refer this particular property inside the password tag. So for that I'm going to type $ curly braces, and I'm going to reference to the Docker password variable. So if I click on this, control click on this Docker password, so it's taking me to this Docker password property, and we have to somehow override this particular password, this property with we have to provide the password to this particular property while building our Spring Boot image. For that I'm going to type in another placeholder called Docker password. So whenever you want to run this build, you can use the command maven spring boot. So let me highlight this. So whenever you want to run the build, you can run the command maven spring boot build image, and you can provide the Docker password. So in this case you will be using your Docker Hub token here. So make sure to run this particular command, and then it will start the build. I did all this configuration, so let's go to our, so let's make sure that to load the maven changes, and once it is done, let's run the maven build command. So I already have the maven build command with me, so I'm just going to run this, and you can see that it's trying to build the Docker image for all the projects. So I will come back to you once all the images are successfully built and deployed to the Docker Hub. All right, so you can see that, so the build is now successful, and you can see that the total time it took is around 1 minute 45 seconds. So this is on my machine. So if you're maybe on your machine, it can be faster than 1 minute 45 seconds, or maybe it can take much more time. And then once this is done, you are now ready to dive into the Kubernetes world, because now we have the Docker images, and these Docker images should also be pushed into the Docker Hub. So let's open the Docker Hub, and if you go to the repositories, you can see that the image is pushed 1 minute ago, 2 minutes ago. You can see that the push is successful. That means our Spring Boot Maven plugin is able to successfully build the Docker images and also push the Docker images to the Docker Hub. So the next step would be to dive into Kubernetes, as I said. So for that, we need to first create a local Kubernetes cluster. So let's see how to do that. So to create a local Kubernetes cluster, the tool I'm going to use is called as Kind. So as you can see here, Kind is a tool for running local Kubernetes cluster using Docker container nodes. So this is a very widely used local cluster for Kubernetes. You may have heard other options like Minikube, and also Docker itself comes with its own Kubernetes cluster. So if you open the Docker dashboard, so let me open the Docker dashboard here. Let me pull up to the screen, and then you can see that if you go to the settings tab onto the top right side corner, and you have this option called as Kubernetes, and if you click on enable Kubernetes, the Docker engine will start a Kubernetes cluster. So you don't need to install anything else, but I'm choosing Kind because it is what I observed is like it's less resource intensive, and that's why I'm using Kind cluster. You can also use any other cluster like Minikube and also the Docker Kubernetes engine. It's your wish, but in this tutorial I'm going to use Kind to create the local Kubernetes cluster. So to install Kind, you can see that the prerequisite are you need to have Go installed, at least the 1.16 version is the minimum. And after that, of course, as you have Docker, all you need to do is you have to run the command go install and the package name of Kind. And once this is done, the Kind package will be installed to your machine. And after that, all we need to do is to type the command kind create cluster. So once you run this command, it will automatically create the Kind cluster. So if you just scroll down, you can see that in the usage section, you can create the cluster by typing the Kind create cluster, and you can also delete your cluster using Kind delete cluster. So to create the Kind cluster, we need some additional configuration. So for that, I'm going to go to the configuration tab here, and I'm going to click on this extra port mappings section. So what I want to do here is I want to create a Kind cluster, the local Kubernetes cluster, by exposing the port 80. So I want to expose the port 80 to the Kubernetes cluster to run the Kubernetes cluster on this port, right? So for that, I just have to I just want to just copy this particular YAML file by clicking on this copy link here, so that it will copy this contents into the clipboard. And I'm going to, on the root project, I'm going to right click and click on new directory called as K8s. And inside this K8s, I'm going to create another directory called as kind. And here I'm going to right click and create a new file called as kindconfig.yaml. Right, and inside this YAML file, I'm going to paste this particular content here. So you can see that you are using a kind cluster with an API version of v1 alpha 4, and here inside this configuration we are assigning the configuration of our nodes, which the Kubernetes cluster, which the kind Kubernetes cluster will create for us. So for this node, for the nodes, we want to create a control plane with this particular extra mappings, where the mappings of the Kubernetes cluster port 80 is mapped to the host port 80, right? And this is listening to the listen address. We have set it as 127.0.0.1. This is the local host address, and we are listening to the protocol TCP, right? So I will just remove the comments from here. So this is the configuration you need to expose the port 80 for the Kubernetes cluster. So once this is done, all you have to do is we have to create the Kubernetes cluster using kind. So for that, I'm going to create a new file called as create kind cluster.sh. So as I'm using Mac, I'm going to create a shell script file. You can also, you can also ignore this shell script file. You can also run the commands directly inside the terminal if you're using Windows. So what I'm going to do now inside the create kind cluster is I'm going to run the command kind create cluster. I'm going to name this cluster as Microservices, and I'm going to provide the config reference as kindconfig.yaml. So I think I made one mistake. I think Kubernetes expects the configuration, the file extension for YAML to be .yaml, not .yml. So let's refactor this. Let's rename this as kindconfig.yaml. All right. So now let's open the terminal, and now I have to cd into the K8s folder inside kind, and now I'm going to type the command /kindcluster.sh. It says that the permission is denied, so I have to add the permission for it. chmod x create kind cluster.sh, and now I'm going to run the create kind cluster command. So you can see that it is creating the cluster called as microservices, and it's doing all necessary startup tasks to create the cluster. So it may take some time for you. If you're doing this for first time, it will take maybe a minute or two to create the cluster. And once this is done, you can see this information like the cluster creation is successful. And so the next thing we are going to do is to create the manifest files to run our services, right? So for that, I'm going to create a new folder under the K8s folder called as manifests, and inside that I'm going to create another folder called as infrastructure. So we will first start off by creating manifest file for all the infrastructure we have. So for example, we have this Docker Compose file, and inside this Docker Compose file we have all the infrastructure like the databases, our Kafka brokers, and also the Grafana, Loki, and Tempo. So all these comes under infrastructure. So we are going to create manifest files for all these infrastructure modules all these infrastructure components first, and then we'll go and create manifest files for our application services. So the first service we are going to create the manifest file for is going to be for the infrastructure. So inside the infrastructure, so I'm going to choose MySQL as the service which I want to first create the Kubernetes manifest file. So you can see that we already have a reference of what we want to do with the Docker Compose file. So this is the Docker Compose file service, the Docker Compose service for MySQL. So we have this image name, container name, the environment variables, the ports which we are exposing, and also the volume information. So we need to create a similar setup also in Kubernetes. So for that, we need to first create a deployment. So create a deployment. So if you are not aware of what is deployment, again, I suggest you to watch an entry level, beginner level tutorial, maybe on YouTube about Kubernetes, and then come back to watching this tutorial. So we'll first create a deployment for Kubernetes. So for that, I need to first go into the folder manifest. First, I have to go back from the kind folder, and I'm going to go inside the manifest folder into the infrastructure. And here I'm going to create a deployment for MySQL service. So for that, I'm going to write a command called as kubectl create. And before we go ahead and create the deployment, you need to install also kubectl in your machine. So for that, you can refer to this install and setup kubectl page. I will link this in the description section. You can install the kubectl binary. So to create the deployment, you need to type the command kubectl create deployment, and the name of the deployment is going to be MySQL. And you can see that my system is already suggesting me the necessary parameters to run this command, but I will just ignore this for now and then type out the command for you. And for the deployment for the MySQL image, I have to create the MySQL deployment, I need to provide the reference to the image name. So for that, I need to use the image flag, and I'm going to provide the name of the MySQL, the Docker image for MySQL, right? So this is going to be the same as the image we have defined here inside the Docker Compose file. So I'm just going to copy this and paste it here. And after that, we also need some other additional configuration, like we are exporting the port 3306. So we also need to provide this information while creating the deployment. So for that, I'm going to type in the flag -- port is going to be 3306, and we need to run the MySQL deployment using only one replica. So we can also have, of course, multiple replicas in the production environment. We'll use multiple replicas usually, but as this is a local development environment, and we have we are working with minimal resources, because we cannot have 3 replicas for all the services, right? Because we are having more than 10 services which we want to run on our machine. So we will just, for everything, we will stick with the replicas as 1. So just for now, I'm going to provide the replicas values as 1. And what I want to do now is, I don't want to create this deployment right away, but I want to create a dry run for this, because I don't want to run this deployment and then start the installation of this deployment. I just want to do a dry run, so that I want to see if this command is working or not. So for that, I can provide this dry run flag, and I provide the value as client. So if you provide the dry run value as client, what it will do is, it will try to create the deployment, but it will not send the deployment. It will not actually create the deployment in the Kubernetes server, right? It will just validate the deployment parameters, but it will not create the deployment by sending this to the Kubernetes server. So that's why we need to use client. And finally, we need to create the manifest file for the deployment. We just do because we want to reuse this, because every time we don't want to use the kubectl command. What I want to do now is, I want to create the manifest file for MySQL deployment, right? So for that, I need to first run the deployment and do the export using the -o flag in the YAML format. So this will create the deployment, and then it will export the manifest file of deployment in the YAML format. So if I just press on enter, what it is doing is, it is trying to create the deployment in the dry run client mode. That means it validates if the deployment parameters are correct or not. So once this is done, what I'm going to do now, I'm going to copy this whole YAML file, and I'm going to open the K8 folder under the manifest infrastructure. I'm going to create a new file called as mysql.yaml, right? And here I'm going to paste in this whole this whole thing as it is. And I'm going to make some small changes here. So we can see that this creation timestamp is set as null. This is not really needed for us. I'm going to remove this particular property, and also the creation timestamp is there inside the template metadata structure. I'm also going to remove this, and also the status field is not necessary. I'm going to also remove this, and also the resources, we don't need this right now. So I did a small cleanup here, and also the strategy is not needed. So we will just provide the fields which we are using, right? We don't want to provide any of the unnecessary fields right now. So these are the bare bones. So this is the bare bones deployment for MySQL. So whenever you run a MySQL deployment, so this is the manifest file that is being created in the background and then applied to the Kubernetes server. After creating the deployment, what we have to do is we have to also create a service, right? So for that, we need to, I'm going to use the same file to store all the deployment service and all the configurations. So to also store configuration for service here, what I'm going to do is I'm going to add the three lines as separator inside YAML, and I'm going to paste in also the Kubernetes manifest file for the services, MySQL services. So for that, I'm going to go back to the terminal, and this time I'm going to create kubectl create service, and the kind of service I'm going to create is going to be a cluster IP service. So I'm going to type in cluster IP, and the name of the service is going to be MySQL, and this service is being exposed on port 3306 because the deployment container is also running on port 3306. So we will also use the service on port 3306. So for that, I'm going to provide the TCP flag as 3306 followed by 3306. So this is the pair of the ports we are exposing. So we are going to make use of the 3306 port inside the container, inside the service, and we are going to map it to the 3306 port of the local machine. So if you run this service, you can access the MySQL service on the port 3306 here. And also for this, as we did for the deployment, we also want to add the dry run flag. So the dry run flag is going to be client. And finally, we're also going to export this manifest file for the service. So if I press enter, you can see that the manifest file is created for our service. So I'm just going to copy this particular manifest file and go back to the mysql.yaml file, and I'm going to simply paste this inside the YAML file. Let's also do some cleanup here. We don't need this creation timestamp, and also the status, we don't need this. The type cluster IP is also not needed because if I remove this type as cluster IP, then the default type is always cluster IP. So you don't need to specifically mention that inside the manifest file. So also I don't need to have a port specifically. So I'm just going to remove this particular property here, and I'm just going to leave the port where the Kubernetes service is exposing the port, and also the protocol which is using, it's going to be TCP, and the target port of the service is going to be 3306. So this is the configuration also for the service, and we have the configuration for deployment. So to the next thing we have to do is we have to add some environment variables to the deployment, because if you go to the Docker Compose file, you can see that we are using an environment variable called as MySQL root password. We are setting this environment variable for our Docker service. So we also need to do this for our Kubernetes deployment for MySQL. So to do that, I'm going to go to the mysql.yaml file, and under the deployment section, under the template specs containers, I'm going to add another field just below the ports field called as env, and inside this env, I'm going to provide a key value pair. So with name as MySQL root password and value as MySQL. Right, I'm going to provide this as a string. So this is the same value I provided inside the Docker Compose file. All right, so you may have observed that we are configuring the sensitive MySQL root password inside the deployment itself. So this is not so nice. So what we can do here is, instead of defining the secret inside the deployment, we can create a separate component called as Kubernetes secrets, you can reference the Kubernetes secrets from the deployment file. So to do that, I'm going to go back to the terminal one more time, and this time I'm going to type in the command Kubernetes create secret generic, and then I'm going to create the secret with the name MySQL secrets, and I'm going to create the secret with from literal. So I want to create a secret pair. So I have the option to create the secret from a file or from a property. So I'm going to use create the secret from a property using from literal flag. So the name of the property is going to be MySQL root password, and the secret value is MySQL, right? So of course, as we did for all other components of Kubernetes, we are going to first do the dry run and export the YAML file. So I'm going to type enter, and you can see that this is the secret which is generated by Kubernetes for us. So what it did is it took this particular value and it is encoding it in the base 64 format and then providing the value of the secret here. This practice is not really 100% foolproof, but this, as we are just doing local development for Kubernetes, we will go with this approach. But in a production grade setup, we'll use another external secret store. Like if you're using AWS, you will use the AWS secret store, or maybe software like Vault, which is used to securely store secrets. So for now, we'll just make use of the Kubernetes secrets. So I'm just going to copy this particular manifest file, and I'm going to add this to the mysql.yaml file. So first I'm going to add a 3-line separator and then paste this information here. So as usual, I'm going to clean up the creation timestamp field, and we have created the secrets. Now we have to refer the deployment to this particular secret. So I can do that by removing this value field, and I can use the field called as value from, and then I can add the reference to the secret key ref property, and then the secret key ref, the key of the secret key should be MySQL root password. So you can see that is the key which you are using for the secret, and this is the value, right? So we need to provide the key for the secret, and also the name of the secret. This is going to be MySQL secrets. So if you just click on control click here, it will take this to the MySQL secrets configuration. So that means it's configured correctly, because it's the deployment is able to identify the secret and then assign it to the secret is assigned to the deployment. So this is one way of using the Kubernetes secrets. So this is one way of using Kubernetes secrets to store the secret values. And lastly, what we have to do is we have to provide also the volume information here. So you can see that whatever data which is created inside the MySQL Docker container, we are mounting it into the local folder onto the local machine under the folder data MySQL, right? So if you just expand the data in MySQL, you can see that all the metadata which is generated by the MySQL database is mounted onto this particular folder, right? So we also want to do this similar thing also in the Kubernetes world. So to do that, we have to create another component something called as persistent volume. So to create the persistent volume, unfortunately there is no command to do that. We have to type out the manifest file ourselves. So for that, I'm just going to make use of the GitHub Copilot. So I'm going to type in API version as v1, and the kind we have to create is going to be persistent volume, and the metadata field is going to be MySQL PV. This PV stands for persistent volume. And then we also have to define the specifications here. For the specification, I'm going to provide the storage class name as standard, and the access mode is going to be read write once, and the capacity, I'm going to provide this capacity of 1 GB to store the MySQL data, and the host path is going to be /data/MySQL. So just to be sure that it won't conflict with the existing storage, I'm just going to delete the data folder completely. So now when the Kubernetes deployment is running, all the data is freshly created on the host machine. So after creating a persistent volume, we also need to create a persistent volume claim. So for that, I'm just going to copy everything inside the persistent volume, and I'm going to paste this below the persistent volume, and I'm going to change the kind name as persistent volume claim, and the metadata name is going to be MySQL PVC, which stands for persistent volume claim. The storage class name is going to be standard. The access mode is going to be read write once, and here I'm going to remove these two fields which are not eligible for persistent volume claim, and I'm going to type the field called as resources, and inside here I'm going to provide the storage as 1 GB. So once this is done, this is the configuration which is needed to create a persistent volume for our MySQL database. Once this is done, this is all we need to create the deployment and the manifest the configuration for our MySQL database. There is also one thing we need to do. If I go back to the Docker Compose file, you can see that we are initializing the database with some SQL commands. So if I go to Docker MySQL, we have this init.sql file where we are creating two databases, order service and the inventory service. We also need to do this in our Kubernetes manifest. So I'm going to create a config map. So to create a config map, I'm going to add another deployment, another component inside the mysql.yaml file. So I have added the separator in the 3-line separator for YAML, and inside the API version, I'm going to provide it as v1, and the kind is going to be of type config map, and inside that I'm going to provide the metadata with the name as MySQL initdb config, and the data, it contains the actual contents of the config map. So the data is, I'm going to call it as initdb.sql, and I'm going to add a pipe which acts as a separator, and I'm going to press enter, and in here I can type the contents of the SQL file. So I'm just going to open the init.sql file, and I'm going to copy this init.sql and paste these contents here. So you can see that whenever this config map is created, it's going to run this particular commands which are there inside the initdb.sql. So we created both the config map and also the persistent volume and persistent volume claim. So the next thing is to assign these components to our deployment, right? So of course we have to reference this to our deployment so that all of them work together. So for that I need to add some configuration under the env field. I'm going to add another configuration to define a volume mount. So this volume mount specifies the path in which all the data which is generated by this container should be mounted on this particular path, right? So the path which contains the data is defined to be should be defined under the mount path section. So the path is going to be, if I refer to the Docker Compose file, this is going to be /var lib MySQL. So I'm going to go back to the deployment file, and I'm going to paste this inside the mount path, and the name of the mount, I'm going to provide it as MySQL data. This particular volume mount, we have to replicate it inside the host machine, right? So for that, I'm going to create a volume and define it under the deployment. So I have to go back to the indentation. I'm going to, under the containers section, I'm going to type in the field called as volumes, and I'm going to create a volume with the name of MySQL data. So make sure that the name of the volume mount and the volume is matching, or else we will get an error. So I'm going to type in the volume name as MySQL data, and I'm going to define a persistent volume claim, and the claim name is going to be MySQL PVC. So this should be the same name as the MySQL persistent volume claim we have created here. Make sure that you follow the same naming convention and the exact same name. So after adding this, we have defined a volume mount in the container, and we have attach that volume mount to the persistent volume claim, right? So the next thing we have to do is we also have to mount the MySQL init.sql file. So init.sql file, which is there inside our config map. So what we have to do is we just have to mount this config map, and this SQL file will automatically be available to our MySQL pod, MySQL deployment. So what I'm going to do now is I'm going to scroll up, and under the volume mounts, I'm going to create another mount path, and the mount path is going to be /docker entry point initdb.d. So this is the same path we have used inside the Docker Compose file, and the name is going to be MySQL initdb config. So the name of this volume mount should match the name of the config map here, which we have defined. So once this is done, we are done. We covered almost all the major components inside our inside Kubernetes. We have defined a deployment, we have defined a service, we defined a secret, a persistent volume claim, and also a config map, right? So this is all we need to create the manifest file to run MySQL. So what I'm going to do now is I'm going to open a terminal, and I'm going to make sure that you are inside the infrastructure folder where you have so if I just do ls, you can see that I'm inside the folder where you have this mysql.yaml file, and here I'm going to type in the command kubectl apply -f mysql.yaml, and I'm going to press on enter. So you can see that the deployment, it's throwing an error that the deployment MySQL is invalid, and it is referring to the volume mounts name MySQL initdb config is not found. So let's see what is this issue here. Okay, so I understood the issue. We have created the volume mount, but we did not create a volume to attach that volume mount. So what we have to do now is I have to create a new entry here inside the volumes, and I'm going to name it as MySQL initdb config, and here I'm going to define a config map with the name as MySQL initdb config. So in this way, the deployment will understand that it has to map this particular mount path /docker entry point db.d to the config map with the name MySQL initdb config, right? So once this is done, I'm going to go back to the terminal, and I'm going to run this command one more time, kubectl apply -f mysql.yaml, and you can see that as I've already run the command previously, all the components like service, secret, persistent volume, and claim are created, but the only thing which is not created is the deployment. So when I ran it for the second time, the deployment is created successfully, and all the other components are unchanged. So let's check if the deployment is successful or not. I'm going to run the command kubectl get all, and you can see that all the components which are created. So the first one is going to be the pod, which is nothing but a normal container which is managed by Kubernetes, and we have the services, the service MySQL, which is using a class type of cluster IP, and this is the IP address of our cluster, and it's running on port 3306. And we also have our Kubernetes cluster, which is running on port 443. We have our deployment for MySQL, and also the deployment consists of a replica set, which is created implicitly for us. So, and this is the replica set for our MySQL. So to check other components like secret, you can type it kubectl get secrets, and you can see that this is the MySQL secrets which is created. Let's also check if the config map is created. I'm going to type in kubectl get config map, and you can see this MySQL initdb config is the config map which is created. Likewise, let's check also the PVCs, kubectl get PVC, and you can see the MySQL PVC which is created. And lastly, let's also check if the persistent volume itself is created or not. And you can see that the persistent volume MySQL PV is created with 1 GB capacity, and it's bound to the MySQL PVC persistent volume claim. So now I'm going to check the logs of our MySQL deployment, MySQL pod. So for that, I'm going to type in kubectl get pods, and you have the name of the MySQL pod. I'm just going to select this and copy this, and I'm going to type in kubectl logs -f, and I'm going to paste in the name of the MySQL pod here. And if you press enter, you can see that our service is up and running without any issues. You can see that the service is running on port 3306. So I'm going to type on Control-C here to come back off the logs terminal. And what I'm going to do now is I'm going to access the service which is running on port 3306. I'm going to, if I type in the command kubectl get svc, you can see that we have a MySQL service which is running on 3306. What I'm going to do now is I'm going to access this service from my local system, right? So for that, what I have to do is I have to do a port forward from my local to the MySQL service. So I can do that by using kubectl port forward svc/MySQL, and I'm going to expose the port 3306 from local and map it to the 3306 port of the service. So if I press on enter, you can see that it is forwarding from our local host 3306 to the 3306 port of the MySQL service. Now to connect to the MySQL database, I'm going to make use of the internal MySQL database console from IntelliJ. You can also use, of course, other IDEs like MySQL Workbench or any other IDE you like. So to connect to the database, I'm going to click on the data source, MySQL, and here I'm going to provide the host name as localhost, the port as 3306. The username is going to be root, the password is MySQL, and I'm going to test the connection. And you can see that the connection is succeeded, and I'm going to click on apply and OK. And if I click on this particular service here, the databases, order service, and the inventory service are already created inside the cluster. So this is what we need. This means that the MySQL deployment is working fine and without any issues. All right, so what I did now is to create the rest of the manifest files for all our infrastructure services. So as you saw how I created the service manifest files for MySQL, so that includes the deployment, the service, the secrets, persistent volume claim, and config maps. So all these workloads quite common for all the other services also, right? For example, if you take the example of MongoDB, you can see that if I scroll all the way up, we have a deployment, which is pretty similar to how the deployment is in MySQL. So if I just split this screen into two to the right side, we can quickly verify that the deployment manifest file is looking very similar to how it is in the MongoDB, right? So the only difference here is coming in the spec containers image. Here we are defining the image as MySQL 8.3.0, but here the name is MongoDB, of course, instead of MySQL, and we have the image of MongoDB. And the container port, we have 3306 in MySQL, and in MongoDB we have the default 27017 port, and we have the environment variables, and I created a separate config file here. Here the config is coming from so here we did not create any specific config for the environment variables, but here we need a config file to store the root username. So I've created the MongoDB config here. So if I just control click on here, it is taking me to the config map, which is created for MongoDB. And here you can see that inside the config map, there are two fields, Mongo initdb root username, Mongo initdb database. So these two fields are referenced inside the environment field using this config map key ref field. I'm providing the key as the Mongo initdb root username and the name as the MongoDB config. So the deployment will now refer to the config through this name. So similarly, I also have the environment variable Mongo initdb root password, but this time instead of MongoDB config map, we are looking this up from the MongoDB secrets, which is a Kubernetes secret file, secret config. And here you can see that the MongoDB init root db password Mongo initdb root password is referenced in the deployment file. Likewise, we also have the volume mount. So inside MySQL, we are using the volume mount for the /var libmysql mount path. But here the mount path would be /data/db. This is the default path where MongoDB stores all its files. And finally, we have the persistent volume claim called as MongoDB PVC. So if I created the persistent volume claim here, and also the persistent volume MongoDB PV. And also in the host path of the persistent volume, I provided the path as /data MongoDB. So this is the place where the data will be stored. Likewise, you can go through the config files. So this is the same for Grafana, Loki, Keycloak. So we are using the same configuration here. For Keycloak, one interesting thing is previously we were reading the realm JSON file from the Docker Keycloak realm export.json. So inside the Docker compose, we were referencing this particular JSON file. If I just scroll down, we are creating the volume and then asking Docker compose to copy the JSON file which is inside Docker Keycloak realms folder into the /opt Keycloak data import folder. So we are doing that through the help of config map. So if I just scroll down here, you can see that inside the volume mount, we are referencing to the Keycloak realm, and the mount path is going to be /opt Keycloak data import. And inside the volumes, we have the same name Keycloak realm, and here we are referencing to the config map Keycloak realm config. And inside this Keycloak realm config, we have this Keycloak realm import.json, which is importing all this information of the realms. So what I did was I just pasted the whole JSON file inside the config map, so that the deployment will import this particular JSON file during the startup of the pod. So you can just go through each and every one of them. You can find the manifest files inside the GitHub repository. So just let me show you the GitHub repository. So you can find this inside the K8s folder, manifest, infra, and you can find all this manifest files. You can just go through the GitHub file and then copy each and every one and paste it into your project. So the next thing I'm going to do is to create the manifest files for our services. But before doing that, we need to make some small changes. So what are the changes? So if I go to the API gateway, source main resources, and in the application.properties, not the application.properties, but inside the logback spring.xml, you can see that we are using this URL of Loki, which is pointing to HTTP localhost 3100 /Loki/API v1 push. So we have a problem here because the URL of Loki is hard coded inside the logback spring.xml file, right? So this is not only for the API gateway project, we are doing this for also all our services like inventory service, notification order, and the product service. So what we have to do now is to externalize this property. So I can do that using so what I'm going to do now, I'm going to first delete this property here, and I'm going to create a new file, new property, spring property inside the logback spring.xml file. So I can do that by just copying this line number 4 and then pasting it here, and the name of this property is going to be Loki URL, and the source is going to be Loki.url. So I want to define a property called as Loki.url inside the application.properties file. So let me scroll down here. I'm going to type in something called as Loki URL, and here by default this is going to be the localhost 3100 Loki API v1 push. But what we will do is on the deployment level, we will override this particular environment variable with the URL of Loki, right? So that's why we have to externalize this particular URL. So we will create an environment variable called Loki.url, and then we will reference this inside the logback spring.xml. Now all we have to do is reference this particular Loki URL inside the URL tag. So for that, I'm going to type in $curly braces Loki URL. So now when the application is starting up, the logback spring.xml will look up for the Loki.url property. So we have to do this for each and every service. So let's go ahead and do that. So what I'm going to do now is I'm going to just copy this whole logback spring.xml and I'm going to apply this for inventory service first. So source main resources, logback spring.xml, and I'm going to paste it here. Next one is notification service, and I'm going to also paste it here. Next comes the order service, logback spring XML, paste it here. And finally we have the product service, source main resources, logback spring.xml, and paste it here. So now the next thing we have to do is to create this Loki.url property. So source main resources, application.properties, and then I'm going to paste this, copy this from the API gateway properties, paste it inside inventory service, notification service, order service, and finally the product service. So once this is done, now we are ready to create the manifest files, and then we will override this Loki URL. So another thing we have to do is inside the API gateway, if I open source main Java routes, and if you go to the routes class, you can see that we have also hard coded the URL of the services. So for the product service, we hard coded this URL, inside the class itself. So this is not so good. What we have to do is we want to also extract this particular service, extract this particular URL into a property. So what I'm going to do now is I'm going to create property inside source main resources application, and I'm going to call this as product.service.url equals localhost 8080. Order service URL is localhost 8081. Inventory service URL is localhost 8082. So what I'm going to do now is I'm going to reference these variables inside the routes class, right? I will do that by adding this value annotation from Spring Boot, and I'm going to call this product.service.url, and it's going to be private string product service URL. And next comes the order service URL. It's going to be private string order service URL. The last one is the inventory service URL. Let's also inject this, and once this is done, I'm going to replace all the occurrences of localhost 8080 inventory with product service URL. So this once, and here it's for the product service Swagger route. I'm going to replace it one more time. And next we have the localhost 8081. So this is going to be order service URL. So let's also replace this. And finally we have the localhost 8082. So this is going to be inventory service URL. So I'm also going to replace that. Now we don't have any hard-coded values inside our API gateway. The URLs are externalized through the properties files, and now these properties are easy to override in the deployment, Kubernetes deployment manifest files. And another last thing I want to do is I want to go open the order service, and inside the application.properties file, I want to rename the inventory.url to inventory.service.url, just because I just want to keep the naming convention similar in all the services. So for order service, it's inventory service URL, and also in the API gateway, we are using the same inventory service URL, right? So in this way, if I want to create a configuration, can create a common configuration and inside a config map, and I can reuse that configuration across all the services. So after renaming this inventory.url to inventory.service.url, the next thing I'm going to do is I'm going to replace the occurrences of inventory.url with the inventory service URL. I can do that by pressing Ctrl+Shift+R, and I'm going to search for inventory.url, and I'm going to replace all the occurrences with inventory service URL. I'm going to click on replace all and click on replace, and that's all we need to do to ready all our services to be to create the Kubernetes manifest files. Once we made all these changes, we need to build all the services, create the Docker images, and then once the Docker images are pushed into the Docker Hub, then we can start creating the manifest files for our application services. So for that, I'm just going to click on this Maven icon, click on this goal button, and then I'm going to build all the services using the command I showed you before, which is going to be Spring Boot build image, and I'm going to provide the Docker password here. So this is my Docker password. Don't worry, I will delete this password by the time the tutorial is out, so don't try to copy this. All right, so I will be back once after the build is completed. All right, so the build is now completed. All the Docker images are built and now also pushed into the Docker Hub. So the first thing before starting the Kubernetes configuration files, we will do also the create the Docker image also for our front-end application. For that, I'm going to open the front-end project, and in here I'm going to, on the front-end root project, I'm going to create a new file, and I'm going to call this Docker file. There is no easy way to use cloud native build packs for the front-end Angular application, because on our Spring Boot backend applications we can create the Docker images through the Spring Boot Maven plugin, but here the process is not so straightforward. We need to install some libraries, but instead of that, it's easier to create the Docker file and get on with it. So the first thing I'm going to do inside the Docker file is to build the Angular application. For that, we need a base image. So I'm going to type in from node 22 as build. So this is going to be, the base image is going to be from node version 22. And the next step is going to be, I'm going to create a work directory called as /app. So this is the directory in which we will store all the Angular application source code. And this is going to be our work directory. Right. So here what I'm going to do now is I'm going to copy the package package star.json into the work directory. So I'm going to copy the package.json, also add the package log.json file into the work directory, and after that I'm going to run npm install. After running npm install, I'm going to copy the whole source directory of front-end Angular, the whole directory, working directory, into the working directory of the Docker container. So I'm going to copy the whole source code into the work directory of app package. So after doing that, now I'm going to run the npm build. So by running the command npm run build, the Angular build will be triggered and all the distribution files will be created. Just as you see here, we have this distribution folder will be created, and all the distribution file are inside the browser. And after that, we have our step 2. In the stage 1 is completed here, where we are copying the source code, installing the application, and then building the application. The next step is to serve the application with the Nginx server. So for that, I'm going to use Nginx Alpine version. And from Nginx Alpine, what I'm going to do now is I'm going to copy from build /app dist frontend browser, and I'm going to copy it to user share nginx /html. So what I'm doing here is I'm creating a base image from Nginx, and inside the Nginx container, I'm going to copy the dist folder as it is, the dist browser folder, and I'm going to paste this inside the user share nginx HTML folder. So Nginx will serve all the files which are under the HTML folder. So when we copy everything inside this particular folder, when Nginx is starting up, it will automatically pick up and serve our Angular application. So that's what we are doing as part of this step. There is one more thing we have to do after creating this Docker file. We need to also create a Docker ignore file, because when we are copying the source code from this present directory to the work directory of the container, it will also copy the dist and the node modules and the .angular files, right? These should not be copied because these are auto-generated when we run npm install and npm run build. So that's why we need to ignore these three directories, right? So for that, I'm going to create a new file called as .docker ignore, and And here I'm going to add the folders.angular dist node modules. So after adding these particular files to the Docker will ignore these directories, and then copy the rest of the directories into the working app directory. So once this is done, let's open a terminal, and I'm going to build this. Make sure that you are under the front end folder, and inside the front end folder, I'm going to type in docker build -t front end dot. So it will build the Docker image with the tag of front end, and the context is going to be the present active folder. So when I press enter, so this is going to first run npm install, and after that it's now running the npm build command. And once this is done, the Docker build is completed. The next step is to tag this particular image. So by typing docker tag, the name of the image is going to be front end with the tag is latest, and I'm going to tag this with my username of the Docker Hub account. So I'm typing my username. You can also type your username as it is, which is how it is in the Docker Hub account. So my username is Upadhyayula and front end latest. So after adding this tag, now I'm going to push this particular front end image to the Docker Hub repository. So I'm going to do that by docker push front end latest, and this is going to push the image into the Docker Hub. And if I open the Docker Hub, let me show you, and you can see that the front end image is pushed less than a minute ago. That's good. So let's go back to the IDE, and now we are ready with all the Docker images of our services, starting from the front end up till the API gateway, inventory service, notification service, order, and the product service. So the next thing is creating the manifest file for our applications. So I'm going to expand this K8s folder under the manifest. I'm going to create a new directory called as applications. And inside this applications directory, I'm going to go ahead and create all the manifest files. Again, you can refer them from the GitHub project. You can go to the applications folder, and you can copy all these manifest files into your project. And once this is done, we'll start the next step, right? So make sure to do all this stuff and come back to the tutorial. All right, so I've created all the manifest files for all our services. So the first one is the API gateway manifest file, and here you can see that we have almost the same deployment configuration as the rest of the services. We have the environment variable, Spring Security, Auth2, Resource, JWT, Sure, URI, and we have created a config map called as API gateway config, and referencing this particular environment variable, and we are providing the URL of the Keycloak service here. Notice that we are providing the service name of the Kubernetes service Keycloak. So instead of just providing the name as Keycloak, I'm providing the fully qualified domain name of the service. So you need to add this to enable the service to service communication. So this is really important. You cannot just put the host name here. You need to add the fully qualified domain name of the service. This is also one important thing that we are not using. One important thing that Kubernetes has inbuilt service discovery. So when you use the fully qualified domain name, also called as FQDN, Kubernetes will do a service discovery mechanism, and it will discover the Keycloak service, and it will enable the communication between the API gateway service and the Keycloak service automatically. So that's why many of you asked why we are not using Eureka inside this project, because as we are using Kubernetes and Kubernetes has inbuilt service discovery mechanism, we are not using Eureka specifically. In the same way, we have the inventory service. There we have created also the Spring Data Source URL here. Likewise, in the notification service, we have the Spring Kafka consumer properties, registry URL property, and you can observe that there are many properties which are common across all the services, right? For example, the Loki URL, the Zipkin URL, etc. So for that, I have created a common config map called as commonconfig.yaml file, and in there I created all the common properties which are common for all the services. The first one is the Loki URL. I provided the URL of the Loki fully qualified domain name, name of the Loki service. Likewise, we have to provide the management Zipkin tracing endpoint. So this is the endpoint which each service will call to send the traces from our services to the Tempo service. So there we have provided the URL of Tempo. And finally, we have the product service, order service, and the inventory service URL with their fully qualified domain name of the services. And lastly, we also have the Spring Boot Kafka Bootstrap servers there, and there the URL is going to be the domain name of the broker service at port 29092. So this is the common config map, and the next thing we are going to look at is the front-end manifest file, the name of a front-end, and it's going to reference to the front-end image, and the container port is going to be 4200, and we are going to create a service with port 4200, and also the target port is going to be 4200. So this service is going to be cluster IP service, as similar to all the other services we are creating. The first thing now I'm going to do is I'm going to go back to the K8s folder under the manifest. So what I'm going to do now is I'm going to apply start the deployment of all the infrastructure services first. So I'm going to type in kubectl apply -f infrastructure. So what this will do is it will scan for the YAML files, Kubernetes manifest YAML files under this folder, and it's going to apply all the folders at once, right? So I'm going to press on enter, and you can see that these are config files are created. So if I say Kubernetes get pods, you can see that all the services are up and running now. You can see this as running on my machine because I've already started this pods just before starting the tutorial. But when you're running this Kubernetes apply command for the first time, it will take a lot of time for you to start the pods and change it to the running status. The containers, the pods can be in the status container creating, because the Kubernetes cluster should download each and every image, and then it should load this image and start the container, right? So that is, of course, is going to take some time. And after applying this after running this kubectl apply command, just give it this minute or two so that all the Docker files or Docker images are downloaded, and then the Docker containers will be started slowly, and then it will be in a running state. So you may face some issues with your Docker configuration. So what I meant by is, if I open the Docker dashboard and if I click on the settings on the top right side corner, can go to the resources section. So I am using a virtual disk limit of 120 GB. I think by default it will be somewhere around 16 or 8 GB. If you we don't have enough virtual disk limit, the containers will not start up. So make sure that you use some higher disk limit, virtual disk limit. So after increasing this to maybe 120 GB, you may have to restart the Docker desktop engine. And once this is done, your pods and all the services should be up and running without any issues. So you can see that I can refresh this, and you can see that all the pods are running. I don't see any errors, which is good. I can also check whether the services are created or not. I'm going to type in kubectl get service, and you can see that these are the services which are available for us. So let's check if we are able to access Keycloak or not. So what I'm going to do now is to access Keycloak at port 8080. We cannot just go to localhost 8080 because as this is a cluster IP, we cannot access the Keycloak directly. We need to do a port forwarding. right? So I'm going to open a new tab here, and I'm going to type in kubectl port forward svc/keycloak 8080, right? So what this is going to do is it's going to port forward all the requests coming onto localhost 8080 to the service Keycloak, which is running on port 8080. So if I just press enter, you can see that the requests are forwarded from localhost 8080 to the container 8080. And if I open localhost 8080, you can see the Keycloak administration URL, and I'm going to log in into this admin portal using the command, using the credentials admin, and you can see that I'm able to log in successfully. And if I click on the realm, you can see that the Spring Microservices security realm is created automatically for us. That is great. And if I click on the clients, you can see the Angular client as well as the Spring Cloud client ID. That is also good. So I'm going to click on the Spring Cloud client ID. I'm going to create credentials. I'm going to regenerate the credentials just so that the credentials are reset and working correctly. And I'm going to go to the realm settings and click on login and click on this user registration as on, so that the user registration field will be activated. Once this is done, now I'm going to go back to the other part of the terminal, and now I'm going to start the Kubernetes config file deployment for the application services. So for that, I'm going to type in kubectl apply -f applications. So this will start the deployment of all the application services. Now I can type in kubectl get pods, and you can see that this is the message you will see if the Kubernetes cluster is pulling the messages. You will see the status as container creating. It will take some time to load the Docker images. And if I try to get the pod information one more time, you can see that the images are downloaded successfully. And now let's go to the API gateway pod. Let's copy this pod name, and I'm going to type it kubectl logs -f API gateway. And you can see that the logs, the application, the API gateway application is started without any issues. That's great. Let's go and get the pod information one more time. Let's check if the product service, let's check if the notification service is up and running correctly or not. So I'm going to type in kubectl logs -f notification service. So it looks like there is also no errors inside the notification service. That's also great. And kubectl get pods. Finally, let's check if the front end is also working or not. I'm going to copy kubectl logs -f front end, and you can see there are also no errors. So I'm going to come out of the console, and the first thing we are going to do now is I want to access the front end on port 4200. So to access front end on port 4200, I need to create a port forward from my local host to the 4200 post of the front end service. So I'm going to create a new terminal here, and I'm going to type in kubectl port forward svc/front end, and I'm going to forward 4200 with the 4200 of the port. And also the port forwarding is now working. Let's open a new browser, and I'm going to type in localhost 4200, and we are getting a connection refused error. All right, so I figured out the error. So as Nginx is running by default on port 80, we are using the port 4200 for the front-end application, which is wrong. So what I did was I changed the container port to 80 for the front end from 4200. And when I restarted the service, and I'm now forwarding the port for front-end service from the localhost 4200 to the localhost to the port 80 of the front-end service. So now I'm able to access the application on localhost 4200. So, and if you, let's click on login and see what's happening. And now let's click on login and see what's happening. and you can see that nothing is happening here. So let's go ahead and inspect the logs here in the developer console. And you can see that we are getting an error. If I go to the network tab, if I click on login, you can see that we are getting a connection refused error. That is because our auth configuration is referring to localhost 8181. The Keycloak is not running on port 8181 on localhost, but it is running on a different service, right? So what we have to do now is we have to update the auth config of the front-end service. So I'm going to open the IDE now, and let's open the front-end project, and let's go to source app config auth config.ts, and in the authority URL I'm going to replace the localhost 8181 with keycloak.default default svc cluster local 8080. So because this is the URL where we are running Keycloak service, so to apply these changes, I'm going to first stop this port forwarding, and I'm going to go back to the front-end folder. I'm going to cd into front-end, and now I'm going to build the Docker image one more time. So once the Docker build is completed, I'm going to type docker tag front-end latest, and I'm going to tag this particular image again. And once this is done, I'm going to push this to the Docker Hub. So once this is done, I'm going to delete the existing deployment of the front end. So for that, I'm going to go back to the K8 folder, manifest, applications, and here I'm going to type in kubectl delete -f frontend.yaml. So that will delete the deployment as well as the service for the front-end application. And I'm going to type in again kubectl apply -f frontend.yaml. So what this will do now is it will freshly download the Docker image one more time, and it will start the deployment of our front-end application. So I can type in kubectl get pods, and you can see that the front-end is now up and running again. That's good. Now I'm going to type in kubectl port forward service front-end localhost 4200 to 80. Now this is done. What I'm going to do now again is I'm going to create a new tab, and here I'm going to port forward for the API gateway, because we need to have communication with the API gateway as well. So I'm going to type in kubectl port forward svc / API gateway 9000. And lastly, we will also create a kubectl port forward for Grafana to test if the Grafana logs, the logs, traces, and monitoring is working or not. So for that, I'm going to create a new tab, and I'm going to type in kubectl port forward svc / Grafana on port 3000. So let's go ahead and start our testing. So first of all, I'm going to click on login here. So I'm going to refresh the application. So if you are, so make sure, so after the deployment, make sure to long press on the refresh button, and you can see this normal reload and hard reload. So what I'm going to do now, I'm going to click on empty cache and do the hard reload. So this will delete the old JavaScript files, and it will fetch it newly from the Docker container. So now I'm going to click on login, and this will redirect to our Keycloak default svc cluster.local 8080. So this will only work if you have updated your etc host information with the Keycloak default svc cluster local. So what I meant by that is, I will show you. I'm going to open a new terminal, and I'm going to open vi/etc/host, and you can see that I've added an entry which is pointing the domain of Keycloak default svc cluster local to my local host. So whenever the browser is looking at this particular domain name, it is looking at the DNS entry inside the etc host file. So after adding this particular entry, our browser will automatically recognize that it should take this domain name and it should forward it to the local host, as we already have the port forwarding active for this particular Keycloak instance. Now it's able to, that's why it is able to forward to the Keycloak admin console. I have to first register for the new user. So I'm going to call this user as test user. Password is going to be test user. Again, I'm going to confirm this password. Email is testuser@gmail.com. First name is test, last name is user. Click on register. So now the user is logged in successfully. So now what I'm going to do is I'm going to create a new product. So I'm going to click on new product and I'm going to type in iPhone_15 as the SKU code. The name is going to be iPhone 15. The description is iPhone 15. The price is 1000. And I'm going to click on add product. And you can see that the product is created successfully. This is the result coming in from our API gateway. And let's click on the Spring Boot Microservices shop URL here. And this is getting the products from the product service. That's good. So now what I'm going to do now is add the quantity as 1 and click on order now. And it will take some time, and then you can see the message order placed successfully. So now let's check if the email, we have received an email or not in our Mailtrap mailbox. I'm going to search for Mailtrap, and inside the demo inbox, I can see that a few seconds ago, I received an email. Your order with order number is now placed successfully, right? So that means all our services, API gateway, product service, order service, and the inventory service, and last the notification service are working as expected. So the last thing I have to do now is to check if the Grafana dashboards are working or not. So I'm going to open localhost 3000, and this is the portal of Grafana. And here onto the top right side corner under the toggle menu, I'm going to click on explore here, and you can see that it is already showing us all the traces inside tempo. And now let's go to Loki here, and inside the Loki I'm going to select the label as application. Inside the value I'm going to select the value as API gateway and click on run query, and you can see that we can see the logs. That's great. And if I go to the trace, the tempo, I can also see the trace information here. If I run the query, you can see that I can see all the traces information. That's also good. If I go to Prometheus, I can also see the Prometheus metrics. So here I have to select the application label and also the inventory service. If I click on run service, you can see these are the Prometheus results which are scraped from our service. And one thing I forgot to mention is inside the Prometheus configuration, you need to make one small change, because in the previous observability part, what I showed you is in the prometheus.yaml file, we are in the scrape config, we are providing the target as host.docker.internal and the port as 9000. But here there is no need to do that. I'm going to open the K8's infrastructure and prometheus.yaml, and here you can see that I'm providing directly the fully qualified domain name of the service itself followed by the port. So in this way there is no need to refer to the host.docker.internal. The Prometheus can directly access the service name of the API gateway and all other services. So that's why you can also see that it's able to provide you the name of the service as it is. And lastly, we have to also check the Grafana dashboards. So I'm going to click on dashboards, and as this is a new installation, I have to import the Grafana dashboard one more time here. I'm going to click on new. I'm going to click on import, and here I'm going to import the dashboard JSON file. So I'm going to copy this from the Docker folder under Grafana dashboard.json. I'm going to copy this and I'm going to paste this inside the import via panel, and I'm going to click on load, right? The name is going to be Spring Boot Statistics. The Prometheus data source, if I click on the drop down, it can see that it's already referring to the Prometheus data source, which we have configured through the config map. So I'm going to select this Prometheus data source and I'm going to click on import. And you can see that the Prometheus data source is already reflecting inside the Grafana dashboard. And if I click on the instance, you can see that we have API gateway instance, inventory service, notification service, order service, and the product service. So we can see that the notification service is up from 19 minutes. It's using 3.5% of the heap memory. The CPU usage you can see here. Likewise, we have the order service. It's running from 19 minutes. The inventory service is also running from 19 minutes, and the product service also we are able to see the statistics here, and also the API gateway, we are also able to see the statistics. So I hope you are able to learn something from this tutorial series. It's been a long series, I have to admit, and I hope this is helpful for you, and I will see you in the next video. And until then, happy coding techies.